Okay, students, so let's get started with A2 Physics syllabus revision. This will be a two-part video. In the first part, we will be covering from chapter 1 till chapter 7, and in the second part, we will be covering from chapter 8 till chapter 14. Make sure you have kept your phones away, you have grabbed a pen and a register to copy stuff, timestamps are there. All the notes, formula sheet, definitions, graphs, revision papers are in the link in the description. Guest paper will be posted one day before the examination. So let's get started with the revision. Now let's start with the first chapter, that is of circular motion. Okay. In circular motion, the first thing that you need to study is about displacement. The first thing that you need to study is about displacement. Displacement are of two types. There are two types of displacements. And maths students will know what are the two types of displacements: linear displacements and angular displacements. There are two types of displacements that you need to study: linear displacements and angular displacement. Linear displacements are represented with a symbol of what? With a symbol of S. Angular displacements are represented with a symbol of theta. Now, please, one more important thing in this class. Silly questions are encouraged over intelligent questions. Okay, so no need to hesitate while asking questions. And second of all, no need to copy while I'm explaining. You will be provided with the recorded lectures. No need to copy. Just look at the board. Just understand the concepts. Let's say this is a circle. And let's say you are standing in the middle of the circle. Okay, this is your center of the circle. Let's say this is your point A. You are standing here. Let's say this is a circle, this is a playground. You are standing at point A. You go from point A to point B like this. You go from point A to point B like this. The distance covered in the yellow, the distance that I have highlighted in the yellow, the distance covered in the yellow is known as what? Linear displacement S. The curve of the circles, or the distance covered when you are moving on a circle from A to B, is known as linear displacement. Sir, what is angular displacement? The angle covered as you move from A to B. The angle covered as you move from A to B is known as theta, or angular displacement. The distance covered as you move from A to B on a circle is known as your linear displacement. And the angle covered as you move from A to B on a circle is known as your angular displacement. So you can write the definition, you can here write the definition of linear displacements like this. Linear displacement is basically the length of the curved track when a body is moving in a circle. Linear displacement is basically the length of the curved track when a body is moving in a circle. Simple. And what will be the definition of angular displacement? One second. किसका सवाल है? Sir, is it linear straight? Okay. A very repetitive question. Yes, I agree. From mathematics, you have studied that linear things might be straight. But here we are using linear displacement to describe the motion in a circle. The length of the path. Can you see this? The length. Length covers your linear wala factor. Length of the path is basically the linear displacement. Length of the curved track. This curved track here is known as your linear displacement, not the straight lines. Secondly, how will you define angular displacement? How will you define angular displacement? Since you have studied angular displacement as well, angular displacement is the angle covered at the center of the circle when you are moving from point A to B. So what will be your definition of angular displacement? The angle subtended by a body as it moves in a circle. This is your definition for angular displacement. Simple as that. Now, when scientists divided angular displacement and linear displacement into two different things, like let's say linear displacement is the length of the track covered and angular displacement is the angle covered. Is this clear up till now? There is also a relationship between S, that is the linear displacement, and theta, that is the angular displacement. There is also a relationship. There is something that connect both of these values. S is equals to R theta. What is S? What is S? Very good, Nimra. Very good. S is equals to R theta. What is S? S is your linear displacement. What is your theta? Theta is your angular displacement. What is your R? R is your radius. Now, sir, what is radius? Radius is the length of the path from the center of the circle to the circumference. This is radius R. This is also radius R. The length of the path from the center of the circle to the circumference is known as what? Radius. Linear displacement is measured in the units of meter, radius is measured in the units of meter, and angular displacement is measured in the units of radians. We will come on to the units of angular displacement. Just tell me for now, is everything clear up till now? Sir, the S is equal to R theta is the derivation for it. Yeah, Ramsha, very good. Yeah, you can say that. Any ambiguities here? If this is clear, just give me a thumbs up. You can give a just thumbs up. There are emoticons on Zoom. You can just give a thumbs up if you are too tired to type in the chat. Is everything clear? Yes. Should we move forward? Okay. Let's move forward. If everything is clear, let's move forward. Now, one second. Sir, एक दफा repeat कर दें please. Okay. So let me repeat it. So there are two types of displacement. Since a student has asked to repeat it, it will be beneficial for all of you to go through it again. There are two types of displacement, linear displacements and angular displacements. What are linear displacements? When you are moving on a circle from one point to another, from A to B, on the curved track. When you are traveling on the curved track on a circle, that is known as the linear displacement. When you are covering an angle on the center of the circle as you move from point A to B, that is known as your angular displacement. This S is equals to R theta is an equation used to relate what? S, that is your linear displacement, with the theta, that is your angular displacement. R is your radius measured in meters. R is your radius measured in meters. Simple as that. Okay. Now let's further move ahead. Now let's say, please pay attention. This is very important for students who are not taking maths. For students who are not taking maths, this is really important for you guys. Let's say this angle is 60 degree and the radius is 2 meters. You have to calculate S. You have to calculate S. How will you calculate S? A student with a non-math background will say S is equals to R theta, R is 2, theta is 60, S is equals to 120 meters. This is completely wrong. Completely wrong. Always remember that this theta, that this angular displacement will always be in the units of radians. Now, what are radians, sir? What are radians? You might ask me. Let's suppose you haven't studied AS physics or mathematics. You will ask me, sir, what are radians? 180 degree is equals to pi radians. 180 degree is equals to pi radians. Degrees and radians are two units to represent angular displacement. But in A2 physics, we will always take angular displacement in radians. We will always take angular displacement in radians. Please remember that. Now, your next question might be how to convert degrees into radians. How to convert degrees into radians? Let's say you have 60 degrees. How will you convert it into radians? Very, very easy. To convert degrees into radians, what do? You multiply by pi upon 180. If I multiply 60 by what? If I multiply 60 by pi over 180, this will become what? 1 over 3. This becomes pi over 3 radians. So always remember, if you have to convert degrees into radians, you multiply it by pi over 180. Here, my degrees are given. I will multiply it by what? Pi over 180 to convert it into radians. This becomes 1, this becomes 3. Pi over 3 is your theta. What is your S? What is your R? 2. S will be equal to what? 2 into pi over 3. That is equals to 2 pi over 3 meters is your linear displacement. Any ambiguities here? You can ask if you have any questions here. Now, let's move on to velocities. Let's move on to velocity. Sir, theta should always be in radians. Yes, beta, I am again and again restating this fact that theta should always be in radians. Angular displacement should always, always, always be in radians. Now, once we have studied displacement, let's move on to velocity. Let's move on to velocity. Velocity is of two types as well. Velocity is of two types as well. Can anyone guess what will be the two types of velocities? Can any genius in the chat tell me what will be the two types of velocities? Yes. The two types of velocities will be what? Linear velocity V, and angular velocity W. The two types of velocities will be linear velocity V and angular velocity W. Simple as that, linear and angular. Yes, very good, Nimra and Meera. If your displacements were of two types, linear and angular, obviously your velocities will be of two types, that is linear and angular. Now, sir, what is the definition of linear velocity? What is the definition of linear velocity? Very, very easy. Rate of change of linear displacement. What is the definition of linear velocity? Rate of change of linear displacement about a point. The more important thing in circular motion is to know the direction of linear velocity. Please, please, please remember this. The more important thing in circular motion is to remember the direction of linear velocity. Linear velocity will always be a tangent to the circle. Linear velocity will always be a tangent to the circle like this. Like this. Linear velocity will always be a tangent to the circle. Always. Please, please remember this. Linear velocity will always be a tangent to the circle. And what will be the units of linear velocity? What will be the units of linear velocity? The SI units of linear velocity will be what? ms minus 1. 1 second. Who has arrived itna late? Chalo. Very, very late, yeah. This is a very late time to arrive. This will not be tolerable. This is bad. If you come in middle of the lecture, that's very bad. Linear velocity is rate of change of linear displacement about a point. Okay. And you need to remember that the direction of linear velocity is tangent to the direction of the circular track. The direction of linear velocity is tangent to the direction of the circular track. Now let's come on to angular velocity, that is W. Can any genius guess what will be the definition of angular velocity? The definition of angular velocity is very easy. The rate of change of angular displacement about a point. W will have a formula of what? Theta over t. Now, why did I wrote theta over t? Because W is equals to rate of change of angular displacement about a point, theta over t. Okay. But let me give you a surprise. This formula of theta over 2 is rarely used. It is rarely used. Then your question might be, sir, which formula of W is used then? If not this, then what? Because this satisfies the equation. We go just a bit deeper, and just a bit common sense more. Let's say this is a circle. Let's say this is your center point. And let's say you have started your rotation. Let's say you have started your rotation from point A. Let's say you have started your rotation. Sir, will the unit be radians per second? Yes. I will come to the units as well. Yes, you can write here. The SI units will be radians per second. Okay. Let's say I have started my rotation at point A. Just please pay close attention. I need full focus here. कोई भी copy ना करे भी. Just focus on the board. Let's say you are starting from point A and you have rotated a complete circle like this. You have started from position A and you have rotated a complete circle like this. Let's say this becomes your final point A prime. Can you tell me how much angle would we have covered throughout this entire rotation? Could you tell me how much angle would we have covered throughout this entire rotation? Very good, Nimra. But let's also make it more basic. The complete angle in a circle is 360 degree. And we have studied that theta will always be in radians. So 360 into pi over 180. This becomes 2, this becomes 1. 2 pi is the number of radians covered in a complete rotation. Okay. So W can be written like this. W is equals to 2 pi divided by what? Now, can you guys tell me what was the time taken to complete one rotation called in AS? If I asked you that the time taken for one rotation to complete was equals to what? बेटा ये किस चीज की डेफिनेशन है? Time taken to complete one oscillation or one rotation. One rotation is the definition of which quantity in AS? Can anyone tell me? No, Meerab. This is the definition of time period. The time taken to complete one oscillation was the definition of what? Time period. Here you can see we have started at point A, we have come towards point A prime, we have completed an entire rotation. So this time t will be what? This time t will become capital T, that is the time period. This is your formula for W that is frequently used. This is your formula for W that is frequently used. T is your time period. T is your time period. Please put it inside a box. इसको इस inside a box put कर दो. Let me give you a bad news. There are 3 formulas for W in A2 physics. There are 3 formulas for angular velocity in A2 physics. You have just studied one of them. What about a small t? Beta, we usually don't use a small t. In A2 physics, we don't use this formula. See, I have written here. This formula is perfectly correct, but it is rarely used. This formula is perfectly correct, but it is rarely used, so I have left that out. The first formula for W is what? 2 pi over capital T, that is your time period. Now, very good, Meera. If you have studied AS physics, you might know that this can be written like this. Even if you have studied O level physics, let alone AS physics, 1 over T will be equal to what? 1 over T will be equal to frequency. W is equals to 2 pi F. This is your second formula for W. This is your second formula for W. Now let's come on to the third formula of W. This will require some brains. Please focus on the board. This will require some brains. Now, can you guys tell me what is frequency? Can you guys tell me what is frequency? Revolutions per second. I am introducing another term here. I am introducing another term here. Revolutions per minute. I am introducing another term here, revolutions per minute, that is RPM, represented with a symbol of capital N. Now let me give you an example. Let's say a clock rotates 2 times per second. Let's say a clock or a fan rotates 2 times per second. How many times will it rotate per minute? How many times? Sir, revolutions, oscillations, same thing. Yes, revolutions, oscillations, same thing. Let's say a clock or a fan is rotating 2 times per second. Can any genius tell me in the chat how many revolutions or oscillation will it perform in 1 minute? 2 multiplied by 60. Why? Because there are 60 seconds in 1 minute. Your revolutions will become 120. So if a fan is performing 2 revolutions in 1 second, frequency is 2. Your RPM will be what? 2 multiplied by 60, because RPM is revolutions per minute. You multiply your frequency by 60, you will get your RPM. Remember this. So can I journalize this formula like this? Frequency multiplied by 60 is equals to your RPM. Can I journalize this formula like this? Is everyone with me up till here? Now, if I make frequency the subject here, frequency will be equal to n over 60. Can I substitute this n over 60 in place of this frequency? Yes, this will give me my third formula of W. That is, W is equals to 2 pi n over 60. Simple as that. Are these three formulas clear to all of you? Any ambiguities you can ask me right now. Any ambiguities to anyone, they can ask me right now. Yes, yes, yes. Ask away. The floor is open for you. If it is clear, you can give a thumbs up in the chat. Clear? Very good. Very good if it is clear to you. You can give a thumbs up in the chat if it is clear to you. If not, you can ask me any question that you like in the chat, obviously. All clear? Let's further move ahead. Let's move ahead. Now, there is a formula that relates a relationship between velocity, between linear velocity and angular velocity. Now, scientists have also discovered a relationship between linear velocity and angular velocity. Sir, what is that relationship? Let's see that. V is equals to RW. V is equals to RW. What is V? What is V? V is your linear velocity. That is measured in the units of what? V is the linear velocity that is measured in the units of ms minus 1. R is your radius, measured in the units of meters. W is your angular velocity, measured in the units of what? Radians per second. This is all that you need to know about velocities and displacements. Now, let's write down a new heading of centripetal acceleration. Let's write down a new heading of centripetal acceleration. The centripetal acceleration is represented with a symbol of A subscript C. Centripetal acceleration is represented with a symbol of what? A subscript C. Okay, if centripetal acceleration is represented with a symbol of A subscript C, so what is the definition of centripetal acceleration? Very, very, very easy. The rate of change of linear velocity is known as centripetal acceleration. The rate of change of linear velocity about a point is known as centripetal acceleration. Now, since you guys are my students, let me give you a magic trick here. Centripetal acceleration has three formulas, but you only have to remember one. Centripetal acceleration has three formulas, but you only have to remember one. Centripetal acceleration is represented with the formula of VW. What is V? V is your linear velocity. Ms minus 1. W is your angular velocity, that is in the units of radians second minus 1. Now, if you open any physics book, they will tell you to remember three formulas for centripetal acceleration. But you only need to remember one. The second and third formula are literally a piece of cake if you have a conscious mind. The second formula for centripetal acceleration can be calculated if you remember V is equals to RW. Instead of this V, if you substitute RW, you will get the second formula for centripetal acceleration. That is equals to what? RW into W. Centripetal acceleration is equals to RW square. Let's move on to the third formula for centripetal acceleration. Centripetal acceleration is equals to VW. Now let's say instead of substituting V, I substitute W. Let's say instead of substituting V, I substitute W. V over R is equals to W. Centripetal acceleration is equals to what? V multiplied by V over R, because instead of W, now I have substituted V over R. My centripetal acceleration becomes what? V square over R. This is what my centripetal acceleration becomes. Simple as that. So now you have three formulas for centripetal acceleration. One is centripetal acceleration is equals to VW. The other formula is centripetal acceleration is equals to RW square. The third formula is centripetal acceleration is equals to V square upon R. Any ambiguities up till now? If you have any questions in this lecture, tell me. If you have any questions up till now, tell me. Now, if you have no questions, let's study about the direction of centripetal force. Let's see where the direction of centripetal force will be directed. Direction of centripetal force. What will be the, direction of centripetal acceleration, not force. We haven't studied force up till now. What will be the direction of centripetal acceleration? Have you guys studied this in O levels? Towards the center, towards the center. Very good. Inwards भी सही कह रहे हो. जो inwards कह रहा है वो भी सही कह रहा है. Towards the center वाले भी सही कह रहे हैं. The direction of centripetal acceleration will be towards the center. It will act towards the center. Sir, what do you mean by towards the center? By towards the center, I mean this. Centripetal acceleration is acting inward. Here, towards the circle. Now, once you know the direction of centripetal acceleration, you can easily answer this exam question. Define circular motion. In recent times, examiner has asked you to define circular motion for 2 marks. How will you approach this question? You know two things about circular motion. In a circular motion, the centripetal acceleration acts towards the center and the linear velocity is tangent. In a circular motion, the acceleration acts towards the center and the linear velocity is tangent. So if I have to define circular motion, I will say what? A motion in which velocity is perpendicular to acceleration. A motion in which velocity is perpendicular to acceleration. The angle between velocity and acceleration is 90 degrees. Simple as that. Now, let's write down a fresh heading of centripetal force. Now, let's write down a fresh heading of centripetal force. Centripetal force can be defined as the resultant force that causes an object to rotate in a circle. Centripetal force can be defined as the amount of force required to rotate an object in a circle. Sir, do we mention speed is constant? No, you don't mention speed is constant. Ramsha, I will come to that. जब हम past paper question करेंगे ना इस तरह का, I will tell you why. I know which past paper question you are talking about. Okay. Let me discuss it. Let me discuss it here. See. The examiner is getting trickier day by day. If he is only asking for circular motion, you will write this definition. If the examiner is saying uniform circular motion, then what you will write? If the examiner is asking you to define uniform circular motion, you will write this: a motion in which velocity is perpendicular to acceleration. And your second point will be what? Speed is constant. If the examiner is specifically asking you for uniform circular motion, then you will say speed is constant. If he is only asking for circular motion, you will never mention speed is constant. Is this difference clear to you guys between circular? Now we were discussing about centripetal forces. What is a centripetal force? A centripetal force is a force that causes an object to move in a circle. A centripetal force is a force that causes an object to move in a circle. Now, if you pick up any textbook for A-level physics, you will find 3 formulas for centripetal force. But you don't need to remember any one of them if you are slightly good at physics. If you are good at base level physics, you don't even need to remember any one of them. Now, sir, why do you say that? Peter, do you know this equation F is equals to ma? Do you remember this equation from primary level physics? F is equals to ma? Yes. To calculate centripetal forces formula, what will you do? You will multiply mass with all of these acceleration ke formulas. To calculate the force formulas, you will multiply masses with all of these acceleration formulas. What is the first formula for centripetal acceleration? VW. So what will be the first formula for centripetal force? M V W. What is the second formula for centripetal acceleration? RW square. So what will be the second formula for centripetal force? MRW square. What is the third formula for centripetal acceleration? V square over R. What will be the third formula for force? MV square over R. Simple as that. Simple logic, nothing complicated. Any ambiguities here? Clear? Okay, perfect. If still it's confusing, you can ask me. Now let's further move ahead. Now let's further investigate centripetal forces. Okay. There are some examples of centripetal forces that you must know for A2 physics. There are some examples of centripetal forces that you must know for A2 physics. Let me bring in the list of those examples. Let me bring in the list of those examples. Stone and rope, planetary motion, charged particles in a magnetic field. All of these are examples that we will be studying across multiple chapters. Tension in rope will be studied in chapter number 1. Centripetal force is a topic that will be studied multiple times in A2. Planetary motion is something that we will study in chapter number 2. Charged particles in a magnetic field is something that we will be studying in chapter number 8. Car moving around a road is something that we will study now, and bucket full of water is something that we will study now. Let's start with this example, tension in a rope. Let's start with this example, tension in a rope. Let's write down the heading of stone moving in a horizontal circle. Let's write down the heading of stone moving in a horizontal circle. Please, please, please pay attention. There is no need to hurry up. There is no need to copy things. Just see what is happening. Let's say you have a stone that is tied to the rope here, and you are moving it in a circular motion like this. And you are moving it in a circular motion like this. Simple. Like this. Can you see the blue colored region that I am making? This is how the stone is moving. Due to the movement of this stone, there is a tension that is getting developed here. There is a tension that is getting developed here, that is T. This tension T is making an angle of theta. This tension T is making an angle of theta with the vertical. Can I resolve these tension forces? Can I resolve these tension forces? Yes. This tension will be equal to T sine theta, and this upward force will be equal to T cos theta. Simple as that. The tension component along this line will be equal to T sine theta, and along this line will be equal to T cos theta. If someone is confused, how did I resolve it? It's very, very easy. Can you see tension is acting like this? This is your angle theta. This is your angle theta. Your vertical component will become like this. That is T sine theta. That is here T sine theta. And your horizontal component of this triangle will become T cos theta. Simple as that. Nothing complicated here. Now, let's further observe this motion. Weight is acting downwards and centripetal force is made away from the circle. Now, this will raise some eyebrows. Sir, why have you marked centripetal force away from the circle? Centripetal force हो ही नहीं सकती away from the circle. How have you marked centripetal force away from the circle? So here is something that is very A2 specific. This is only done in A2 physics. This is only done in A2 physics. Please remember this. The direction of centripetal force. Now, please, 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 these are some very detailed points that nobody pays attention to. The direction of centripetal force in A2 physics in theory is towards the center. If the examiner is asking you in theory, where is the direction of centripetal force? You will say towards the center. However, when you are marking it on a diagram, however, if you are marking it in a diagram, you will always mark centripetal force away from the circle. Now, sir, why do we do this? To make calculations easy. To make calculations easy. The only reason to do this is to make calculations easy. Nothing more. Please, please, please understand this fact that centripetal force direction according to theory is towards the center. And if you want to mark the direction of centripetal force on the diagram, then it will be away from the circle. Will you guys remember this? Give me a yes or a no in the chat. Do you understand this? Will you guys remember this? Now let's say the stone is moving in a horizontal circle. We have marked the centripetal force away from the circle. The tension is divided into two components. The weight is acting downwards. Now, if you can closely observe, the centripetal force is equal to T sine theta. And the weight will be equal to what? Weight will be equal to T cos theta. Is this clear to everyone up till now? अभी तक lecture clear है बेटा? Any questions? Just give me a thumbs up. If everything is clear, then we move ahead. Then I will show you one more magic trick here. There is one more magic trick left in the bag for this question. All clear? 1 second, let me see. Okay. Now here, can you see I have marked the centripetal force away from the center? The tension ka component that is acting towards the center is T sine theta. Centripetal force is equal to T sine theta. Weight is acting downward, T cos theta is acting upward, weight is equal to T cos theta. Now let me show you another magic trick. You can combine equation 1 and 2 very easily. And this is a trick for every A2 question like this. Whenever you have two equations, two simultaneous equations, one in cos and one in sine, you can combine them into one. Whenever you have two simultaneous equations, one in cos theta, one in sine theta, you can combine them into one. In terms of tan, very good Nimra, very good. आज कुछ लोग पढ़ के आए हैं, that's very good. That's really good to see. What we will do, we will divide equation 2 by equation 1. What is my equation 2? This. Equation 1 is this. Fc is equals to T sine theta divided by W divided by T cos theta. Okay, 1 second. I think I divide equation 1 by equation 2. I have divided the first equation, that is centripetal force is equals to T sine theta by W is equals to T cos theta. Now, if you are good at mathematics, you will realize tension and tension cancel out. Sine theta over cos theta is equals to which identity? Tan theta. Centripetal force over weight is equals to tan theta. Centripetal force is equals to W tan theta. This is your final equation if you want to express it in a singular equation. Centripetal motion in a circular direction, or you can say stone moving in a vertical circle. Now, believe me, this is the most important thing that you will study in circular motion. A stone in a vertical circle. A stone in a vertical circle. Please, please, please pay attention. There is no need to copy. Obviously, you will be given the notes, you will be given the lectures. Let's say the stone is moving like this. This is your stone, and it is moving in a circle. It is moving in a circle. First of all, let's see 4 points, 4 specific points on a circle. 1, 2, 3, and 4. 1, 2, 3, and 4. Let's say this stone is attached with a string. Please pay attention. No need to copy. I am again and again repeating it. Koi copy na kare bhi. Let's say you have strings like this. Okay, this is the same string but at different locations. Something like this. Okay, let's draw it in a very precise manner. Okay. So first of all, let's visualize position 3. Let's visualize position 3. Okay, just look at what is happening at position 3. First of all, if your stone is moving in a circular motion, or anything is moving in a circular motion, which force will act? Centripetal force. That will act away like this. The centripetal force will act away like this. Okay. And if you have studied even the slightest of O levels or AS physics, you will know that an other force will also act downward. That will be known as weight. Two forces are acting downward. Will there be any force that is acting upward? Yes. Since this is a string, there will be a tension in the string. Upward force is equals to downward forces. Tension at point 3 is equals to the weight plus the centripetal force. Now, let's examine position 3. At position 3, your weight is acting downward. Like this. Again, you are moving in a circle. So, centripetal force will act away like this. And your tension will act away from the stone like this. So, here, the tension 2 plus weight is equals to the centripetal force. Tension 2 is the tension at tension 1. Let's say this is tension 1, this is tension 3. I have just subscribed the tension so that you know कौन से point की tension की बात हो रही है. This is tension 1. Tension 1 is equals to the centripetal force minus weight. Please don't copy. An important point is about to come. Just pay attention on your screens. Now look at point 4. At point 4, the tension will be away like this. Where will the centripetal force act? The centripetal force will be somewhere here. Where will the weight act? Downward like this. Here the weight at point 4. Tension at point 4 is equals to the centripetal force. Now please pay attention on the screen. If you see, the tension at point 1 is the least. You have least tension at point 1. Why? Because you are subtracting your weight from the centripetal force. So your tension at point 1 will be the least. You will have least amount of tension at point 1. However, at position 3, can you see weight is getting added to centripetal force? So the tension will be greatest at this point. Now, why is this useful for you guys? Why is this useful for you guys in A2 physics in real lives? Because this tells us in A2 physics in real life, this tells us that if a string, if a string snaps, if a string snaps or breaks, it will be at point 3. Why have I written this point? If a string breaks or snaps, it will be at point 3. Why? Because the tension at point 3 is the greatest. And this position 4 is exactly replicated at position 2. Position 2 will also have the same features. Tension 2, and here the centripetal force will be like this. Tension 2 is equals to the centripetal force. Any ambiguities in this entire motion? Any ambiguities here? Yes, tell me. Newton's law of gravitation basically states that the force of attraction between any 2 point masses is directly proportional to the product of masses and inversely proportional to the square of separation between them. Okay. I can write these two quantities together as well. The Newton's force of attraction is directly proportional to m1 m2 divided by r square. Now, from basic physics, we know that whenever we remove direct proportionality sign, we get a constant, that is capital G in this case, m1, m2 divided by r square. This is your Newton's law of gravitation, where F is your force of gravitation measured in Newtons, force of gravitation measured in Newtons. Capital G is your gravitation constant. That is what? Yes, does anyone remember the value of gravitation constant? 6.67 into 10 raised to the power of minus 11. What is your value of m1? Mass of planet 1 or object 1. What is m2? Mass of object 2. What is r? Separation between the two objects. Separation between the objects. Simple as that. Okay, let's further move ahead. Now, now let's continue forward. Let's continue forward. Let's say, let's say you are a person. You are a person that is standing at the surface of the earth. Let's say you are standing at the surface of the earth. Your mass is 70 kg. Let's say this is the earth. You are standing here with a mass of 70 kg. What will be the force of gravitation on you? What will be the force of gravitation on you? Can you calculate the force of gravitation on yourself? Yes. F is equals to capital G, capital M, small m divided by r square. Capital G is what? 6.67 into 10 raised to the power of minus 11. Capital M is what? The mass of the planet. 5.99 into 10 raised to the power of 24. Multiplied by the small mass, that is 70 kg. Divided by the separation. Divided by the separation between you and the earth. What will be the separation between you and the earth? The radius of the earth. That is 6.4 into 10 raised to the power of 6 whole square. What does the force of gravitation come out to be? Can anyone calculate it? What does the force of gravitation come out to be? Can anyone calculate it? The force of gravitation comes out to be 683 newtons. If you are standing on the earth's surface and you need to calculate the force of gravitation on yourself, you will apply this formula. You will apply this technique. But, sir, what is so interesting about it? Now, if you calculate the weight here, that is mass into 9.81, this will give you a value of 687 Newton. Weight and gravitational force are almost equal when you are at the Earth's surface. This is the key point that you need to remember. Weight and gravitational force are almost equal when you are at the Earth's surface. Simple as that. When you are at the Earth's surface, the weight and the gravitational force are equal to each other. Please remember this. Don't forget it. Okay. Now let's further move ahead. Now let's plot a graph. Let's plot a graph of force versus. Let's plot a graph of gravitational force versus the separation, that is R. Are there any questions up till now in this entire explanation? Anything that you guys feel confusing? I hope there are none. If there are any questions, you can ask me. Now, let's plot a graph of gravitational force versus radius. How will we plot a graph of gravitational force versus radius? Very, very easy. First of all, examine the formula. The gravitational force is equal to what? Capital G, capital M, small m divided by R square. If you can notice, force and radius are what? Force and radius are what? Inversely proportional. If you can notice, force and radius are what? Inversely proportional. But this inverse relation is slightly unique. Why? Why is this inverse relation slightly unique? Because there is a square sign on the top of the radius. Now, what does that mean, sir? That means if your radius increases from r to 2r, what will happen to your force? Your force will half 2 times. If your radius doubles, your force will decrease by a factor that is a square of the increase in radius. Now, this might get a bit confusing, but let me do it in a more simpler way. Can you see the radius is increasing 2 times? Yes. But the force will decrease by or get divided by 2 square. Now let's try another number. Let's say radius increases from r to 3r. What will happen to the force? The force will decrease by a factor of what? By a factor of 3 square. The force will decrease by a factor of 3 squared, that is 9. Now let's say your radius has gone to 4 times. What will happen to your force? The force will decrease by a factor that is 4 square, that is 16. I hope this makes sense. Why is force decreasing by square factors? Because can you see this square sign? This makes it a complicated or a not normal inverse relationship. This makes it a unique inverse relationship. And these types of relationships are known as inverse square law. These types of relationships are known as inverse square law. Now, how will you draw a graph for force versus R? Very, very easy. Let me bring in the graph of force versus R. If you see here, okay, this is quite zoomed in. Oh yeah, let's see. This is perfect. If you see here, as your radius goes from R to 2R, or you can say as your separation goes from R to 2R, your force decreases from F to F upon 4. as your r goes from negative r to negative 2r, your force decreases from negative F to negative F upon 4. Inverse square law is being followed on both the sides. Inverse square law is being followed on both the sides. Also, one more thing to remember here. What is one more thing to remember here? One more thing to remember here is that if you decrease the radius below r, this r is what? This capital R is the radius of the planet. Now, please listen to this carefully. Let's say this is your planet, and let's say this is your radius r. If you decrease the radius below r, that is, if you travel inside the surface, that is, if you travel inside the surface of this planet, what will happen? Your force will decrease to zero. There will be horizontal lines here. Okay, let me repeat what have I said. If you go inside the surface of the planet, if you go inside the surface of the planet, that means if you decrease your radius below r, that means if your r decreases below this value, below the radius, or if you go inside the surface, your gravitational force will drop down to zero. Now, sir, why is that the case? This is due to the point mass assumption. This is due to the point mass assumption. Now, what does point mass assumption states? What does point mass assumption states? This is an A2 specific assumption. This is an A2 physics specific assumption. This is not applied in real life. Please remember this. Okay, so what have I told? Let's reiterate it. If you go inside the surface of a planet, your r decreases below the radius. If your r decreases below the radius, or if you go inside the surface of a planet, what will happen? Your gravitational force will decrease to zero. Why will it decrease to zero? Because of the point mass assumption. Okay, sir, what is the point mass assumption basically? Point mass assumption states that all masses are considered to be a single entity. All masses are considered to be a single entity. Everything exists outside the mass, outside the mass, and nothing inside. The point mass assumption simply states that masses are acting as singular entities and everything exists outside the mass and there is nothing inside. If there is nothing inside, that means what? If there is nothing inside, that means you will have a force of zero on the inside. Simple as that. Do you guys get this? Any questions here? Any questions in this graph, any question up till now in the lecture are more than welcome. The floor is open for you. You have 1 to 2 minutes. You can ask whatever you have to ask. Okay, so let's do one thing. Let's write down the heading of gravitational field and gravitational field strength. Gravitational field and gravitational field strength. Okay. What are these two terms? Let's study that. Okay. Now, first and foremost, the thing that you need to remember is gravitational field is always attractive. Gravitational field is always attractive. Always remember this, that gravitational field is hamesha attractive. Always remember gravitational field is always attractive. You can write it here as well. Gravitational field is always attractive. Okay. How do we show an always attractive nature? Whenever you will draw gravitational field lines, the arrows will point inwards like this. The arrows will point inwards like this, like this, like this, like this, like this, like this. Whenever you will draw gravitational field lines, the arrows will point inwards like this. Okay. And how to define gravitational field? Basically, how to define gravitational field? Gravitational field is basically a region in a space around a mass where another mass experiences a gravitational force. How to define gravitational field? Gravitational field is basically a region in space where an other mass experiences a force. Simple as that. Let me repeat the definition of gravitational field because this comes a lot in the examination. Gravitational field is a region around a mass where another mass experiences a force. And always remember, gravitational fields are always attractive. Gravitational fields are always attractive. Okay. Secondly, the direction of field lines is always radial. The gravitational field lines are always made in a radial direction. And the closer the field lines, that means the stronger the field. This is what you need to know about gravitational field. Now let's come on to gravitational field strength. Now let's come on to gravitational field strength. What do I mean by gravitational field strength? Gravitational field strength is basically the force per unit mass. Gravitational field strength is basically the force per unit mass in a gravitational field. Now, what do you mean by that, sir? Have we studied the formula for force? Yeah, capital G, capital M1, M2 divided by R square. The gravitational field strength is the force of gravitation per unit mass. What do you mean by that, sir? Very easy. Gravitational field strength of any planet can be calculated by dividing the gravitational force with what? By dividing the gravitational force with the mass. What was the formula for gravitational force? Capital G, capital M, small m divided by R square. If you divide this formula of force by the small mass, m and m get cancelled out. The gravitational field strength gives you a value of what? Capital G, capital M divided by R square. Where capital G is the gravitational constant, R is the radius of the planet. What is capital M? Capital M is the mass of the planet. Simple as that. Capital M is the mass of the planet. Okay. Now let's say this formula is true. Let's utilize this formula to calculate the gravitational field strength G for Earth. Let's utilize this formula to calculate the gravitational field strength G for Earth. If you apply this formula, you will notice that the gravitational field strength G for Earth comes out to be 9.75 Newton per kg. The gravitational field strength for Earth comes out to be what? 9.75 Newton per kg. What is the value of G that you have studied throughout your O levels and AS level physics? The value of G that you have studied throughout O and AS level physics is 9.81 ms minus 2. So this value of G, that is 9.75 Newton per kg, is pretty close to this value. Hence this formula works. Hence this formula works. Now let's move a step further. Let's plot the graph of gravitational field strength versus radius. Let's plot the graph of gravitational field strength versus radius. How will we do that? Very easy. Again. First of all, write down the heading. First of all, write down the heading of gravitational field strength versus R. Gravitational field strength G versus radius or separation, you can say. versus separation r. Okay. So you have to plot the graph of gravitational field strength versus r. First of all, let's look at the formula. G is equals to capital G capital M divided by R square. Again, if you are smart enough, you will notice that G is inversely related to R square. G is inversely related to R square. But this is not a normal inverse relationship. Why? Because we have a square here. Hence, this is what? This is the same relationship as the gravitational force versus R. This is known as inverse square law. Now, what will happen in inverse square law? If your R increases to 2R, your gravitational field strength will decrease by a factor of 4. If your R increases to 3R, your gravitational field strength will decrease by a factor of 9. If your R increases to 4R, your gravitational field strength will decrease by a factor of 16. So by whatever factor radius is increasing, the square of that factor gets divided with the gravitational field strength. By whatever factor radius is increasing, the square of that factor gets divided with the gravitational field strength. Simple as that. Nothing complicated. Now, can you draw a graph? Can you draw a graph of gravitational field strength versus R? Yes, you can surely do that. How will you do that? How can you draw a graph of gravitational field strength versus R? Pretty similar to what you have done for force. Something like this. As R increases to 2R, the gravitational field strength will decrease by 4. As R increases to 2R, this would be negative R because it is in the left direction. Your gravitational field strength decreases as well. Simple as that. Any ambiguities here? Yes. Any ambiguities here? You can ask me right now. Then I am going to discuss an important point here that is literally missed by 99% of the students. All clear up till now? You can write yes or no in the chat. You can just give a thumbs up, thumbs down if anything is unclear. We will discuss what happens inside. 1 second. Okay. Now, since we are considering all the masses as point masses, since we are considering all the masses as point masses, let's say this is your planet, let's say this is your radius r. If you start going inside the mass, since this is a point mass, your gravitational field strength will remain constant. Since this is a point mass, your gravitational field strength will remain constant like this. Remain constant like this. So, an important distinction to remember. If you go inside the surface, your gravitational force becomes 0. And if you go inside the surface, your gravitational field strength becomes constant like this. Simple as that. Anything complicated here? Yes. Anything that you feel is difficult? All clear? Chalo, let's further move ahead. Now, up till now, we have seen the gravitational field strength for one planet. That as we move away, the gravitational field strength will decrease. This was the gravitational field strength for one planet. Now, let's look at the gravitational field strength for two planets. Let's look at the gravitational field strength between two planets. Okay, let's write down the heading. Gravitational field strength. Gravitational field strength between between two planets. Okay. How will we calculate the gravitational field strength between two planets? Very, very easy. Let's say you have a mass like this. Okay. Let's say this is your mass m1, and let's say this is your mass m2. Okay. Do you remember from theory that gravitational field strength will always act inward? Do you remember that gravitational field strength is attractive, hence it will always act inward? Okay, so let's mark the inward arrows. Let's mark the inward arrows. Let's mark the gravitational field strength here. Like this. Let's say this is G1. And let's mark the gravitational field strength here. Let's say this is G2. Okay. Now you must also remember. Now you must also remember that gravitational field strength is a vector quantity. Gravitational field strength is a vector quantity. This is something that you must remember. Gravitational field strength G is a vector quantity. And gravitational field strength always acts inward. Gravitational field strength always acts inward. Okay. So, if it is a vector quantity, it is always acting inwards. What you can do is you can say the vectors acting to the right can be considered as positive and the vector acting towards the left can be considered as negative. Simple as that. Now, now, if I draw a graph here, something like this and like this. Let's say I plot gravitational field strength on the y-axis, Newton kg minus 1, and negative gravitational field strength, let's say Newton kg minus 1 here. Let's say this is your r slash meters. Okay. Just look at the board, no need to copy right now. First of all, if you can see, this gravitational field strength is acting towards the right, and the vectors towards the right are considered to be positive. So this will be positive. Now, can you also see that this gravitational field strength is acting towards the left, and the vectors towards the left are negative? So this G1 will be negative. Okay, okay, okay. Is this clear to everyone? Yes or no? Tell me, is this initial step clear to everyone? Yes or no? Now begins the actual fun. And please, please, please remain active in the chat. Just this just increases my motivation to teach. Okay, at the surface here, M1, what do you have? Whenever you are making a surface, you try to make dotted lines like this. Okay. At the surface M1, what do you have? At the surface M1, you have a negative gravitational field strength of negative G1. Okay, please, please, please observe this. As you will move away from the surface, R increases, gravitational field strength will decrease. Okay, so let's draw a graph like that. Something along these lines. Okay, this is a curve. Now, let's do the same thing for mass M2. Let's do the same thing for mass M2. Mass M2 had gravitational field strength towards the right, so it will be positive gravitational field strength. It will be positive gravitational field strength, something like this. Somewhere here. Yeah, this is capital G2 positive. This will cause the gravitational field strength to decrease as we move forward. As the radius increases, gravitational field strength decreases. Similar thing happens for the red graph. Okay, now it would be better if I write the key here. A red graph represents the gravitational field strength of mass 2. Blue graph represents the gravitational field strength of mass m1. Okay, now you had to calculate the resultant or the gravitational field strength between two planets. These are individual graphs. How will you calculate the combined graph, or you can say the total gravitational field strength between the two planets, or you can say the resultant gravitational field strength between the two planets? Very, very easy. Add these two graphs up. Add these two graphs up. You will get something along these lines. You will get something along these lines. This green graph is your, sir, how G is decreasing for green because negative reaching zero is. See, we are talking about magnitude, beta, here. Beta, we are talking about magnitude here. You are perfectly correct in mathematical terms, and this will come in handy in the next few topics. बिल्कुल सही कह रहे हो. But here we are only talking about the magnitude. Here we are only talking about the magnitude. Is this clear? समझ आई बात? We are only talking about the magnitude. चलो, perfect. Now, once you add these two graphs up, this will give you the resultant gravitational field strength. This will give you the resultant gravitational field strength. Okay. Now, let's also label these graphs. This graph, red one, is for G2. This graph, blue one, is for G1. And this green graph is your resultant gravitational field strength graph. Resultant gravitational field strength graph. Let's label it as GT. Let's label it as GT. GT is equals to G1 plus G2. Now, sir, why is this such a useful graph? Why is this such a useful graph? Because let's say you have to calculate gravitational field strength at a random point here. Let's say this is your point A. You need to calculate the gravitational field strength here. You will just go here and calculate the resultant gravitational field strength here. Simple as that. That's why this graph is very, very handy. Any questions? Let's say you weren't given the graph. Let's say you weren't given the graph and you had to find the gravitational field strength at, let's say, this point. You had to find the gravitational field strength at, let's say, this point A. Let's say you have to find the resultant gravitational field strength at A and you weren't given the graph. How would you do that? Please focus on the diagram. Now, you must know that the distance, let's say you are given the distance as well between the two masses, that is x, and you are given the distance between mass m1 and A, let's say that is r. You have to calculate the total gravitational field strength at A. How will you do that? Can you observe that the gravitational field strength at A is a combination of two gravitational field strengths? The gravitational field strength due to the mass 2 and gravitational field strength due to mass 1. How can you write this? You will say G2 plus negative G1. Why have I written negative G1? Because the gravitational of mass 1 is acting towards the left and all the vectors towards the left hand side are negative, as you can see. How will you calculate the gravitational field strength due to mass 2? Can you calculate this distance? Can you calculate this distance? Yes. Yes or no? Can you calculate this distance from point A till this center of the mass? Can you calculate this distance from this point A to the center of the mass? Yes, you can do that. That is x minus r. What was the formula of gravitational field distance? Capital G mass m2 divided by what is the distance? X minus r square minus capital G capital M 1. What is the distance from the center of mass m1 till point A? R square. This is your resultant gravitational field strength at point A. This is your resultant gravitational field strength at point A. Is this thing clear? Do you understand how we calculated the resultant gravitational field strength at point A? Very, very easy. If you are not given the graph, let me repeat it. If you are not given the graph, how will you calculate the resultant gravitational field strength at any point? You will take the distances from point A and you will apply the formula. Is this logic clear to everyone? You can give me a thumbs up in the chat if this is clear. If this is not clear, you can tell me. Clear? Perfect. Now, one more thing that you must notice here is there exists a point where the resultant gravitational field strength becomes 0. There exists a point where the total gravitational field strength or the resultant gravitational field strength becomes 0. Any tip to memorize the long formula? The only tip to memorize this formula or to know this formula is to not memorize it. A very counterintuitive tip, but the only way to remember this entire thing is to not memorize it. Instead, learn the logic behind it. Instead, try to learn the logic behind it. What have I actually done here? What have I actually done here? Let's see again. Okay. Now, there is a point on this graph. There is a point on this resultant gravitational field strength graph, or you can say total gravitational field strength graph, where gravitational field strength is equal to 0. This point is known as null point. At null point, your total gravitational field strength becomes 0. How will you find out null point? How to find out null point? To find out null point, you will place G. You have this formula, right? To calculate gravitational field strength at any point. To calculate null point, what will you do? You will place GA as 0. To calculate null point, you will place GA as 0. Shabash. Very good, Aram. Very good, Aram. Does anyone has any questions up till now? Kindly ask in the chat or by opening your voice chat. Both are possible. Otherwise, we are moving on to the next topic. Okay. Is everything clear? You can just give a thumbs up. At least be active. There is a thumbs up option in the Zoom. You can just give that if you are lazy. Chalo. Let's write down the next heading. And this is also important. Sir, ये last वाला repeat कर दें please. Null point वाला बेटा. Do you want a repetition of null point? Okay. Whenever the examiner will tell you to calculate null point, your total gravitational field strength will become 0. Otherwise, everything will remain same. Whenever the examiner tells you to calculate null point, your gravitational field strength total will become 0. Everything else remains unchanged. Is this clear, Hussein? Any questions further? बेटा what have I done? मैंने कुछ नहीं किया. मैंने GA की जगह अगर 0 रख दिया, this allows me to find null point. Nothing complicated. Okay. Now let's come on to the most important concept. Could we take GM common? Yes बेटा, आप इसके GM common ले सकते हो. बहुत सारी चीज़ें कर सकते हो. ठीक है, बहुत सारी चीज़ें कर सकते हो. We will see that in past papers. अभी के लिए just make your concepts correct. Now write down the heading of gravitational potential energy and gravitational potential. Now write down the heading of gravitational potential energy and gravitational potential. Okay. Now I want your undivided attention. Gravitational potential energy and gravitational potential. Okay. What is gravitational potential energy? See, the definitions from AS physics change here. The definition from AS physics change here. What is gravitational potential energy is definition, sir. Gravitational potential energy is the work done on a body to move it from infinity to any defined point in a gravitational field. Gravitational potential energy is the work done on a body to move it from infinity to any defined point in a gravitational field. Now, sir, what do you mean by that? Let's say this is your Earth. Please focus on the board. You can copy all this after. Also, you will be provided with the note, so you actually don't need to copy it. This is, let's say, infinity. This is, let's say, infinity. And let's say this is your box of chocolates at infinity. We are considering something interesting so that it remains in your head. Let's say this is a box of chocolate at infinity. The energy required to bring this box of chocolate from infinity to any other point, let's say A, is known as gravitational potential energy. The energy required to bring this box of chocolate from infinity to any other point is known as gravitational potential energy. Nothing complicated. Nothing complicated. Okay. Now, what is the formula of gravitational potential energy? Very, very easy. The formula of gravitational potential energy is UP is equals to negative capital G capital M small m divided by R, where capital M is the mass of the planet, the small m is the mass of the object, and what is R? R is the distance between the center of the two objects. This is the formula that you need to remember for gravitational potential energy. G is your gravitational constant, capital M is your mass of the planet, small m is the mass of the object, R is the distance between the planet and the object. Now, sir, what is gravitational potential? Gravitational potential is just a, you can say, a derivation from gravitational potential energy. What is gravitational potential, sir? First of all, gravitational potential is represented with the symbol of phi. And what is gravitational potential? Gravitational potential is the work done per unit mass. Gravitational potential is the work done per unit mass to bring any object from infinity to a point in the gravitational field. So basically, can you read both these definitions? Gravitational potential energy is the work done on a body to move it from infinity to any defined point in a gravitational field. Gravitational potential is also the work done to move any object from infinity to any point in a gravitational field strength. But there is a changing. That is per unit mass. Gravitational potential is per unit mass. However, in gravitational potential energy, mass doesn't matter. Is this clear? How will I write the formula of gravitational potential? Very easy. Gravitational potential is gravitational potential energy per unit mass. What was the formula of gravitational potential energy? Minus capital G, capital M, small m divided by R divided by mass. M and M gets cancelled out. The formula for phi comes out to be capital G, capital M over R. This is one more formula that you need to remember. Please put it in your heads. Secondly, you can also rearrange this formula. Mass into phi is equals to gravitational potential energy. You will also need to remember this formula as well. Both are one and the same things. Both are one and the same thing. All clear up till now? All clear up till now. Now, If there are any questions you can ask while I am teaching, please don't be hesitant. If you aren't asking questions in the class, that and if you are still confused and are not asking questions, that then that means you are basically not utilizing the classes correctly. Make sure you clear each and every doubt before going away from these classes. Take care. Chalo. Now let's do one thing. Let's say this is your earth. Okay, let's say this is my earth. And let's say I have an object here. Let's say this is, what should I say? This is planet A. This is planet A. The planet A has a gravitational potential energy of minus 7 into 10 raised to the power of 7 joules. Planet A has a gravitational potential energy of minus 7 into 10 raised to the power of 7. The mass of Earth is capital M, the mass of planet A is a small m. Now, what does this value of minus 7 into 10 raised to the power of 7 joules mean? What does this value of minus 7 into 10 raised to the power of 7 means? It basically means, it basically means that the planet A requires this amount of energy to escape the gravitational field strength of Earth. This basically means that planet A requires minus 7 into 10 raised to the power of 5 joules of energy to escape the gravitational pull of the Earth or the gravitational pull of the planet that is somewhere here. Simple. Let me repeat it again. What does the value of gravitational potential energy tell you? What does the value of gravitational potential energy tell you in A2 physics? It tells you the amount of energy needed by the object to escape from the gravitational pull or the field strength. Now, we are going to study two most important cases. Now, believe me, you will see these cases like many times in past papers. Case number one, object moving towards the planet. Please keep your eyes open towards the planet. Object moving towards the planet. Okay, let's say this is your Earth. Let's say this is your Earth. Okay. Earth or any planet. Let me journalize this. Let's say this is a planet. And let's say you are moving towards the planet. Let's say this is your, I will try to make it as good as possible. Let's say this is your initial position. And let's say you are moving towards the planet like this. Let's say this is your final position. Okay. You are moving towards the planet. You are moving towards the planet. What will happen? If you are moving towards the planet, what will happen? Any ideas? If you are moving towards the planet, your gravitational potential energy will become more negative. Let's say it was initially minus 5 into 10 raised to the power of 5. At the final position, it will become minus 8 into 10 raised to the power of 5 joules. If you are going towards the planet, what does that mean? If you are going towards the planet, what does that mean? Your gravitational potential energy will become more negative. Can you see it is going from a value of minus 5 to a value of minus 8? What is happening here? It is becoming more negative. It is becoming more negative. Okay. If your gravitational potential energy is becoming more negative, that means what? If you are moving towards the planet, there will be a loss in gravitational potential energy And this gravitational potential energy will get converted into what? Gain in kinetic energy. Simple as that. Believe me, nothing complicated here. Loss in gravitational potential energy will get converted into gain in kinetic energy. Simple as that. Is this thing clear to everyone? Any questions here? Anything that confuses you still, you can ask me right now. Hmm. Let's study case number two. Case number two. Believe me, if these two cases go through your head in the correct manner, you will be acing the past papers. Object moving away from the planet. If your object is moving away from the planet, okay, what do you mean by that, sir? Let's say this is your planet, okay, and let's say your object is moving away. 1 second. Let's say your object is moving away like this. Let's say this was your initial position, and let's say this was your final position. Let's say object is moving away from the planet. Okay. Initially, your gravitational potential energy will be, let's say, minus 7 into 10 raised to the power of 5. At the final position, let's say your gravitational potential energy is minus 4 into 10 raised to the power of 5 joules. Can you observe one thing? Can you observe one thing? That your gravitational potential energy is becoming what? Less negative. That your gravitational potential energy is becoming less negative. If your gravitational potential energy is becoming less negative as you move away from the planet, that means what? As you move away from the planet, there is gain in gravitational potential energy and loss in kinetic energy. Simple as that, nothing complicated. As you move away from the planet, there is gain in gravitational potential energy and loss in kinetic energy. Simple as that, nothing complicated. Graph of gravitational potential versus separation, or in other words, R. Graph of gravitational potential versus R. Okay. So, how can we draw the graph of gravitational potential versus R? Very, very easy. If you are smart enough, if you are smart enough and you can focus on the formula of gravitational potential, you will notice gravitational potential is always negative. So you don't need to draw the positive y-axis. Can you see how did I concluded this? I don't need to draw the positive y-axis, or I can keep the positive y-axis very, very small, because gravitational potential will always be negative. So I can keep the positive axis pretty small. Gravitational potential has a unit of what? Joules per kg, kg minus 1. Gravitational potential will always be negative, so my negative y-axis will be much more greater. Okay. Now, how will you draw the graph of it? How will you draw the graph of it? Very, very easy. Very easy. Literally the easiest thing you will study. Let's suppose this is your planet. Uh, yeah, something like this. Yeah, let's suppose this is your planet. At the surface of planet, let's say R here, and let's say negative R here. At the surface of planet, you will have negative phi somewhere here. At the surface of the planet, you will have negative phi like this, okay. As your R increases to 2R and your R increases to negative 2R, what do you think will happen? Can you observe gravitational potential and radius are inversely related? So phi will become what? Negative phi over 2. Somewhere here, somewhere here. So your graph will pan out something like this. Something like this. This is your gravitational potential versus R graph. This is your graph for gravitational potential versus R. Nothing complicated here. Okay. One more thing to remember here is if you go inside this mass, if you go inside this planet or mass, which assumption will start applying? Point mass assumption, your gravitational potential will get constant like this. Simple as that. Nothing complicated. In this highlighted region, the region I have highlighted in yellow, point mass assumption is being applied. Okay. Now, let's try and calculate the gradient of gravitational potential graph. Let's try and calculate the gradient of gravitational potential graph. Let's draw a tangent here. Let's draw a tangent here. The gradient of this graph will be equal to what? Change in y over change in x. What is on the y-axis? Negative gravitational potential. And what is on the x-axis? You have change in x, that is r, minus capital G capital M over r divided by r. This will be equal to what? Minus capital G capital M over r square. Can you tell me, have we studied any quantity that has this formula? Have we studied any quantity that has this formula in gravitation chapter? Yes, that is gravitational field strength. The gradient of gravitational potential graph is what? The gradient of gravitational potential graph is negative of gravitational field strength. Yes, very good, Arham, very good, Nabia. So please remember this key point. Let me repeat it as well. The gradient of gravitational field strength, gravitational potential graph is negative of gravitational field strength. The gradient of gravitational potential graph is negative of gravitational field strength. Please repeat after me. The gradient of gravitational potential graph is equals to negative of gravitational field strength. Simple as that. Secondly, this is your gravitational potential graph for what? This is your gravitational potential graph for one planet. This is your gravitational potential graph for one planet. How will you draw the gravitational potential graph for two planets? If you have two planets, how will you draw the gravitational potential graph? The easiest of the graphs that you have seen up till now. How will you draw the gravitational potential graph for two planets? Let me show you guys. Please remember that gravitational potential always remains negative. Gravitational potential always remains negative. Let's say this is the gravitational potential graph for mass m1, and let's say this is the gravitational potential graph for mass m2. Can you see both of them are in negative? Yes. You can add these two up to get the resultant gravitational potential graph. You can add these two up to get the resultant gravitational potential graph. I hope there are no misconceptions here. Secondly, let's say you are not given the graph. Instead, you are given a point A here and the total distance between the center of the two masses. The total distance between the center of the two masses is, let's say, x, and the distance from point M1 to A is R. Okay. Can you calculate the resultant gravitational potential at A? Yes, you will utilize this formula. Resultant gravitational potential at A is equals to the gravitational potential due to mass 1 plus the gravitational potential due to mass 2. The gravitational potential due to mass 1 will be what? Negative capital G m1 divided by r. What will be the gravitational potential due to mass 2? Can you calculate this distance? Yes, this is x minus r. So plus negative capital G m2 x minus r. This is how you can calculate resultant gravitational potential at any point between two planets. हुसैन ऊपर वाला ग्राफ नहीं समझ आया बेटा ऊपर वाले ग्राफ में क्या नहीं समझ आया if you see uh, let me write the relationship again here. Phi is equals to capital G capital M over R. Okay, phi is equals to capital G capital M over R. Can you notice phi will remain negative throughout? Can you notice phi will remain negative throughout? So can you see I have drawn all the graphs in the negative axes for phi? And can you also notice that phi is inversely proportional to r? As r doubles, phi halves. As r doubles, phi halves. If you calculate the gradient of this graph, this will be equal to what? Change in y over change in x. On the y-axis, I have placed phi. The formula of phi is what? Negative capital G capital M over R. The formula for x is what? R. Divide both of them. This comes out to be what? Capital G capital M over R square. Capital G capital M over R square is equals to what? Gravitational field distance. So the gradient of gravitational potential graph is equals to gravitational field distance. Simple. Let's suppose you have a planet like this. Let's say this is your Earth, okay, and let's say there is a satellite rotating around the Earth. Let's say this is your planet, and let's say this is a small satellite rotating around the planet. This is your satellite. Okay, so something like this will be your path of rotation. Okay, what will happen? The satellite will apply a gravitational force towards the planet like this. This is your force of gravitation. And whenever your object is moving in a circle, whenever your object is moving in a circle, there is a centripetal force acting away like this. So there are two forces. Whenever a outer space body is in motion around a planet, there are two forces acting on it. The gravitational force that is towards the center and a centripetal force acting away. Okay. How can you represent that? You can say force of gravitation is equals to the centripetal force. Now gravitation force can be represented with one formula only, capital G, capital M, small m divided by this radius of the orbit square is equals to centripetal force has multiple formulas. Centripetal force has multiple formulas. Okay. What will be the formulas of centripetal force? Do you remember there were three formulas for centripetal force? Do you remember? What were the three formulas for centripetal force? Anyone? mv square over r, mvw, and mrw square. So there are three formulas for centripetal force that you can apply here. Okay, let's apply the first formula. That is which one? One second. Let's apply the first formula for centripetal force. That is what? mv square over r. mv square over r. This can be applied. This can be applied as well. However, what you can do as well, you can say gravitational force capital G, capital M, small m over r square is equals to what? Equal to the second formula of centripetal force. That is mrw square. Okay. We can do one last thing. We can do one last thing. We can say capital G, capital M, small m over r square is equals to what? it is equals to mvw. This is your third formula for when an object is moving around a planet. Whenever an object is moving around a planet, what happens? The force of gravitation is equals to the centripetal force. Whenever an object is moving around a planet, what happens? The force of gravitation is equals to the centripetal force. The force of gravitation only has one formula, capital G, capital M, small m, where capital M is the mass of the planet, small m is the mass of the satellite, r is the radius. Simple as that. I can write it here as well. Capital M is the mass of planet. Small m is the mass of satellite. R is what? R is the distance between the satellite and the planet. You can also term it as separation. What is V? V is your linear speed of the satellite. V is your linear velocity. And what is W? W is your angular velocity. W is your angular velocity. Simple as that, nothing complicated. Is everything clear up till now? Now let's move on to Kepler's law. Now write down the heading of Kepler's law. If everything is clear up till now, write down the heading of Kepler's law. Now, sir, what is Kepler's law? Very, very simple. Kepler's law relates the time period of an orbit with the radius of an orbit. Okay, so what do you mean by that? Let's say you have a planet like this again, and let's say there is a satellite orbiting around this planet. Like this, there is a satellite orbiting around this planet like this. This is your satellite, this is your planet. Okay. What will happen? What will happen? Again, the force of gravitation that will act towards the center will be equal to the centripetal force Fc. So you can write it here. Force of gravitation is equal to the centripetal force. But hold your horses. There is an important trick here. Whenever you are driving Kepler's law, the force of gravitation will remain same, capital G, capital M, small m over r square. The centripetal force, which formula of centripetal force will you use? mrw square. Is anything getting cancelled out? Yes, m and m get cancelled out. Also, do you remember from the first chapter that w, angular velocity, used to be equal to what? 2 pi over t? Okay, let's further write this down. Capital G, capital M over r square is equals to what? R into 2 pi over t whole square. Okay. Capital G, capital M over r square is equals to r 4 pi square over t square. This r square and r will get multiplied. Capital G, capital M is equals to r cube 4 pi square over t square. Now, let's rearrange this formula. Let's take t square to the other side. Capital G, capital M divided by 4 pi square is equals to r cube. Can you note that capital G, capital M, 4 pi square is a constant? Can you note capital G, capital M and 4 pi square is a constant? Yes. If something is a constant, you can replace it with a direct proportionality sign. This means what? Time period is directly proportional to what? Time period is directly proportional to r cube. Simple as that. Okay? Time period is directly proportional to what? Time period is directly proportional to radius का cube. Okay, यहाँ तक is everything clear? This is basically Kepler's law. Any ambiguities here? ठीक है? Okay, any ambiguities here? I am asking once again, if everything is clear, just give me a thumbs up in the chat. Yeah, is everything clear? Give me a thumbs up in the chat. If something is unclear, you can ask me right now. Shariar, is it clear? Since you weren't present in the previous lecture as well, beta. Is it clear? Rao, is it clear to you? Perfect, let's further move ahead. This was basically Kepler's law. Okay, now let's further move ahead. Write down the heading of geostationary satellites. Write down the heading of geostationary satellites. What are geostationary satellites? Let's see that. Geostationary satellites. Let's see what are geostationary satellites. Okay, so geostationary satellites are those satellites that have the same angular velocity as that of the planet and they are moving in the same direction as the planet. Okay, let me write down the definition as well. Geostationary satellites have the same angular velocity as the planet and are moving in the same direction as the planet. What do I mean by that? See, let's say we consider the example of Earth. Earth is rotating around its axis. Let's say this is the axis of Earth. Earth is rotating around its axis and completes one revolution in 24 hours. Earth is rotating around its axis and completes one rotation. Now, Earth is rotating around its axis in 24 hours. Yes. So, if we have a geostationary satellite for Earth, if we have a geostationary satellite for Earth, geostationary satellite for Earth, its time period will be what? Its time period will also be 24 hours. What are geostationary satellites? Geostationary satellites are those satellites which have the same angular velocity, same W, as that of the planet around which they are orbiting. As that of the planet around which they are orbiting. Okay? Now, now, what else? What else? The Earth is taking 24 hours to rotate around its axis. Okay. And if a geostationary satellite takes 24 hours to rotate around the Earth, that will be a geostationary satellite for Earth. Simple. Time taken for the Earth to rotate around its axis is 24 hours. And a geostationary satellite for Earth will also take 24 hours to rotate around the Earth. This is a geostationary satellite's definition. Okay. Now let's consider Earth. Now let's consider the example of Earth. Let's say we have Earth like this. Oh, 1 second. Let's say this is our Earth and there is a geostationary satellite orbiting around the Earth. Something like this. Let's say this is your geostationary satellite that is orbiting around the Earth. Obviously, my circles are pretty much like ovals, and this is advantageous if you have studied some space physics because orbits are usually ellipses. Okay, so for Earth, so for Earth, let's say this is a geostationary satellite. What will happen? Let's say this is a geostationary satellite. What will happen? The force of gravitation acting towards the Earth, that is Fg, will be equal to what? The away force of centripetal force. You can say that the force of gravity is equals to the centripetal force. What is the force of gravitation? Capital G, capital M, small m over r square. What is the centripetal force? mv square over r. However, let's place this formula for centripetal force, mRw square. I will tell you guys why in a bit. Just give me a second. I will tell you guys why in a bit. Okay. Now, is anything getting cancelled out? Yes. Satellite's mass, that is a small m, is getting cancelled out. Capital M is the mass of the earth. Okay. What is R? R is this complete green line. Okay. So capital G, capital M, take R to the other side, it becomes R cube. Instead of W square, let's place 2 pi over T whole square. Capital G, capital M is equals to R cube 4 pi square divided by T square. Okay, you had to calculate R. Okay, you had to calculate R. T square is equals to capital G, capital M, 4 pi square is equals to R cube. Now, please, please, please pay attention here. Your eyeball should be focused here. You shouldn't be doing anything else. Okay. Now we know that the mass of Earth, capital M, is 6 into 10 raised to the power of 24 kg. Okay. And do you know this time period? Yes. Any genius in the chat who can tell me the time period for this geostationary satellite? The time period for geostationary satellite is 24 hours. But we cannot put time as 24 hours. We will have to convert it into seconds. So 24 into 60 into 60. So how will we put the time period? 24 into 60 whole square. Capital G is what? 6.67 into 10 raised to the power of minus 11. This is the gravitation constant. What is the mass of the earth? 6 into 10 raised to the power of 24 kg divided by 4 pi square. Take a cube root of this. Take a cube root of this. What will your answer for radius come out to be? Very good, Nabiha. Yeah, 24 hours is the time period. What will your answer for R come out to be? What will your radius be? Anyone in the chat who has a working, functioning calculator? I hope all of you have a working calculator up till now in A2. The value of R comes out to be 4.3 into 10 raised to the power of 7 meters. So what does this tells us? What does this tells us? If Earth has a geostationary satellite, it will be a distance R that is 4.3 into 10 raised to the power of 7 meters away from the center of the Earth. This is your R. Is this thing clear to everyone? Yeah. Any ambiguities here? You can tell me. Any ambiguities in this question, you can tell me. Clear? Perfect, Nabia. Perfect. Sharia, Rao, Asma, is it clear to you guys? Any ambiguities here? Anything that you feel is incorrect, anything that you feel is not making sense, you can ask. All good. Should we move ahead? Okay, chalo. Let's further move ahead. Now, in recent times, examiner has started to do one more trick. In recent times, the examiner has started to do one more trick. What is that trick? Examiner asks you to calculate the height h of satellite, the height h of satellite above the Earth's surface. In recent times, the examiner has started to ask you to calculate the height of the satellite above the Earth's surface. Okay, how will you do that? How will you calculate the height h of the satellite above the Earth's surface? Basically, what do you have to calculate? You have to calculate this thing. You have to calculate this green thing. Let's label this as h. If you want to calculate this h, then we have to subtract the radius. Very good. If we want to calculate this height h, then what do we have to do? We have to subtract the radius of the earth, that is this value. Oh, let's mark it with blue. If we have to calculate the height, we will have to subtract this radius of the earth, that is this value. And what is the radius of the earth? That will be given in the examinations. What is the radius of the earth? The radius of the earth is 6.4 into 10 raised to the power of 6. 10 raised to the power of 6 meters. If you want to calculate the height h, what will you do? You will subtract RE from R. You will subtract RE from R to calculate the height. What was R? R was 4.23 into 10 raised to the power of 7. 4.23 into 10 raised to the power of 7. What is the radius of the earth? 6.4 into 10 raised to the power of 6. What will your height above earth's surface be equal to? 3.59 into 10 raised to the power of 7 meters. This is your height of the satellite above the earth's surface. Very, very easy. Now, let's look at the path of geostationary satellites. Let's see where actually geostationary satellites orbit around the earth. There might be a path to geostationary satellites. It can't be random. Yeah, there is a path to it. Let me show you that as well. Geostationary satellites orbit on the equator. Geostationary satellites orbit on the equator. Can you see this? Geostationary satellite is orbiting on the equatorial orbit. There are one more types of satellites that you need to know for your A2 level examination. There is one more type of satellite that you need to know for your A2 level examinations. That is polar satellites. Okay, what are polar satellites? Polar satellites are those that rotate on the poles. Can you see this? Oh, this highlighter is very, very bad. Can you see these one I'm marking in pink sort of? These are your polar orbits or polar satellites that orbit around the poles. Simple as that. They orbit from pole to pole. Now, let's write down another heading of energy of a satellite. Let's write down another heading of energy of a satellite. You can write it here. Energy of a satellite. Okay. What will be the energy of a satellite? Let's see that. Let's put it like this and let's see what will be the energy of a satellite. Okay. First of all, what will be the gravitational potential energy of the satellite? The gravitational potential energy of the satellite is pretty easy. We have studied this in the previous lecture as well. Gravitation potential energy is equals to what? Minus capital G, capital M, small m over R. Simple as that. Gravitational potential energy of a satellite is pretty easy to calculate. Minus capital G, capital M, small m over R. Simple as that. How to calculate the kinetic energy of a satellite? That's a different task. So pay close attention here. This is your gravitational potential energy. Now we are moving on to kinetic energy. Let's see how to calculate kinetic energy of a satellite. Okay. First of all, can you guys tell me what is the formula of kinetic energy that you remember from AS level? 1 upon 2 mv square. Let's say this is your Earth. Let's say this is your Earth or any planet. And let's say there is a satellite rotating around this planet. Let's say there is a satellite rotating around this planet. I guess up till now you might know what I'm trying to do here. The inward force of gravitation, Fg, will be equal to the outward centripetal force. Okay, you can write it here. Centripetal force is equals to the gravitational force. Gravitational force is capital G, capital M, small m divided by R square. Centripetal force is what? mv square over R. Now I have placed this formula of centripetal force. Why? because I want to calculate what v square will be equal to. I want to calculate what this v square will be equal to. Let's calculate that. M and M gets cancelled out. R gets cancelled out with this R square. V square will be equal to what? Capital G, capital M divided by R. Simple as that. Now I will substitute this formula of V square where? In the formula of kinetic energy. Simple as that. Kinetic energy is equals to 1 upon 2 M. What will be your V square? Capital G, capital M over R. Kinetic energy is equals to what? Capital G, capital M, small m over 2R. This is your formula for kinetic energy also gets done. This is how your formula for kinetic energy also gets done. Now, let's come on to the total energy. That is the third energy. Let's come on to the total energy. Total energy is equal to what? Total energy is basically equal to kinetic energy plus gravitational potential energy. What is your kinetic energy equal to? Capital G, capital M, small m over 2R. What is your gravitational potential energy equal to? Capital G, capital M over R with a minus sign. Can you calculate the formula of total energy? Total energy is equals to what? Minus capital G, capital M, small m over 2R. So now, just by some logical understanding, you have the formulas of three types of energies of a satellite. First is gravitational potential energy, second is kinetic energy, third is total energy. Simple as that. Nothing complicated here. One second. Do we have to remember these formulas? Yes, you have to remember these formulas. Yes, yes, yes. You have to remember these formulas for sure. If you want to achieve an A star in A2, you have to remember these formulas. Okay. Now, let's draw the graphs of gravitational potential energies, kinetic potential energies, and total energy versus R. Let's draw the graph of all three energies versus radius. Okay, let's do that. One second. Here you have the graphs for all three types of energies. Okay. Can you notice that gravitational potential energy has this green graph? Why? Why? Always ask why in physics. Gravitational potential energy is equals to capital G, capital M, small m over R. Gravitational potential energy is zero at infinity. Gravitational potential energy is zero at infinity. And as you move away from infinity, it gets negative and negative and negative. That's why this green graph. We have also seen a detailed version of gravitational potential energy graph. Where have we seen that? One second. Yeah, I had drawn somewhere here. Yeah, this is your gravitational potential energy and gravitational potential graph versus R. So, a similar graph will be drawn here. This graph reaches zero as R approaches infinity. As R approaches infinity, gravitational potential energy approaches zero. Simple as that. How about the graph of kinetic energy? Do you remember the formula of kinetic energy? Kinetic energy used to be equal to capital G, capital M, small m over 2R. Can you observe kinetic energy is inversely proportional to your radius r? That's why this sort of an inverse curve. When you add the kinetic energy graph to the gravitational potential energy graph, you get the red graph that is of total energy. Any ambiguities here? Any questions here? Chalo, let's further move ahead. Now, this is the last thing of chapter number 2. This is the last thing of chapter number 2. You can write down the heading of escape velocity. Now, if you have ever thought of escaping this world, if you are ever tired of living in this world, this concept will come in handy. escape velocity. What does this concept states? Let's say, first of all, let's write down the definition of escape velocity to get things out of the way for theory. Escape velocity is the minimum speed required for a body to escape the gravitational pull of planet and reach infinity. Okay. What is escape velocity? Escape velocity is the minimum speed required for a body to escape the gravitational pull of planet and reach infinity. Simple as that. Okay. Let's say you have a planet like this. Let's say you have a planet somewhat like this. Okay. The mass of this planet is, let's say, capital M. Okay. And let's say the radius of this planet is capital R. Okay. And let's say you plan to escape this planet completely from position A to position B, that is at infinity. That is at infinity. Okay. Let's say you plan to escape this planet completely from position A to position B, and the gravitational potential at infinity is zero. Also, the gravitational potential energy at infinity is zero. Okay. You are starting from point A. Point A is your initial position, infinity is your final position. Okay. And let's say the mass of this object is a small m. The mass of this object is a small m. Okay. Now, focus a bit. What is happening? You are moving away from the planet, isn't it? You are moving away from the planet. In the last class, haven't I taught you that whenever we are moving, where have we done that? One second, let me show you guys. Whenever we are moving away from the planet, what happens? Gain in gravitational potential energy and loss in kinetic energy. Whenever we are moving away from the planet, what happens? There is a gain in gravitational potential energy and loss in kinetic energy. So let's write that down. Let's write that down. You will write gain in gravitational potential energy is equals to what? Loss in kinetic energy. Okay. What is gain in gravitational potential energy equal to? How will we find that? The phi at the final position B minus the phi at the initial position multiplied by the mass. How will I find out loss in kinetic energy? Due to the loss ka keyword, I will place a negative sign here. 1 upon 2 m into the change in velocities. The velocity at b square minus the velocity at a square. Okay, what will we do then? Mass and mass gets cancelled out. Can you also observe that phi of b, phi at b will be 0? What will be the phi at A? Yes, any ideas? What will be the phi at A? Minus capital G, capital M over R. Okay, let's do that. This will become 0. This will be what? The phi at B. See, at B we are at infinity. So the phi at B will be 0. And negative, what will be the phi at A? Minus capital G, capital M over R is equals to minus 1 upon 2. Now here I have to state one other thing. Can you see this key point reach? You have to just reach infinity. You have to just reach infinity. What do the key point of reach mean? What does the key point of reach mean? That at infinity your velocity will be 0. At infinity, your velocity will be 0. So at B, your velocity becomes 0. What will be your velocity at A? Minus VA square. Minus minus gets cancelled out, minus minus gets cancelled out. The velocity at A is equals to what? 2 capital G M over R taken under root. This is your velocity at A. This is also known as escape velocity. This is the derivation of the formula of escape velocity. Is this clear? Hmm. Is the derivation of the formula of escape velocity clear? So we can escape the gravitation after we cross infinity. Yeah, the gravitational field ends at infinity. So remember, you asked me a question yesterday. You said if we enter the gravitational field of another planet, why don't that be the minimum speed or something like that? So this is the reason to it. The gravitational fields only end at infinity, not at some random point. Okay. I hope your yesterday's question also get cleared out here. Now, let's further move ahead. Let's do it for Earth. Let's do it for Earth. Now, let's suppose you are standing at Earth and you are fed up of the life here. Let's say you don't want to live on Earth anymore. You want to escape to infinity. How will you calculate the escape velocity for Earth? The mass for planet Earth is 6 into 10 raised to the power of 24 kg. The radius of planet Earth is what? 6.4 into 10 raised to the power of 6. Place the mass in place of capital M. Place the radius in place of R. This is your escape velocity. 1.12 into 10 raised to the power of 4 is your escape velocity. Simple as that. So if you launch yourself with this velocity from the surface of Earth, you will never luckily return back on Earth. You will never return back on Earth. Is this thing clear? This marks the end of chapter 2, that is gravitation. Okay, so let's start the discussion on thermal properties of matter. First of all, first and foremost, you need to know about heat. What is heat? What is heat, sir? Heat is basically the energy in motion due to temperature difference. Heat is basically the energy in motion due to temperature difference. What do you mean by that, sir? If there is a temperature difference, heat energy will flow. If there is a temperature difference, heat energy will flow. Heat energy is the energy that flows due to temperature difference. If there is a temperature difference, heat energy will flow. Always remember, let's say you have two objects, one at 70 degrees centigrade, one at 20 degrees centigrade. Heat will always flow from a higher temperature to a lower temperature. Heat will always flow from a higher temperature to a lower temperature. And heat will keep on flowing. Heat will keep on flowing until and unless you reach what? Until and unless you reach a thermal equilibrium. Heat will keep on flowing until and unless you reach a thermal equilibrium. In this scenario, your thermal equilibrium will, let's say, be at a temperature of 40 degrees centigrade. When the temperature of both the objects equals to one another, you reach a thermal equilibrium. There is no net heat transfer. Simple as that. When the temperature of both the objects equals to one another, there is no net heat transfer. Thermal equilibrium is achieved. Simple as that. Okay. Now, in A2 physics, there are two types of heats that you need to know about. In A2 physics, there are two types of heat that you need to know about. What are those two types of heats? The first type of heat is sensible heat. We will study this in detail. Don't panic, don't worry. The second type of heat is latent heat. The first type of heat that you need to know about in A2 is sensible heat. The second type of heat that you need to know about in A2 is latent heat. Okay, what is sensible heat? Any heat energy that causes a change in temperature. Any heat energy that causes a change in temperature is known as sensible heat. Any heat energy that causes a change in temperature is known as sensible heat. Simple as that. Heat energy that causes a change in temperature is known as sensible heat. Okay. What is latent heat? Latent heat is the heat energy that causes a state change at a constant temperature. There are two different types of heat that you need to know about. First is sensible heat. What is sensible heat? Sensible heat is the heat that causes a change in temperature. However, latent heat is what? Latent heat causes a state change without a change in temperature. Simple. Okay. One more key point that you need to remember here is that temperature is directly proportional to the kinetic energy of the molecules. One more thing that you need to remember here is that temperature is directly proportional to the kinetic energy of the molecules. Okay. What does that mean? If temperature increases, kinetic energy of the molecules increases. If temperature decreases, the kinetic energy of the molecules decreases. Simple as that. Nothing complicated here. Chalo, let's further move ahead. Now, let's discuss sensible heat in detail. Let's discuss sensible heat in detail. Okay. If I discuss sensible heat in detail, what will happen? If I discuss sensible heat in detail, there are two things that you need to know in sensible heat. First is heat capacity. The first thing in sensible heat that you need to know is heat capacity. Okay. What is heat capacity? Heat capacity is represented with a symbol of capital C. Heat capacity is given the units of what? Joules per Kelvin. And what is the definition of heat capacity? The amount of heat needed to bring a 1 degree centigrade change in the temperature of a substance. What is heat capacity's definition? Amount of heat needed to bring a 1 degree centigrade change in temperature in an object. What is the formula of heat capacity? What is the formula of heat capacity? Heat energy, that is Q, divided by the change in temperature gives you your heat capacity. What are the SI units of heat capacity? Joules per Kelvin. Simple as that. What is the formula of heat capacity? Q, that is energy divided by the change in temperature. Simple as that. Nothing complicated here. Okay. Now, what is specific heat capacity? What is specific heat capacity? The definition is pretty similar to heat capacity with just one change. The definition of a specific heat capacity is pretty similar to heat capacity with just one change. Specific heat capacity is what? Specific heat capacity is the amount of heat required to bring a 1 degree centigrade temperature change in what? In a unit mass. Specific heat capacity is what? Amount of heat required to bring a 1 degree centigrade change in a unit mass. How can you calculate a specific heat capacity? You can calculate a specific heat capacity by dividing heat capacity with the mass of the substance. You can calculate a specific heat capacity by dividing heat capacity by the mass of a substance. Okay. Now, what was the formula of heat capacity? Can anyone tell me what was the formula of heat capacity? Yes. What was the formula of heat capacity? Anyone? The formula of heat capacity was energy divided by mass. Yeah. Oh, sorry, energy divided by time, yes. Sorry, what am I saying? Energy divided by temperature. Energy divided by temperature divided by mass gives you your specific heat capacity. Simple formula for specific heat capacity. However, this is not a popular version of a specific heat capacity. In most of the books, you will say this version, where we have made Q, or the energy supplied, as a subject. Q is equals to mc delta T is your energy supplied, and specific heat capacity as a formula of what? Q divided by m divided by delta T. Simple as that. Okay. Now, one more thing to remember here. One more thing to remember here. Heat capacity depends on the mass of the substance. Heat capacity depends on the mass of the substance. Heat capacity depends on the mass of the substance. That is, higher the mass, the higher will be the heat capacity. Heat capacity depends on the mass of the substance. The greater the mass, the greater will be the heat capacity. However, specific heat capacity is what? Specific heat capacity is a material's property. Specific heat capacity is a material's property. Yeah, let's say I take this formula. Q is equals to mc delta T. Okay. And let's do one thing. Let's say I plot Q on the y-axis and delta T on the x-axis. Okay, let's do that. Let's do that. Let's plot Q slash joules on the y-axis and delta T slash Kelvin on the x-axis. Okay. What will happen? What will happen? You will have a straight line graph. You will have a straight line graph like this. The gradient. Yes, 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 yes. Sensible heat is some kind of energy. Yes, 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 you can say that. The gradient of this graph will be equal to what? The gradient of this graph will be equal to mass into specific heat capacity. If you plot energy on the y-axis, change in temperature on the x-axis, the gradient of this graph will be mc, that is mass into specific heat capacity, nothing more, nothing less. Now, if you further focus here, I have told you one more thing. Specific heat capacity is equals to capital C, that is heat capacity divided by mass. Let's say I rearrange this formula by multiplying mass here. mc is equals to capital C. So can I say that this mc is equals to what? Heat capacity or capital C. Heat capacity or capital C. Okay. Can I say this capital C is what? Heat capacity or capital C. Okay. That means the gradient of Q energy versus change in temperature will be equal to heat capacity. Simple as that. Nothing complicated. I hope this is clear. Now let's say the examiner tells you to draw a graph for an object with higher heat capacity, heat capacity. What will you do? You will draw a graph with a higher gradient like this. We'll draw a graph with a higher gradient like this. Is this thing clear to all of you? Any ambiguities here? You are free to question. Any questions here? Anything that you feel is ambiguous? If not, everything is clear. You can give a thumbs up in the chat so that we can move forward. If everything is clear, you can give a thumbs up in the chat so that we can move forward. Umar, Nabiha, is it clear to you guys? Perfect. Should we move forward? Chalo. Let's move ahead. Okay, let's move ahead. Now, let's discuss. Now, important things are going to start. Let's discuss an example question. Okay, let's discuss a pretty basic example question. Let's discuss a pretty basic example question. I need your undivided attention here. Please, please, please. No one should copy. You should focus on the board and you should focus on asking questions. Okay, let's see this. Let's see this. Okay. Let's say we have a system. Okay. Let's say we have a system like this. Okay. And let's see what is in the system. We have a copper ball. We have a copper ball that is at 0.8 kg. The specific heat capacity, small c, of the copper ball is what? 385 joules per kg degree centigrade. And the initial temperature of the copper ball is 200 degrees centigrade. Then we have water. Water has a mass of 2 kg. The specific heat capacity of water is 4.2 joules per grams degree centigrade and the initial temperature of water is 25 degrees centigrade. There is a heat exchange between the copper ball and water. Calculate the final temperature of both the substances as they reach thermal equilibrium. As they reach thermal equilibrium. Now, whenever you face these types of questions, there are two key points for examination purposes that I would love if you guys write. Heat loss, heat loss by one substance, heat loss by one substance is equal to the heat gained by the other substance is equals to the heat gained by the other substance. And the second key point, you wouldn't find these key points in any books. These are key points after years of past paper practice, what I have noticed. Second key point, final temperature, final temperature, TF of all the substances is same. Okay. Final temperature of all the substances is same. Okay. So the final temperature of water will be TF as well, and the final temperature of copper will be TF as well. Because in the end, what is the reasoning for this key point? Because in the end, you reach thermal equilibrium. Because in the end, you reach thermal equilibrium. Okay, now let's start solving this question. First of all, tell me, out of copper or water, which has a higher temperature? Out of copper or water, which one has a higher temperature? Copper has a higher temperature. And in the starting of the lecture today, what did I told you guys? Heat flows from a higher temperature to a lower temperature. Heat always flows from a higher temperature to a lower temperature. So heat will flow from this copper ball into water like this. Heat will flow from the copper ball into the water like this. Oh, like this. Like this. Like this. Heat will flow from the copper ball into the water. This means this means oh 1 second. Oh yeah. Oh. This means heat lost by copper is equal to heat gained by water. Now pay close attention again here. How will you calculate heat lost by copper? Copper is only undergoing a temperature change. So whenever you are only undergoing a temperature change, what is the formula to calculate heat? M of copper multiplied by the specific heat capacity of copper multiplied by the change in temperature of copper. I am still missing one more thing here. This keyword of lost will give you a negative sign here. Whenever in A2 physics or in general physics you have heat lost or you have energy lost, you will represent it with a negative sign. Now, heat gained by water, how will you write that? Heat gained by water. Mass of water divided by the specific heat capacity of water into change in temperature of water. Simple. Let's start plugging in the values. What was the mass of copper? 0.8. What was the specific heat capacity of water? Okay, whenever you are plugging in the values of a specific heat capacity, you have to make sure the units of mass are the same as the units in the specific heat capacity. So yeah, both of them have the units of kg. So C will have a value of 385. What will be your change in temperature? Final temperature minus the initial temperature of 200 is equals to the mass of copper, that is 2 kg. Okay, 2 into the specific heat capacity of what? Water, that is 4.2. Oh, here we have a issue. This specific heat capacity is in grams. This specific heat capacity is in grams. What will you do? You will convert it into kilograms. 4.2 into 1000. This will become what? 4200 joules per kilogram degree centigrade is your specific heat capacity. Now the units of mass and the specific heat capacity are same. You can plug in the values. 4200 into what will be the change in temperature for water? Water had a final temperature of TF. The initial temperature of water was 25 degrees centigrade. Can we calculate the answers? Yes, surely we can calculate the answers since TF is unknown here. Very easy to calculate. 0.8 into 385 divided by 8400. Yeah. I have taken this entire thing in the division on the left hand side. This becomes what? G2 kilogram should not have divided 4.2. No, 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 no. No, 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 no. See, what does this value mean? This value means that you need 4.2 joules to increase the temperature by 1 degree centigrade of 1 gram of water. If you want to increase the temperature of 1 kg of water by 1 degree centigrade, you will need 1000 times this energy. Simple. So I have multiplied it by 1000. Simple. Now you divide this here, this comes out to be negative 11 over 300 TF minus 200 TF minus 25. What does your value of TF comes out to be? Can anyone tell me what will the final temperature come out to be? Final temperature comes out to be 31. Final temperature comes out to be 31.2 degrees centigrade. Okay. Now here, if you see, we have assumed a very, you can say, very non-hypothetical thing. सर ये कैसे आया? बेटा ये सिर्फ इक्वेशन स्विच करते, बेटा इक्वेशन सॉल्व करनी है बस. Hussein, do you get it till this step? Do you get this step? Yes or no? You have to just algebraically solve this equation. Nothing complicated here. Hussein, do you get this step? Should I do this step as well in detail? Let's say there is 20% of the heat loss to the surrounding. How will we calculate the final temperature then? Let's say there is 20% heat loss to the surrounding. What will happen? Then copper will be supplying heat to water and to the surrounding as well. So, what will happen? Then the heat lost by copper, 80% of it will go to water and 20% of it will go to the surrounding. We only have to be concerned with water. We are not concerned with the surrounding. So what will we say? We will say 80% of heat loss by copper is equals to what? Is equals to heat gained by water. Simple. If you are taking 80% of something, if you are taking 80% of something, what does that mean? If you are taking 80% of something, what does that mean? You will multiply it by 0.8 and then you will keep everything same. Can we just multiply the heat gained by? No, no, no. You have to multiply the heat lost by copper by 0.8. You are doing it the opposite way, Umar. Mass of copper divided by the specific heat capacity of copper change in the temperature of copper, and we will place a negative sign here due to the loss, is equals to the heat gained by water. Mass of water is specific heat capacity of water change in temperature of water. Now plug and play. Negative 0.8. What was the mass of copper? Mass of copper was 0.8. Specific heat capacity was 385. Let's plug in here. 0.8 into 385 into change in temperature, that is final temperature minus the initial temperature. What was the mass of water? 2. What was the specific heat capacity of water? 4200 multiplied by the final temperature minus the initial temperature of 25. Will you guys now be able to algebraically solve this? बेटा algebraically solve कर लोगे इसको? Yes, Hussein, Mishal, Umar. Yes, you will be able to do this. Perfect. Now, if you are algebraically able to solve this, the temperature final comes out to be what? Temperature final now comes out to be 30 degrees centigrade. Simple as that. Very good, Safat. Safat is doing great job. Shabash. Now write down the heading of latent heat. Now write down the heading of latent heat. First of all, what is latent heat? What is latent heat? Latent heat is the heat required to cause a state change at constant temperature. Latent heat is the heat required to cause a state change at constant temperature. Okay. Okay, what is latent heat? Latent heat is the heat provided to cause state change at constant temperature. Okay. Now, why temperature remains constant during state change? Or you can say why. What is the purpose of heat supplied during latent heat? What is the purpose of heat supplied during latent heat if your temperature is remaining constant? The heat supplied during latent heat is used to do work done against intermolecular forces. Whenever you are going state change, your temperature doesn't changes, but still you are supplying heat. That heat is used to do work done against intermolecular forces and increase the potential energy of molecules. Simple as that. Let me repeat it again. During latent heat, you are providing heat, but your temperature is not increasing. So, where is that heat energy going? That heat energy is used to do work done against the intermolecular forces and it is used to increase the potential energy of the molecule. Simple as that. Any questions here? Any ambiguities here? The first type of latent heat that we need to know about is latent heat of fusion. The first type of latent heat that we need to know about is latent heat of fusion. The first type of heat that we need to know about is known as latent heat of fusion. Latent heat, latent heat of fusion. Okay, what is latent heat of fusion? Latent heat of fusion is basically, one second. What is the first type of latent heat? Latent heat of fusion. What is latent heat of fusion? Latent heat of fusion is the amount of heat needed to change the state from solid to liquid at its melting point. What is latent heat of fusion? Amount of heat needed to change the state of an object from solid to liquid at its melting point. This is latent heat of fusion. Okay. What is latent heat of vaporization? What is latent heat of vaporization? Let's see. Latent heat of vaporization. What do latent heat of vaporization mean? Latent heat of vaporization is basically the amount of heat needed to the state change the state of an object, yeah, to change the state from liquid to gas, from liquid to gas at its boiling point. At its boiling point. Latent heat of vaporization is what? Latent heat of vaporization is the amount of heat needed to change the state of an object from liquid to gas at its boiling point. Okay. Now, how do we calculate these two types of latent heats? How do we calculate these two types of latent heats? Very, very easy. To calculate latent heat of fusion, you utilize this formula. Q is equals to mass into LF. To calculate latent heat of vaporization, you utilize this formula. Q is equals to mass into LV. Now, what is LF and what is LV? LF is what? Specific latent heat of fusion. LF is what? Specific latent heat of fusion. What is LV? Specific latent heat of vaporization. Okay, what do these two terms mean? What do these two terms mean? Very simple meaning as to latent heats, but just one thing will get added. What does specific latent heat of fusion mean? Specific latent heat of fusion means the amount of heat needed to change the state from the solid to liquid of a unit mass. When you change the state from solid to liquid of a unit mass at its melting point, that is known as the specific latent heat of fusion. Similarly, if you change the state of a unit mass from liquid to gas, if you change the state from solid to liquid of a unit mass, then it is known as specific latent heat of vaporization. I hope all these four terms are clear to you guys. There are two types of latent heats: latent heat of fusion, latent heat of vaporization. Latent heat of fusion is calculated using which formula? Q is equals to mLF. Latent heat of vaporization is calculated using which formula? Q is equals to mLV. What is LF? Specific latent heat of fusion. What is LV? Specific latent heat of vaporization. Simple. And the definitions for all of them are written here. Okay. Now, one thing that you need to know about. One thing that you need to know about. Always remember, always remember, specific latent heat of vaporization LV will be greater than what? LF. Specific latent heat of vaporization will always be greater than specific latent heat of fusion. Why? Why will that be the case? Yes, there are two reasons for that. There are two reasons for that. First reason is more work is done against intermolecular forces, intermolecular forces during what? During boiling, then melting. More intermolecular forces are broken during boiling than melting. What is the second reason why LV is greater than LF? Because work is done. Work is done against atmospheric pressure as well in latent heat of vaporization. Work is done against atmospheric pressure as well. Any ambiguities up till now, anything that you find difficult here, just tell me. How can we experimentally determine latent heat of fusion? Very easy. Let me first of all bring in the apparatus. This is your apparatus, somewhat like this. Just pay close attention here. You don't know how important this is. You have to experimentally determine latent heat of fusion. How will you do that? Let's say you have melting ice at 0 degrees centigrade. Let's say you have the surrounding temperature at 25 degrees centigrade, and let's say you have heater. What will happen? Heat always flows from a higher temperature to a lower temperature. I hope this point was clear to you guys in the first class. Heat always flows from a higher temperature to a lower temperature, isn't it? Okay, if you all agree to that, where will heat flow? Heat will flow from the surrounding into the ice, and heat will flow from the heater into the ice. The ice it is at 0 degree centigrade. As soon as it acquires heat, it will start to melt and this water will get collected here. So which equation can I write here? I can very conveniently say that heat gained by the ice will be equal to the heat produced by the heater plus heat gained from the surrounding. I can conveniently say that the heat gained by the ice will be equal to what? Heat produced by the heater plus heat gained by the surrounding. Now, first of all, I can write heat gained by the ice as what? Qi. Heat produced by the heater can be written as what? You can take the power of heater multiplied by the time for which the heater is operating. How will you get the time? By using this stopwatch. Plus, heat gained by surrounding is given a symbol of Qs. You can further do one more thing. You know ice is at melting point. So the heat gained by ice will be what? Latent heat. So what was the formula of latent heat? Somewhat like this. Latent heat of fusion due to ice converting into liquid is equal to power into time plus Qs. This is your first equation. This is your first equation. Now, if you divide the entire equation by time. If you divide the entire equation by time, what will happen? If you divide the entire equation by time, what will happen? LF into M divided by T is equals to power into time divided by T plus QS divided by T. This T and T gets cancelled out. Always remember, if we divide mass by T, that will become what? M dot. And what does M dot means? Mass per unit time. Let's replace that. LF into M dot is equals to power plus QS divided by T will become what? QS dot. This is your second equation that you need to remember for determination of latent heat of fusion. All clear up till now. Any ambiguities here? How can you experimentally determine latent heat of vaporization? Again, very, very easy. Again, very easy. If you are calculating latent heat of vaporization, that means what? This heater will supply heat to the water. And let's say this heater is at 70 or 100 degrees centigrade. Okay, let's say this heater is at a very high value. Let's say the surrounding is at 25 degrees centigrade. Again, heat will also flow from the heater into the surrounding. Heat will also flow from the heater into the surrounding. Heat will also flow from the heater into the surrounding. Simple. Now, what can you do? What can you do if heat is flowing from the heater into the surrounding and from the heater into the water? What equation can you write here? You can say that heat produced by heater will be equal to what? You can say what? Heat produced by heater will be equal to what? Heat gained by water plus heat supplied to the surrounding. You can say what? Heat produced by heater will be equal to heat gained by water plus heat lost to the surrounding. How can you write it in variable forms? You can write it like this. Heat gained by heater is equals to heat gained by water plus the heat lost to the surroundings. You can phrase it like this. Like this. Heat produced by heater is equals to heat gained by water plus heat lost to the surrounding. What will heat produced by heater equal to? Power into time. What will heat gained by water be equal to? Latent heat of vaporization into mass. What will be heat supplied by heat loss to surrounding be equal to? Qs. Simple. This is your first equation. This is your first equation. You can put it in a box like this. This is your equation number 1. Now, if you divide this equation by T, divide by T, what will happen? Power into time divided by T is equals to LV into mass divided by T plus QS divided by T. T and T gets cancelled out. power is equals to what? M divided by T will be what? M dot LV. Qs divided by T will be what? Qs dot. This is your second equation. Second equation. And the third and the shortcut equation will be what? The shortcut and the third equation will be what? Do you remember? The third and the shortcut equation will be what? Change in power into time is equals to change in mass into LV. This is your third equation. Equation number 3. This marks the end of chapter number 3. Any questions that you have, you can ask. This marks the end of chapter number 3. If you have any silly, intelligent questions, you may ask. What does it tell you? What will we talk about in this chapter? What do you guys think? What is thermodynamics? What are we going to talk about in this chapter? What do you think? Any random guesses? Any wild guesses from anyone? What is thermodynamics? What does the word actually mean? See, thermo means heat. Thermo means heat. Yeah, we are going to study about temperature as well. Thermo means heat and dynamics mean work. Thermo means heat, dynamic means work. And this gives you the definition of thermodynamics. That is, thermodynamics is the study of relationship. Thermodynamics is the study of relationship between heat and work. Thermodynamics is the study of relationship between heat and work. The most important thing that we need to study in thermodynamics is what? First law of thermodynamics. Sit back and relax. This is something that you guys are going to enjoy. First law of thermodynamics. Okay, sir. What is first law of thermodynamics? To put it in a wording and not give you any conceptual thing, to put it just in words, the first law of thermodynamics means this. The first law of thermodynamics states that the heat supplied to the system is equal to the increase in internal energy of the system and work done by the system. The first law of thermodynamics states what? That the heat supplied, that is Q, to a system is equal to what? Increase in internal energy plus work done by the system. Simple as that. Now let's look into the details of this. First of all, let's look into the detail of internal energy. Sir, what is this change in internal energy or change in U that you have written? So let's write down the heading of internal energy. What actually do we mean by the term internal energy? Internal energy is basically the microscopic sum of what? Kinetic energy and potential energies. Internal energy is basically what? Microscopic sum of what? Kinetic energies and potential energies due to their random motion. Internal energy is what? Microscopic sum of kinetic and potential energies of the molecule due to their random motion. Okay. However, in ideal gases, what happens? However, in ideal gases, intermolecular forces are negligible. However, in ideal gases, the intermolecular forces are negligible. And if your intermolecular forces are negligible, what will happen? Your potential energy between the molecules becomes zero. Hence, there is no potential energy between the molecules in an ideal gas. See, where did we started the topic of internal energy from? We said that internal energy U is equals to potential energy plus kinetic energy for a normal object. For a normal object, or you can say for a normal substance. However, for an ideal gas, For an ideal gas, what happens? Potential energy becomes zero. This thing entire T becomes zero. So your internal energy will be equal to what? Kinetic energy. For an ideal gas, the potential energy beta becomes zero. So your total internal energy becomes what? Equal to the kinetic energy. Now, what is so special in this? If your internal energy becomes entirely equal to kinetic energy, what is so special in this and why are we studying this? But we have studied in the previous chapter. We have studied in the previous chapter that kinetic energy was dependent on one factor. Do you remember? We have studied in the previous chapter. Kinetic energy was dependent on one factor. Do you remember? Do you remember or not? Kinetic energy was dependent on temperature. So, for an ideal gas, if the total internal energy is dependent on kinetic energy and kinetic energy is in turn dependent on temperature, you can say for an ideal gas, the internal energy is directly proportional to temperature. If temperature increases, your internal energy will increase. This is only for a ideal gas. If your temperature decreases, your internal energy will also decrease. Simple as that, nothing complicated. You can write it like this. As temperature is the measurement of average kinetic energy for an ideal gas is equal to internal energy, so internal energy is directly proportional to temperature. Now let's discuss what is work done by the gas, or you can say, why have I written a small by here? Why have I written a small by here? Why have I written here work done by the gas? So there are two types of work done. There are two types of work done. There are two types of work done in our A2 level syllabus. What is the first type of work done? The first type of work done is work done by the gas. And the second type of work done is what? Work done on the gas. The first type of work done is what? Work done by the gas. By the gas. What is the second type of work done? Work done on the gas. Let's see both of them in detail. Let's see both of them in detail. First of all, before doing anything, you must recall from AS. You must recall from AS that work done by gases used to have a formula like this. You must recall from AS that work done for gases used to have a formula like this. Pressure into change in volume. You must recall from AS that work done of either of the gas used to be equal to what? Pressure into change in volume. P is pressure, delta V is change in volume. Now let's study about work done by the gas. Let's study about work done by the gas. Okay. Let's say, let's say, you have a gas whose initial volume was, let's say, this VI. The final volume has increased, let's say, VF. You can say that the final volume is greater than the initial volume. You can say the gas has expanded. In this case, what will happen? In this case, you will have work done by the gas. Whenever the gas expands, always remember this. Whenever the gas expands, your work done will be known as what? Work done by the gas. Whenever your gas expands, your work done will be known as what, beta? Work done by the gas. Please, please, please remember this. Whenever your final volume is greater than the initial volume, or whenever your gas is expanding, What will your work done be known as? Work done by the gas. Okay. Sir, what is work done on the gas? The reverse of it. The reverse of it. What is work done on the gas? The reverse of it. Okay. What do you mean by that, sir? Let me show you. If your volume decreases or your gas compresses, let's say your initial volume was this VI, your final volume was this VF. If your initial volume is greater than the final volume, the gas is compressing. That means you have work done on the gas. I hope this is clear. If your gas is expanding, your work done will be work done by the gas. If your gas is contracting or compressing, it will be known as work done on the gas. Okay. Now, sir, like what, why are we studying this? Your question might be very logical. The reason for studying this will be summarized in this one equation. Work done by the gas is equals to negative of work done on the gas. Both work done by the gas and on the gas are calculated with which formula? P is P multiplied by change in volume. And work done by the gas is what? Negative of work done on the gas. Simple as that. Please remember this, that both work done by the gas and on the gas will be calculated with the same formula, that is what? Pressure into change in volume. And work done by the gas is what? Negative of work done on the gas. Simple as that. Nothing complicated here. Sir, what are you saying? Can you give a numerical example? Why negative, sir? Let me tell you. Let me tell you. Let's say, okay, let's give you guys an example here. Let's say this is a piston and let's erase this top part. Let's say this is your piston. Let's say initially the volume of the gas was 18 cm cube. This is the initial volume. Let's say you are compressing it. Let's say you are compressing it. This is the final volume of 20 cm cube. Let's say you have a constant pressure of 100 pascals. Let's say you have a constant pressure of 100 pascals. Okay. Can you calculate work done? Can you calculate work done on the gas? Yes, you can do that because this is compressing. What will you do? You will take pressure into change in volume. What is your pressure? 100 pascals. What will be your change in volume? 20. That is the final volume minus 80, that is the initial volume. You are still forgetting one thing here. The centimeter cubes need to be converted into meter cubes. How will you convert centimeter cube into meter cube? Multiplied by 10 raised to the power of what? 6. Multiplied by 10 raised to the power of minus 6. Sorry. Multiplied by 10 raised to the power of minus 6 will convert centimeter cube into meter cube. Multiplied by 10 raised to the power of minus 6. Can you calculate this answer? Yes, geniuses. Can you calculate this answer? You will notice a very interesting thing. 100 into 60 into 10 raised to the power of minus 6. This comes out to be negative 6 into 10 raised to the power of minus 3 joules. This comes out to be what? Negative 6 into 10 raised to the power of minus 3 joules. You were calculating work done on the gas, and the gas is compressing. And the gas is compressing. So it should have given you a positive value, isn't it? It should have given you a positive value. Don't you agree? If your gas is compressing, shouldn't this have given you a positive value? Here is the important key point here. This formula, that is work done is equals to pressure into change in volume, will always provide you work done by the gas. This formula, that is pressure into change in volume, again listen, this formula, that is pressure into change in volume, will always give you work done by the gas. So this thing is your work done by the gas, not on the gas. Your work done by the gas is coming out to be negative. But since you are, yes, only for ideal gas. Only for ideal gas. Since this is compressing, this comes out to be your work done by the gas. But since this is compressing, you are in the investigation of finding work done on the gas. Because whenever a gas is compressing, you take work done on the gas. How will you calculate work done on the gas? You know work done on the gas is negative of work done by the gas. Negative, negative 3. This comes out to be 6 into 10 raised to the power of minus 3 joules is your work done on the gas. What is the sole important thing that you need to remember here? This formula, that is pressure into change in volume, always gives you work done by the gas. How will you write change in volume? Change in volume is final volume minus initial volume. This formula, pressure into change in volume, always provides you with work done by the gas. However, if a gas is compressing and you need to calculate work done on the gas, you will apply this equation. Because whenever the gas is compressing, your work done on the gas is positive, work done by the gas is negative. All clear up till now. Any ambiguities here? Perfect. Please write a key point here that will sum up this lecture. Whenever you are undergoing expansion, what will happen? Your work done by the gas is positive and your work done on the gas is negative. However, whenever you are undergoing compression, what will happen? Your work done by the gas will be negative, just what we have seen up here, and your work done on the gas will be positive. So this is a key point that you must remember. Whenever you are undergoing expansion, your work done by the gas will be positive, your work done on the gas will be negative. Whenever you are undergoing compression, your work done by the gas will be negative, work done on the gas will be positive. Simple as that. Nothing complicated here. You can write this down if you want to. Now, if you go and discuss things with your colleagues, okay? If you go and discuss things with your colleagues, they will fight with you if you tell them that the first law of thermodynamics is this. Your colleagues will fight you or will argue with you if you tell them that the first law of thermodynamics is this. Because there are two forms or two different ways to write the first law of thermodynamics. First is this one, Q is equals to change in U plus work done by the gas. This is the first way of writing first law of thermodynamics. However, if you bring this work done by the gas to the left hand side, what will happen? Q minus work done by the gas is equals to change in internal energy. And just now we have deduced that negative of work done by the gas is what? Work done on the gas. So replace it here. change in internal energy is equals to Q plus work done on the gas. These are two different ways of writing the same thermodynamic equation. These are two different ways of writing the same thermodynamic equation. First is what? Q is equals to change in internal energy plus work done by the gas. Second way is what? Change in internal energy is equals to Q plus work done on the gas. Simple as that, nothing complicated. Is this thing clear to you guys as well? Any questions here that you want to ask? Any questions here? Thermometer. This is one last topic that is left in thermodynamics. ठीक है? बेटा अपलोडेड ड्राइव पे मैंने भेज दिया है ना वो ड्राइव पे नहीं व्हाट्सएप ग्रुप पे मैं ड्राइव पे भी अपलोड कर दूंगा डोंट वरी अबाउट दैट ये वाले नोट्स भी ड्राइव पे अपलोड हो गए बेटा ओके एनी फिजिकल प्रॉपर्टी दैट चेंजेस विद टेम्परेचर कैन बी यूज टू मेजर टेम्परेचर any physical property that changes with temperature can be used to measure temperature any property that changes with temperature can be utilized to measure temperature. Okay, sir, what do you mean by that? Has everyone here seen a liquid and glass thermometer? In a liquid and glass thermometer, your volume of the mercury either expands or contracts with temperature. Hence, it can be utilized for measuring temperatures. In a liquid and glass thermometer, your volume for mercury expands or contracts. Hence, it can be utilized to measure temperature. Hence, it can be utilized to measure temperature. Okay. Sir, height also changes. Yeah, you can say that as well. Yeah. But primarily, what changes actually? Your volume changes. That's why your height changes. But primarily, your volume changes. That's why your height changes. Okay. This is the first example. What is the second example of a physical property? EMF. In a thermocouple thermometer that we will just see in a minute, your EMF changes with temperature. And thirdly, resistance. In a thermistor thermometer or a resistance thermometer, your resistance changes with temperature. Hence, this can also be used to measure temperature. Don't panic, don't worry. We will see each and everything in great detail. You don't need to worry. Okay, first of all, let's see a liquid and glass thermometer. Let's see a liquid and glass thermometer. A liquid and glass thermometer looks something like this. 1 second. Okay. A liquid and glass thermometer looks something like this. Okay. You have your mercury here, this black shaded area. And let's say at 0 degree centigrade, your mercury expands by 2 centimeter. At 100 degree centigrade, your mercury expands by 22 centimeter. This expansion of mercury enables us to measure temperature. However, let's say I want to calculate a random temperature theta degree centigrade. At that temperature, my expansion of mercury is 12 centimeter. How will I calculate this temperature? Using this formula. Theta is equals to L theta minus L naught divided by L 100 minus L naught. Now what are these L's? L theta is the length of mercury at theta degrees. What is L naught? L naught is the length of mercury at 0 degrees. What is L 100? L 100 is the length of mercury at 100 degrees centigrade. By utilizing this formula, you can calculate all the unknown temperatures in a thermometer. Here, my L theta is what? 12. L naught is 2. L 100 is 22. Your theta comes out to be 50 degrees centigrade. So this unknown temperature is 50 degrees centigrade. However, there is a drawback. There is a drawback of this formula. This formula is based on the assumption that liquid and glass thermometers offer a linear scale. This formula is based on the assumption that liquid and glass thermometers offer a linear scale. However, that's not the case. The scale of a liquid and glass thermometer is non-linear. So the answer obtained in reality will be slightly different. The answer obtained in reality will be slightly different from the actual temperature. Now let's move on to the second type of thermometers, that is thermocouple thermometers. Okay, what are thermocouple thermometers? Let's see what are thermocouple thermometers. In a thermocouple thermometers, firstly, bit by bit, you don't need to digest everything at once. Aram se. In a thermocouple thermometer, you have two metal wires like this, and like this. Okay, these are two metal wires. Perfect. A voltmeter is connected here. This is your voltmeter. Okay. One end of the thermocouple thermometer is at pure melting ice. One end of the thermometer is at pure melting ice at 0 degrees centigrade. Okay. This is known as the cold junction or the reference point. The other end of the thermocouple thermometer is at an unknown temperature theta degree centigrade. See what is happening. You have two junctions or two reference points in a thermocouple thermometer. One is at the cold junction at 0 degree centigrade, other is at an unknown temperature theta degree centigrade. Okay. What will happen, sir? What will happen, or what is the procedure here that we will follow? Electrons will flow from a lower temperature to a higher temperature. Electrons will flow from a lower temperature to a higher temperature. Electrons flow from a higher temperature to a lower temperature. ठीक है. इलेक्ट्रॉन्स बेटा हायर टेम्परेचर से उठ के लोअर टेम्परेचर की तरफ आ रहे होंगे लाइक दिस. This movement of electrons is recorded by the voltmeter. This movement of electrons is recorded by the voltmeter. Okay. Now let's say the voltmeter is recording a reading of 5 millivolts or 10 millivolts. Okay? Let's say the voltmeter is recording a reading of 5 millivolts or 10 millivolts. How will you calculate the temperature using these voltage values? How will you calculate the temperature using the voltage values? Any ideas? Yes. How will you calculate the voltage using these? How will you calculate the temperature using these voltage values? There are something known as calibration charts. There are something known as calibration charts. Calibration charts में बेटा क्या होता है? You can give it an EMF value and it will give out a temperature value. So what is happening actually? You take a thermocouple thermometer, you place one end at 0 degree centigrade, that is the cold junction, and you place the other end at the hot junction or the temperature that you want to calculate. Electrons will flow from the hot junction into the cold junction. This flow of electrons is recorded by this voltmeter, let's say 10 millivolts. Then you are provided with calibration graphs through which you can see how much voltage corresponds to how much temperature. Let's say 5 millivolts is corresponding to 117 degrees centigrade. Simple as that, you can find the temperature like this. Any ambiguities here? Anything that confuses you guys here? There are a lot of things to discuss further, but up till now, theory clear is key. One more thing to remember is that thermocouple thermometers also have a non-linear scale. Thermocouple thermometer also have a non-linear scale. However, देखो एग्जाम में कीवर्ड्स होंगे. However, if the examiner tells you to assume thermocouple as a linear scale, then you can apply this formula. However, if the examiner tells you to assume thermocouple as a linear scale, then you can apply this formula. How can you calculate the unknown temperature if thermocouple is assumed to be a linear scale? You measure the EMF through the voltmeter. This is the voltage at unknown temperature. What is V naught? Voltage at 0 degree centigrade. What is V100? Voltage at 100 degrees centigrade. Simple. Won't there be two? Yeah. Umar, very good observation, yeah. Very good observation, Umar. I am coming to this point. Is there topical for this part of thermodynamics? Yes, there are certain topicals. एक दो सवाल हैं इससे related. We will do that. Don't worry about. Umar, what a point you have highlighted. Very good. इस point को भी दिमाग में रखो. शाबाश. Does everyone understand what to do with thermocouple thermometers? Now, on the looks of it, थर्मोकपल थर्मोमीटर के बहुत सारे एडवांटेजेस आपको लग रहे होंगे. From the looks of it, thermocouple thermometer might be looking very advantageous. Okay, it has multiple advantages. First of all, it has a very wide range. It has a very wide range of temperature measure, that is minus 250 degrees centigrade to 1150 degrees centigrade. The metals used in thermocouple thermometer have a very low specific heat capacity. This means the percentage error in the reading will be less. And they can measure localized temperature. That means they can measure temperature in a specific region. Where are thermocouple thermometers most commonly used? In furnaces. In furnaces. Okay. Now, sir, is thermocouple thermometer the best thermometer in the world? Does it have no disadvantages? No. It has many disadvantages. First disadvantage is highlighted by a student named Umar, and what a point it was. What a point it is. The first disadvantage of thermocouple thermometer is if you observe the calibration graph has a turning point. That means for the same EMF, you will have two temperatures. Here it is written. Since the graph has a turning point, for certain values of voltage, there will be two temperatures. Secondly, thermocouple thermometer is not equally sensitive for all temperatures. Third disadvantage, non-linear scale. Fourth disadvantage, thermocouple thermometer is quite big in size. It is not portable. Just like a liquid and glass thermometer can be carried in pockets as well. Thermocouple thermometers cannot be carried like that. It is pretty big in size and you need proper equipment to carry it from one place to another. Okay. First of all, chill, relax, just sit back and listen what is happening. What is the thermistor? Thermistor looks something like this. As the temperature of the thermistor increases, the resistance decreases. Okay. Let's say this is an unknown liquid of temperature theta degree centigrade. Let's say this is an unknown liquid of temperature theta degree centigrade. Okay. You have placed a thermistor in this liquid and you have connected a voltmeter in parallel and an ammeter in series. With the voltmeter, you will record the voltage. With the ammeter, you will record the current. Can you calculate the resistance of the thermistor? R is equals to V over I. Let's say your voltmeter was giving a reading of 5 volts. Your current was giving a reading of 20 milliampere. You divide both of them, you get the resistance of the thermistor. Now you will say, sir, this is a prank with me. I had to calculate temperature. You are saying me to calculate resistance. This is a prank with me. You are provided with calibration graphs from where you can locate the resistance and your temperature will be given. Let's say 250 ohm resistance give a temperature of 55 degrees centigrade. Simple as that. Now, one more thing. If the examiner tells you to assume a linear scale for the thermistor, you can apply this formula. Chapter number 5 for A2 level physics, ideal gases. Okay. So, first of all, in ideal gases, we will be looking at some assumptions of ideal gases. First of all, in ideal gases, we will be looking at some of the assumptions of ideal gases. Okay. There are five assumptions of ideal gases that you need to remember. There are five assumptions of ideal gases that you need to remember. Okay. What are those assumptions? Bhai? First assumption. Assumption number one. Ideal gases have negligible intermolecular forces of attraction. Okay. This becomes your first assumption. What is your second assumption? The size of molecules of gases is negligible compared to the volume of the gas. Basically, the second assumption means that, let's say, your volume of the gas is equal to this volume of this container, let's say Vg. The volume of one molecule is, let's say, small v. This small v is negligible or very, very less compared to the volume of the gas. Second assumption says that the size of molecules is negligible compared to the volume of the gas, as I have stated here. Third assumption, collision between the molecules is perfectly elastic. Fourth assumption, time of collision between molecules is negligible compared to the time between successive collisions. And fifth assumption, the gas molecules are in continuous random motion. For examinations, I would advise you guys to remember these four assumptions. You can skip the fourth one, लेकिन ये four assumptions आपको याद होनी चाहिए. Let's further move ahead. Let's further move ahead. Chalo, let's further move ahead. Now, let's study Boyle's law. You can write down the heading of Boyle's law. Okay, what does Boyle's law state by? Boyle's law basically states that a fixed mass of gas, the volume of gas is inversely proportional to temperature. Boyle's law क्या state करता है बेटा? Boyle's law basically states that for a fixed mass of gas at constant temperature, the volume is inversely proportional to pressure. Simple as that, nothing complicated here. Okay, now how to write this law? This law can be easily written like this: pressure is inversely proportional to volume. In this Boyle's law, two things are fixed: your mass and your temperature. Mass and temperature are assumed to be constant. Mass and temperature are assumed to be constant. Okay. Pressure is inversely proportional to volume, and mass and temperature are supposed to be constant. Okay. Now, usually you are asked to draw the graph of pressure versus volume as well. How will the graph of pressure versus volume look like? Somewhat like this. Pressure, volume. This will look an inverse proportionality graph like this. If you are stating Boyle's law ka graph, it will go something along these lines. Pressure is inversely proportional to volume. Your pressure axis can be labeled in pascals. Your volume axis can be labeled in meter cube. So what does Boyle's law state? Boyle's law state that at a constant temperature, your pressure is inversely proportional to volume. Perfect. Charles law क्या कहता है बेटा? Charles law basically states volume of the gas is directly proportional to the temperature provided that pressure remains constant. Volume is directly proportional to temperature. Now, what is constant? Pressure remains constant. Okay. Pressure remains constant. Please focus on the board. You don't need to copy. Okay. Now, okay, that's great. Pressure, volume, and temperature are directly proportional. That's great. Avogadro's law states that for a gas at constant pressure and temperature, okay, so for this, you have an assumption of what? Constant pressure and temperature. For a gas of constant pressure and temperature, volume of gas is directly proportional to the number of moles. This is your Avogadro's law. For a gas at constant pressure and temperature, the volume of a gas is directly proportional to the number of moles. If I remove the direct proportionality sign, I will get a constant K. And hence, Avogadro's law can also be represented in this form. Now, a frequently asked question. A frequently asked question. Believe me, just give me 5 minutes. All this will make so much sense that you will say physics is amazing. Let me show you. Up till now, we have studied three equations. Volume is inversely proportional to pressure, Boyle's law. Volume is directly proportional to the number of moles, and volume is directly proportional to temperature. If I write them in a combined format, this will be your answer. Okay. Let's bring P to the other side. PV directly proportional NT. If I remove the direct proportionality sign, you will see a very familiar equation. PV is equals to nRT. This is your ideal gas equation that you need to remember. This is your ideal gas equation that you need to remember. Now, can you realize that I have calculated this PV is equals to nRT through the three laws that we studied? Okay, what is P here, beta? P is your pressure. Okay, what is V here? V is your volume. So, these are your quantities. P is your pressure measured in pascals, V is your volume measured in meter cube, N is your number of moles, R is your universal gas constant, and what is T? T is your temperature in Kelvins. Temperature measured in Kelvins. And this is your ideal gas equation. Ideal gas equation. Okay, now since we know ideal gas equation, how can we define ideal gas? Now the definition of ideal gas gets very easy. Any gas that obeys PV is equals to nRT. Any gas that obeys PV is equals to nRT for all values of temperature, pressure and volume is known as an ideal gas. Simple, basic. Physics is not that difficult. From O level chemistry, just relax it back. You will be able to know all these 2 points. Don't worry. From O level chemistry, we studied that we can calculate the number of moles of an element by dividing the mass with the atomic number or molecular number. Okay, sir, what do you mean by that? Let's say I have given you helium 42 and I have given you 4 grams of helium. Can you calculate the moles of helium? Yes. Take 4 grams divided by the mass number. That is 4. This is your mass number. The thing written on the top is your mass number. Okay. The thing written on the top is your mass number. 4 divided by 4, the number of moles are 1. Simple. So whenever you have to calculate what? Whenever you have to calculate the number of moles, you divide the mass by the atomic number or molecular number. Simple. Okay. How will you calculate the number of molecules or atoms? Okay. Very easy. Always remember 1 mole of any atom has 1 mole of any element has 6.02 into 10 raised to the power of 23 molecules. 1 mole of any element, any atom has this amount of atoms or molecules. Okay. So if you want to calculate the number of molecules in n number of moles, you will multiply the number of moles by the Avogadro's number. These are the two things that I require you to know before continuing on to the next thing. What is the first thing? First thing is that number of moles can be represented as what? Mass divided by the mass number. And number of molecules in any atom, any element, you can derive it how? Number of moles को multiply कर दो with the Avogadro's number, you will get the number of molecules. Simple. Now, sir, how are we going to utilize this? Very, very easy. Very easy. Just look at what I'm doing. PV is equals to nRT is your formula, right? And just now we have studied that number of moles is equals to what? Number of molecules is equals to what? Number of moles multiplied by the Avogadro's constant. Can I make n the subject here? Can I make number of molecules number of moles the subject here? Yes. N divided by Na. Let's place it here. PV is equals to what? N divided by NaRT. I have just replaced what? I have just replaced N with what? N divided by Na. What is Na? Avogadro's number. That is 6.02 into 10 is the power of 23. Okay. Now, if you closely focus here, this R is also a constant, universal gas constant. Na is also a constant, Avogadro's number. So you can do something like this. PV is equals to capital N R divided by Na into T. This R divided by Na has a specific name. This R divided by Na has a specific name. Can anyone guess? 8.314 divided by 6.02 into 10 raised to the power of 23. Will anyone calculate this? This comes out to be 1.38 into 10 raised to the power of minus 23. This is known as what? This is known as K or Boltzmann constant. This is known as K, or you can say Boltzmann constant. So you can replace this entire R over Na by what? PV is equals to NKT. This is your second way of writing the ideal gas equation. Okay, this is the second way of writing the ideal gas equation. Any questions that you guys have, you can ask me right now. Shabash Wahab, very good on guessing this. Okay, this is a cuboid, this contains gas particles, this is a container. Okay, like this. Or you can say this is a cube. Let's say this is a cube. Let's say this is a cube with each side as L. This is L, this is L, and the back side is also L. This is the cube, all the sides are equal to L. It is filled with gas. Okay. Let's consider the front face only. Let's consider this face. Let's consider this face. Okay. So let's make that face here. Yep. Something like this. It will have a length of L and a breadth of L. Okay. Let's say we have a gas particle here. Let's say we have a gas particle here. Somewhat like this. It is traveling with a speed of Cx. So this is a molecule of gas that is traveling with a speed of Cx. It collides with the wall and that molecule of gas starts traveling towards the left with a speed of Cx. Okay. Now, first of all, tell me how can I calculate the change in momentum of this gas molecule? Can I calculate the change in momentum of this gas molecule? Yes, surely I can do that. How will I calculate the change in momentum of this gas molecule? Pretty easy. I can say that the gas molecule is initially moving with a speed of cx. It hits the container, moves with a speed of negative cx. And the mass of the gas molecule is, let's say, m, small m. So change in momentum will become what? Negative m cx, because the final velocity was towards left, minus m cx. This becomes negative 2m cx is your change in momentum. Okay. Now once you have the change in momentum, can you calculate the force? Yes, you can surely calculate that. You can surely calculate the change force as well. Okay. What is force equal to? From AS level, what have you guys studied? What have you guys studied? आज ही पढ़ के आ रहे हैं कुछ लोग तो. एक का साइन पॉजिटिव नहीं होगा. रेट ऑफ चेंज ऑफ मोमेंटम, वेरी गुड. सर एक का साइन पॉजिटिव नहीं होगा. नहीं बेटा, एक का साइन पॉजिटिव कैसे होगा? देखो, चेंज इन मोमेंटम हमने क्या पढ़ा है बेटा, क्या होता है? चेंज इन मोमेंटम इज इक्वल्स टू मोमेंटम फाइनल माइनस मोमेंटम इनिशियल. लेट्स से राइट साइड इज पॉजिटिव, लेफ्ट साइड इज नेगेटिव. ओके, फाइनल मोमेंटम किसके इक्वल हो जाएगा बेटा? m मल्टीप्लाइड बाय माइनस सी एक्स. माइनस इनिशियल मोमेंटम किसके इक्वल हो जाएगा? m मल्टीप्लाइड बाय सी एक्स. दोनों का साइन नेगेटिव होगा ना. ओके. एक का साइन नेगेटिव है ड्यू टू दिस डिफरेंस, एंड दूसरे का साइन नेगेटिव है ड्यू टू द डायरेक्शन. ओके, चलो अब आगे बढ़ते हैं भाई. नाउ कैन यू कैलकुलेट द फोर्स ऑन वन मॉलिक्यूल? यस. Force on one molecule will be equal to what? Change in momentum over change in time. Okay. Now, this negative sign on the force is of no use to me. This negative sign of force is of no use to me. Why? Because this is only telling me the direction. This is only telling me the force is acting towards the left hand side. And if I calculate the force on wall due to one molecule, that is this red arrow, it will become positive. So what can I do is, I can ignore the negative sign from the force. My force will become what? 2m cx divided by change in time. Okay. Now things are getting interesting if you pay attention. Things are getting interesting if you pay attention. Okay. Now, if you notice, this force is for only one molecule. If you notice, this force is for only one molecule. Okay. Sir, how to calculate the force for the entire gas or for all the molecules? You multiply this force by the number of molecules, that is capital N. You multiply this force by the number of molecules or capital N. Something along these lines. Something along these lines. You multiply the force by capital N. This comes out to be a total force. Okay. Now, once you have the total force, the change in time is not suiting our equation too much. The change in time is not suiting our equation too much. I would like to replace that. How will I do that? If I notice this particle is traveling a length of what? 2L, and has a speed of what? Cx. Can I calculate change in time? Yes, I can replace change in time with what? I can replace change in time with distance over what? Speed. Distance is what beta? 2L. The speed of the particle is what? Cx. Replace this change in time with what? 2L over Cx. Perfect. Perfect. Replace it with 2L over Cx. ठीक है, कर दो replace भाई. What does your answer of force now come out to be? Your answer of force now comes out to be something like this. Force is equals to 2n mcx over 2l over cx. This comes out to be your formula for force. Okay. Now you will say me, sir, you are pranking with us. Why? Because the heading of our topic was pressure of gases. and we are calculating force. Hmm, this doesn't make sense. We are moving on to pressure. Just a second. We are moving on to pressure. What is the formula of pressure? Pressure is equal to force over area. Okay. And which phase have we considered, beta? हमने कौन सा phase consider किया है? This one. What will be the area of this phase? L into L. So yeah, we can actually calculate the pressure as well here. The pressure will be equal to what? Pressure will be equal to somewhat like this. Somewhat along these lines. Pressure is equal to force over area. The phase is L multiplied by L. Area becomes L square. Force divided by L square. Your pressure ka formula comes out to be this. Pressure is equal to capital N mcx square divided by L cube. Simple. Now, if you are smart enough, you will notice a very interesting thing here. If you are smart enough, you will notice a very interesting thing here. Okay, sir, what is that interesting thing? Do you realize that density is equals to mass over volume? Yes, sir, density is equals to mass over volume. But how has density come here all of a sudden? Just wait and watch. Just wait and watch. You know that density is equals to mass over volume. What would be the total mass of the gas? Number of molecules multiplied by the mass of one molecule. This is the total mass of the gas. What will be the volume of the gas equal to? The volume of the cuboid, that is L cube. Can you see indirectly Nm over L cube is what? Density of the gas. So basically your formula of pressure for a gas can be concise to this value. Pressure of any gas is equals to density multiplied by Cx square. All clear up till now? Any ambiguities? Perfect है हुसैन को समझ आ गई that's good. Yes sir, clear, very good. चलो let's further move on. Now here I have assumed a very childish thing. I have assumed a very childish thing in the start, and you guys also didn't stop me from doing that. I have assumed that the particles will only travel in the x direction. That's a very absurd assumption to do. I have assumed that the particles will only travel in the x direction. That's why my velocity was cx. But the particles can travel in all three dimensions x, y, and z. How to solve for this? How to correct this? How to correct this? Now, since particles travel in all directions, there are some assumptions that we make. Okay, what are those assumptions? We believe that the total velocity or the resultant velocity. Now, please pay attention. To account for all the three dimensions, what do we do? To account for all the three dimensions, what do we do? We apply a very simple logic. We say that the total velocity, that is c square bracket. Currently, I am saying it as c square bracket. You will get to know there is a specific term for this. Currently, I am referring it as c square bracket or the total speed. Okay, let's say this as total speed square. Total speed square. The total speed square will be equal to what? The square of speed in the x direction, the square of speed in the y direction, and the square of speed in the z direction. Okay. And here I have made a slightly lesser absurd assumption that all three velocities will be same. In the x, y, and z directions, the velocities will be same. Okay. Now, if all three velocities will be same, this will become what? 3cx square. C square bracket divided by 3 will give you cx square. What was your initial formula? Initial formula was pressure is equals to density into Cx square. Now in place of Cx square, I am placing this bracket Cu square over 3. Let's do that. Pressure is equals to rho Cu square over 3. This comes out to be 1 over 3 into pressure into Cu square. This is your correct formula for pressure of a gas. This is your correct formula for pressure of a gas. Now the total speed square and C square bracket are very baseless terms. There are specific terms for bracket cu square in the examination. First of all, you need to understand that the formula that you need to remember by heart is this one. Pressure of a gas is equals to 1 upon 3 into density into bracket cu square. This P is the pressure of the gas, rho is the density of the gas, and what is this bracket cu square? Let's discuss this in great detail now. Now is the time to discuss this in great detail. If in examination this is written bracket cu square, this is known as mean square speed of gas molecules. This cu square is known as what? Mean square speed of gas molecules. What do you mean by that, sir? What do you mean by that, sir? Let's say you have 5 molecules. Let's say you have 5 gas molecules. Let's say you have 5 gas molecules like this. 1, 2, 3, 4, 5. You have 5 gas molecules like this. Let's say the speed of one is 4.5 ms minus 1. The speed of the second one is, let's say, 6 ms minus 1. The speed of the third one is, let's say, 4 ms minus 1. The speed of the fourth is, let's say, 8 ms minus 1. And let's say the speed of the fifth is 10 ms minus 1. You are given 5 gas molecules. How will you calculate the mean square speed? The calculations lie in the name. Mean square speed of gas molecules. First of all, you will square all these speeds. 4.5 square, 6 square plus 8 square plus 4 square plus 10 square. And then you will take their mean divided by 5 to calculate bracket cu square. And this is how you calculate mean square speed. Can anyone calculate this and tell me the answer, please? Now, take average. Yes. The answer, the calculation method of cu square or mean square speed lies in the name. First, you square all the speeds and then you take their mean. First, you square all the speeds and then you take their mean. Yep. Anyone who will tell me the answer of bracket cu square or mean square speed? What will be the answer to this? Anyone? 47.25 ms minus 1. Pretty correct. 47.25 ms minus 1. Okay. Now, I guess mean square speed term is clear to you. Now, there is a more, you can say, frequent term or a favorite term of examiner that the examiner uses than mean square speed. बेटा मीन स्क्वायर स्पीड से भी ज़्यादा एग्जामिनर को एक और टर्म पसंद है. What is that term? That is CRMS. That is mean. That is, please focus on the name. Root mean square speed of molecules, of gas molecules, you can say. That would be a better thing. Root mean square speed of the gas molecules. Okay. And CRMS or root mean square speed is under root of C square. CRMS is under root of root mean square speed, and it is also evident in the name. First of all, take a square, then take a mean, then take an under root. For the above example, your cu square or your mean square speed was coming out to be what? 47.25. Can anyone tell me what will CRMS come out to be for this above example? CRMS is equals to under root 47.25. Anyone with the correct answer? Anyone with the correct answer? Yes. 6.87 ms minus 1. 6.87 ms minus 1. So these are the two terms that you must remember. Root mean square speed and mean square speed. Now, let's come on to one more thing that I have kept a secret from you guys. Beta, in the start of chapter 3, I told you guys one thing. In the start of chapter 3, I told you a very simple secret that kinetic energy is directly proportional to temperature. As temperature increases, kinetic energy increases. As temperature decreases, kinetic energy decreases. I never ever told you the logic behind it. Do you remember that I never ever told you the logic behind it? Hmm. Yes, do you remember? Yes, I remember if you don't. That I never told you the logic behind it. Okay. So, what is the logic behind it? Let's study now. Let's study now. What is the logic behind it? We know that pressure of a gas is equals to what? Pressure of a gas can now be represented with this formula 1 over 3 density into mean square speed. And now I can replace this density with what? Total mass of the gas, that is Nm divided by the total volume. Multiply V to the other side. Multiply V to the other side, it becomes what? PV is equals to 1 over 2 Nm mean square speed. Now I taught you guys an equation. अभी 30 minutes पहले I taught you guys an equation. This equation was PV is equals to NKT. This equation was PV is equals to NKT. Sir, what is the purpose of this? If I substitute, second, if I substitute NKT instead of PV, because I know PV is equals to NKT, what will happen? 1 over 3 capital N capital M mean square speed. Is anything getting cancelled out, beta? Yes. N and N gets cancelled out. Let's take 3 to the other side. This becomes what? 3 KT. Okay. Always remember Boltzmann constant is written with a small k. 3 KT is equals to MC square. Now, this at first glance will seem very, very. But if you notice, kinetic energy is equals to what? Kinetic energy is equals to 1 upon 2 mv square. Can you see you already have m and velocity square? Velocity square of the gas. If you divide the equation by 2, divide equation by 2, what will happen? 3 over 2 kT is equals to 1 over 2 m mean square speed. This 1 over 2 mcu square is what? Okay, this is also important. This 1 over 2 mcu square, this thing is the kinetic energy of one molecule. Is the kinetic energy of one molecule. So you can replace it. 3 upon 2 kT is equals to the kinetic energy of one molecule. Now, if you notice If you have a keen eye for observation, you will notice that 3 upon 2 is also a constant. K, Boltzmann constant, is also a constant. Kinetic energy becomes directly proportional to temperature. Hence, temperature is directly proportional to kinetic energy, or you can say kinetic energy is directly proportional to temperature. Why in chapter number 5, oh sorry, chapter number 3, I told you that kinetic energy is directly proportional to temperature? This was the reasoning behind it. Any questions here? This marks the end of ideal gases. Any questions here? Simple harmonic motion or oscillations, chapter number 6. Let's start with it. ठीक है बेटा, लेट्स से अगर मैं आपको कोई एक मोशन दे दूं यार, एक आपका मैं सामने कोई मोशन रख दूं एक किसी बॉडी का, हाउ विल यू नो दैट इट इज सिंपल हार्मोनिक? किस तरह हम पता लगा सकते हैं दैट एनी मोशन इज अ सिंपल हार्मोनिक मोशन? सिंपल से 3 पॉइंट हैं, दो अभी समझ आ जाएंगे, तीसरा पॉइंट समझने के लिए थोड़ा 5 मिनट वेट करना पड़ेगा. If your motion is simple harmonic motion, if your motion is simple harmonic motion, it will be a periodic motion or a repetitive motion, the first property. The first property of simple harmonic motion is what? It is a periodic or a repetitive motion. ठीक है, बार बार अपने साइकिल को रिपीट करता रहता है. ओके. Second property of simple harmonic motion. Second property of simple harmonic motion. The second property of simple harmonic motion is that acceleration is. अच्छा, सेकेंड पॉइंट को लिखने का एक और तरीका जो मार्किंग स्कीम में यूजुअली देखोगे, दैट इज एक्सेलरेशन इज डायरेक्टली प्रोपोर्शनल टू डिस्प्लेसमेंट बट इन द ऑपोजिट डायरेक्शन. ये भी मार्किंग स्कीम में लिखा होता है. यस यस यस, यू आर परफेक्टली करेक्ट. सेकेंड पॉइंट को आप इस तरह भी लिख सकते हो बेटा, दैट एक्सेलरेशन इज डायरेक्टली प्रोपोर्शनल टू डिस्प्लेसमेंट बट इन द ऑपोजिट डायरेक्शन. ओके. अच्छा, नाउ कम हियर. ऑलवेज रिमेंबर, एएस लेवल फिजिक्स हो, ओ लेवल फिजिक्स हो, A2 फिजिक्स हो, PhD फिजिक्स हो, इफ यू रिमूव डायरेक्ट प्रोपोर्शनैलिटी साइन, there will always be a constant. If you remove direct proportionality sign, there will always be a constant. In this case, the constant is what? In this case, the constant is W square. Sir, W square क्या है? बेटा चैप्टर 1 में किसने ध्यान दिया था? W square is your angular frequency square. Please recap. I joined a bit late. Sure. चल. So we were studying simple harmonic motion. A simple harmonic motion के first 2 points हमने पढ़े. We have studied the first 2 points of simple harmonic motion. The first point is that simple harmonic motion is periodic and repetitive. The second point is that in a simple harmonic motion, acceleration is directly proportional to the negative of displacement. You can also write the second point like this: acceleration is directly proportional to displacement but in the opposite direction due to the negative sign. Now always remember, whenever you remove the direct proportionality sign, you will get what? You will get a constant. Whenever we are doing simple harmonic motion, that constant is W square or angular frequency square. Now you will ask, sir W कैसे निकालें? जिन्होंने चैप्टर 1 सही से नहीं पढ़ा वो सर से पूछेंगे, सर W कैसे निकालें? W has two formulas, 2 pi into frequency and W is equals to 2 pi over T. There is a third formula for W as well, which I expect only A star students to remember. W is equals to 2 pi N over 60, N being your RPM. Kindly revise the first chapter if you don't know any of these formulas. Okay. Now, you might see a very confusing term here. A restoring force acts towards the mean position all the time during oscillation. Now, let's say I am pretty curious and I sought out to draw a graph of acceleration and displacement. Acceleration on the y-axis, displacement on the x-axis. I draw a graph like this. Let's say I have drawn this blue graph. Let's say I have drawn this blue graph. What will be the gradient of this graph? The gradient of this graph will be equal to negative w square. If you apply the equation y is equals to mx, the gradient of this graph will be equal to what? W square. Yeah, negative w square. It's better to phrase it as negative w square. Okay. Now, just focus a little more. थोड़ा सा और फोकस चाहिए मुझे तुम लोगों का, थोड़ा सा और फोकस. Let's say I want to draw a graph for a greater W value. What will happen? Your gradient will increase. This is your green line. Simple. And always remember, whenever you are drawing a graph of acceleration versus displacement, it will have a downward slope because your gradient will be negative. It will always have a downward slope because your gradient will be negative. That is negative w square. Perfect है. आगे बढ़े. चलो, let's further move ahead. Now, the first thing that we need to discuss today, the first and foremost thing that we need to discuss today is equations for velocity, displacement, and acceleration of simple harmonic motion. The first thing that we need to discuss today is to discuss the equations of displacement, velocity, and acceleration of simple harmonic motion. Okay. Now, there are two situations. There are two situations. The first situation is if the motion is starting from maximum displacement. If the motion is starting from maximum displacement, or you can say the motion is starting from what? Extreme position. If the motion is starting from maximum displacement, or you can say extreme position, what will be your equations for velocity, displacement, acceleration, and furthermore? If you are starting from maximum displacement, if you are starting from maximum displacement or from the extreme position, please remember that your equation for displacement will look something like this. If you are starting from the maximum displacement, your equation for displacement will look something like this. X is equals to x naught cos wt, where x naught is what? Where x naught is your amplitude, where x naught is your amplitude, or you can say maximum displacement. Maximum displacement. Simple as that. Where x naught is your maximum displacement, and your equation for displacement will be x naught cos wt. Whenever you are starting from the extreme position or the maximum displacement, your equation for displacement will become what? X is equals to x naught cos wt, where x naught is your amplitude or maximum displacement. Cos wt is the function on which the graph will be plotted. Here, what is w? Beta, here, what is w? W is your angular frequency. W is your angular frequency. Now, if you have studied a little bit of mathematics, you might know that if we differentiate displacement, we will get what? We will be getting velocity. If we differentiate displacement, we will be getting velocity. Okay, let's do that. Let's differentiate displacement to get velocity. So if I differentiate this, my answer will come out to be this. If I differentiate this displacement equation, this will be my answer. Here, can you see, for non-mathematics students, I am just doing this for non-mathematics students, जिन्होंने mathematics पढ़ी है, they already know this. The differentiation of cos wt is what? Negative sine wt, negative sine wt multiplied by w. This is the differentiation of cos wt, x naught remains same. Okay, multiply both of them, this comes out to be your velocity equation. Velocity is equals to negative x naught w. Is w constant? Yeah, you can say that. W into sine wt. Okay. Now you must also remember that the maximum velocity or V naught is equals to what? X naught W. Maximum velocity is equals to what? Amplitude into W. This comes out to be your V naught is equals to X naught W. You can replace this entire thing, X naught W, with what? V naught. Replace it. Your velocity equation comes out to be what? Velocity is equals to negative V naught sine WT. This will be your graph. Simple. Now, those of you who have studied a little bit of mathematics more might know. Differentiation learn करनी है? No, you just remember that velocity की equation ये होगी, displacement की equation ये होगी. If you are starting from the maximum displacement, just remember this. If you can't remember differentiation, you can remember this. Okay. Now, for those of you who have further studied mathematics, might know that if you differentiate velocity, you get what? You get acceleration. So let's do that. Let's differentiate x naught w sine wt. Again, for non-mathematics students, let me tell you, sine wt has a differentiation of what? W cos wt. W cos wt is the differentiation of sine. Let's multiply it with the original equation. You get this as your acceleration key equation. Simple. This is your equation for acceleration. Acceleration is equal to negative x naught w square cos wt. Now you must also remember that maximum acceleration a naught is equal to what? X naught w square. A naught is your maximum acceleration. And this is your curve for that. Simple as that. If you have any questions here, you may ask. These are the displacement, velocity, and acceleration graphs when you are starting from the maximum displacement. These are the acceleration, velocity, and displacement graph when you are perfect. Chalo, let's start further. Now, let's say you are starting from the mean position. Okay. Whenever you are starting from the mean position, your equations change slightly. Whenever you are starting from the mean position, or you can say zero displacement, your equations change slightly. Okay, how do my equations change, sir? Whenever you are starting from the mean position or zero displacement, your displacement equation becomes what? X naught sine WT. Simple as that. Okay. And what does your velocity equation becomes? X naught W cos WT. We all know that X naught W is what? Maximum velocity V naught. This becomes velocity is equals to V naught cos WT. If you further differentiate it, your acceleration becomes what? Minus X naught W square sine WT. And we all know X naught W square is your maximum acceleration. You put it here. A naught sine WT is your acceleration equation. Simple as that. Mean position ki bhi, I hope so. It is clear to you. Now, let's do one thing. Now, obviously, you just need to remember. If those of you who are weak at mathematics, just remember these three equations for extreme positions, and just remember these three equations for mean positions. Simple as that. You don't need to go into differentiation. Perfect. Let's further move ahead. Now, let's relate velocity and displacement. Let's relate velocity and displacement. Okay, let's do that. Let's relate velocity and displacement. So, at mean position, at mean position, or at zero displacement, can you guys tell me what was your displacement equation? At mean position or zero displacement, can you tell me what was your displacement equation? X is equals to x naught sine WT. Okay, let's place it here. X is equals to x naught sine WT. And at mean position, what was your equation for velocity? Velocity is equals to x naught W cosine Wt. Now let's do a thing here. Let's make sine Wt the subject here, and let's make cosine Wt the subject here. Just observe what I'm going to do here. X over x naught is equals to your sine Wt, and V over x naught W is equals to your cosine Wt. Now, all of you might have studied in mathematics. All of you might have studied in mathematics that cosine square theta plus sine square theta is equals to 1. Okay, what is your cosine Wt? V over x naught W. V over x naught W square. Plus, what is your sine theta? X over x naught square is equals to 1. This becomes what? V square plus x square divided by x naught W divided by x naught is equals to 1. Let's take the LCM now. Let's take the LCM now. What can we do? We can multiply this by W, multiply this by W. What happens? V square plus x square W divided by x naught W is equals to 1. Oh, sorry. You have to put squares here as well. You have to put squares here as well. These all will be squares due to the square function. Okay. Now, let's take this denominator to the other side. Let's take this denominator to the other side. This becomes what? V square plus x square W square is equals to x naught square W square. V square is equal to square minus x square W square. Let's take W square as common. X naught square minus x square. Let's take under root on both sides. Velocity comes out to be what? Plus minus W. X naught square minus x square. This is the formula that you need to remember. This is the formula that you need to remember that relates velocity and displacement. This is the formula that relates velocity and displacement. All clear up till now? Any ambiguities? Nabeha, Wahab, and Safat and Michel. Any ambiguities here? Now let's say I want to plot a graph of velocity versus displacement. Let's say I want to plot a graph of velocity versus displacement. Velocity on the y-axis and displacement on the x-axis. Please pay attention. These types of graphs have been quite repetitive in the recent years. These types of graphs, very good Wahab, very good. These types of graphs have been quite repeating in recent years, so please focus here on the board. We have to draw a graph of velocity versus displacement. Okay. So let's first of all assume the extreme position. Let's first of all assume the extreme position. Okay. Can you guys tell me what will happen at the extreme position? Yes, any geniuses? At extreme position, my displacement x will be equal to x naught. Okay. So what will my velocity be equal to? Plus minus w under root x naught square, and my x becomes equals to what? X naught. So minus x naught square. This entire thing will become 0. Anything multiplied by 0 will give you a value of 0. So velocity is 0 at extreme positions. Velocity is 0 at extreme positions. How will you show that? You will say that let's say this is the positive extreme position plus x naught. Here the velocity is 0, and here at the negative extreme positions, here as well the velocity is 0. Okay. Now let's try out the mean position. Let's try out the mean position. Mean position. What do you think happens at mean position? At mean position, your displacement x is equals to 0. Your velocity is equals to plus minus w x naught square minus 0 square. Velocity is equals to plus minus w x naught. Can you guys remember from earlier in the lecture? बेटा आज हमने previously in the lecture क्या पढ़ा है? That velocity maximum is equals to what? X naught w. So here as well, you are getting what? Here as well, you are getting x naught w. So this velocity v naught is your maximum velocity. That means at the mean position, you will have your maximum velocity when x is 0. So how will you represent that? When x is 0, your velocity is v naught. When x is 0, your velocity 1, 2, 3, 4, 5. 1, 2, 3. Okay, 1, 2, 3, 4, 5, 6. Okay. Here you will have your velocity. Can I draw a curve through these points? Yes. Let me choose a different color. This would get pretty similar. This will be an oval shaped curve. Is this graph clear to all of you? बेटा अगर clear नहीं है any part that you find difficult, do tell me. Michelle beta, is this clear to you? You have just joined. Oscillating body in simple harmonic motion. The first type of energy that we will be studying is kinetic energy. Okay, just I want your undivided attention here, please, please, please. Kinetic energy has a formula of what? 1 upon 2 mv square. Have we studied any formula for velocity? Any formulas for velocity? Yes. Have we studied any formulas for velocity? Can I replace it in the kinetic energy ki velocity wala formula? Yes. Yes, 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 you can do that. Here, I remember from my previous adventures in physics that plus minus w, x naught w square minus x square is your velocity. Okay. If you take a square, velocity square will equal to what? W square x naught square minus x square. So kinetic energy is equals to what? 1 upon 2 m w square x naught square minus x square. This is your kinetic energy formula. Okay. Now, if you guys remember my advice from the first lecture, kinetic energy is maximum at where? At mean position. Kinetic energy is maximum at mean position. Kinetic energy is maximum at mean position. Okay. So that means at mean position, your x is equals to what? 0. Okay. So what will my kinetic energy maximum become? Kinetic energy maximum is equals to what? 1 upon 2 m w square x naught square. This x square will get cancelled out because it is 0 square. So now you have two formulas for kinetic energy. One for kinetic energy at any point, and if you have to calculate the maximum kinetic energy, you will utilize this formula. Can you remember this? ये बात याद रहेगी? Yes or no? Yes or no? Now let's move on to total energy. If you have any hesitations, Abibi, kindly ask in the chat. Don't be afraid. Let's move on to total energy, that is TE. Now, before moving on to total energy, I want your attention on something. 1 second. Yep, kinetic energy is maximum at mean position, and as Wahab has stated, kinetic energy is 0 at extreme positions. Please remember this by heart. Kinetic energy is 0 at extreme position and is maximum at mean positions. This is also evident from the formula. If my x equals to what? X naught, that is the extreme position, then my kinetic energy will become 0. Okay, chalo, let's move on to total energy. Now, before studying total energy, I need your attention on one thing. Have you guys studied the law of conservation of energy? Have you guys studied the law of conservation of energy? Yes or no? Have you guys studied the law of conservation of energy in O levels or IGCSE physics? I hope so you have studied that. Law of conservation of energy states that energy in the system remains constant. Law of conservation, yes, from AS, yeah, you can say that. Law of conservation of energy states that energy in a system remains constant. Okay, let's say total energy in a system remains constant. Let's say this is position A. Let's say this is position B. Let's say this is position C. Position A is the extreme position, position B is the mean position, and position C again is the extreme position. Okay. According to law of conservation of energy, total energy at point A will be equal to the total energy at point B, and it will be equal to the total energy at point C. The total energy in a system remains constant or same throughout. Okay. Now, can you calculate the total energy at one of these points? Can you calculate the total energy at one of these points? If you analyze point B, if you analyze point B, the total energy at point B consists of what? Maximum kinetic energy only, because you are at the mean position. And at the mean position, your gravitational potential energy is 0. And your kinetic energy is maximum. So can I calculate the total energy formula for A, for C and for B? Yes, it is equals to the kinetic energy maximum, that is 1 upon 2 m w square x naught square. Simple as that. Can you remember this? बेटा मैंने क्या physical logic apply किए यहाँ पे? The total energy in a system remains constant throughout. Okay, sir. So the energy at point A will be equal to the energy at point B will be equal to the energy at point C. From looking the diagram, we can see that B is what? B is the mean position. At mean position, your only energy is the maximum kinetic energy. Gravitational potential energy is 0. Okay. So the total energy at point B will be equal to what? 1 upon 2 m w square x naught square. Here I have written this entire thing. If there is no energy lost, energy is just converted from one form to another. At extreme position displacement, the total energy is equals to the potential energy, as kinetic energy is 0. And at mean position, total energy is equals to the kinetic energy maximum, as potential energy is 0. So the formula for total energy remains this. And total energy remains constant throughout simple harmonic motion. The formula for total energy is this, and total energy remains constant throughout simple harmonic motion. Is this clear? Any ambiguities here? Let's move on to potential energy, that is the third type of energy. Now, always remember that in simple harmonic motion, total energy comprises of what? Potential energy plus kinetic energy. Do you have the formula for total energy? Yes, 1 upon 2 m w square x naught square. What is the journal formula for kinetic energy? 1 upon, I am not asking about the maximum kinetic energy. Journal formula of kinetic energy. 1 upon 2 mw square x naught square minus x square. Let's bring this entire thing. Let's bring this entire thing towards the left side. Your potential energy equals to what? 1 upon 2 m w square x square. This is your formula for potential energy. So now, luckily, you have the formula for all three types of energies. Now, unknowingly, you have the formulas for all three types of energies. Kinetic energy, that is 1 upon 2 mw square x naught square minus x square. The maximum kinetic energy is 1 upon 2 mw square x naught square. The total energy is what? 1 upon 2 mw square x naught square. And the potential energy has a formula of what? 1 upon 2 m w square x square. Are all the three formulas of energy? Beta. Three formulas of energy are clear to all of you, yes or not? Are the three formulas of energy clear to all of you, yes or no? Perfect. Now let's say the examiner asks you to calculate a point, calculate a displacement where potential energy is equals to kinetic energy. Let's say the examiner has asked you to calculate a point where calculate a displacement where potential energy is equals to kinetic energy. What will you do? You will just take the formula of potential energy and equate it to kinetic energy. You will just take the formula of potential energy and equate it to kinetic energy. This comes out to be what? Potential energy is equals to kinetic energy. Potential energy has the formula of what? 1 upon 2 m w square x square. Kinetic energy has the formula of what? 1 upon 2 m w square x naught square minus x square. At a displacement of what? X naught over under root 2. Your potential energy is equals to kinetic energy. So if your displacement becomes equals to what? Maximum displacement divided by under root 2, then your kinetic energy is equals to the potential energy. Simple as that. Nothing complicated. I hope so. Everything is clear. Okay. Now let's draw the graphs. Now let's draw the graphs of all these three types of energies. Now let's draw the graphs of all these three types of energies. 1 second. Now let's draw. Now let's draw the graph of kinetic energy, potential energy, and potential energy, and total energy. Let's see whether we can draw a graph for all of these. Let's see. Okay. So, so we know one thing. We know that kinetic energy, kinetic energy is maximum where? Kinetic energy is maximum at the mean position. So can you see this blue graph is maximum at the mean position? एक second यार किसी का सवाल है. Now you have gotten it थोड़ा सा incorrect, Wahab. Kinetic energy will be maximum at the mean position because velocity is maximum at the mean position. Okay. Kinetic energy will be zero at the extreme positions. Perfect. This blue graph or the yellow highlighted graph is the kinetic energy graph. Simple as that. Okay. Now, let's look at potential energy. We know potential energy will be maximum at extreme positions here and here. Potential energy is zero at the mean position. So this green graph comes into existence. At any moment in the simple harmonic motion, the total energy remains constant. So you have a horizontal line like this. Now you will ask, sir, how was this total energy graph made? I have added the potential energies and kinetic energy graph to get this total energy graph. Okay. And in the last part, in the previous working, we have calculated that when x is equals to x naught over under root 2, your kinetic energy is equals to potential energy at this point and at this point. Are these graphs clear to all of you? Yes or no? If not, ask away your question. Now, sir, what is damping? What is damping? Damping is basically what? Damping is the decrease in amplitude of a vibration due to loss of energy. Damping is basically the decrease in amplitude of vibration due to loss of energy. Okay, damping is the decrease in amplitude of vibration due to loss of energy. Now, sir, how can we damp a system? How can we damp a system? You can damp a system via two methods. There are two methods to damp a system. What are those two methods to damp a system? You can either oscillate the body in a viscous fluid, such as oil, glycerine, water. You can either oscillate the body in a viscous fluid, such as oil, glycerine, water, or you can increase the surface area of the body, or you can increase the surface area of the body by attaching feather or some substance that increases the surface area. Simple as that. So there are two ways in which you can cause damping. First of all, you can oscillate the body in a viscous fluid. Secondly, you can increase the surface area. This also causes damping. Perfect. Now, now one more thing that you need to study here. Beta, how will damping affect this resonance ka graph? How will damping affect the resonance का ग्राफ? भाई रेजोनेंस का ग्राफ किस तरह इफेक्ट होगा? How will damping affect the resonance का ग्राफ? Very easy if you can pay attention here. If damping occurs, your resonance का graph beta will shift at a lower amplitude. You can see the maximum amplitude will decrease. The maximum amplitude in the resonance graph will decrease. Let's say initially your amplitude was A1. It has now dropped to a lower amplitude of A0. Can you see your amplitude has decreased? So damping causes the amplitude maximum to decrease. And also your resonance frequency has also decreased. Now the point where your maximum amplitude occurs is also at a lesser frequency. So these are the two changes to your resonance graph when damping occurs. First of all, your resonance frequency decreases. Secondly, your maximum amplitude decreases. Is everything clear up till now? Now, there are three types of damping. Now, there are three types of damping, beta. Damping की three types हैं. Perfect, inshallah. And if you have any questions, do ask me at that point. वैसे तो you are lucky that this topic is completely not related to the previous. सर इसके पास पेपर आज करेंगे? यस बेटा इसके पास पेपर आज करेंगे. दिस इज जस्ट अबाउट टू फिनिश. उमर यू आर लकी दैट इस आज जो हम टॉपिक पढ़ रहे हैं उसका प्रीवियस से कोई रिलेशनशिप नहीं. यस वी डू डिफ्रेंशिएशन वाला पार्ट हमने प्रीवियस क्लास में किया था बेटा. प्रीवियस क्लास में हमने डिफ्रेंशिएशन वाला पार्ट कर लिया था. वेयर वाज इट? हेयर हेयर. So Hussein, you can also see the beta recorded lectures. And if you have any questions, you can ask me. ठीक है? चलो अब कंटिन्यू करते हैं. There are three types of damping that you need to know about. There are three types of damping that you need to know about. First type of damping is light damping or under damped system. Please pay attention. I need your undivided attention here. The first type of damping is light damping or underdamped system. Sir, what do you mean by an underdamp or a light damping? But a light damping or underdamping means that your amplitude of vibration will gradually decrease. Let me show you how. Let's say initially your amplitude was somewhat like this. Gradually it will decrease. Okay, it will gradually decrease. This is what? Green represents light damping. In light damping, your amplitude decreases pretty gradually over a period of several oscillations. बेटा लाइट डैम्पिंग में आपका एम्पलीट्यूड डिक्रीजेस स्लोली एंड ग्रेजुअली ओवर मल्टीपल ऑसिलेशंस. Please, please, please remember this. Okay. Sir, what is the second type of damping? The second type of damping is known as critical damping. Okay. Now, what happens in critical damping? In critical damping, your amplitude decreases to zero very quickly in a quarter of a cycle. In critical damping, your amplitude decreases to zero very quickly in a quarter of a cycle, somewhat like this. Blue represents critical damping. Now, the last type of damping that you need to know about. The last type of damping that you need to know about is heavy damping or over damped systems. But the last type of damping that you need to know about is heavy damping or over damped systems. In heavy damping or in over damped systems, your amplitude does decrease to zero, but it takes a longer time. This is heavy damping. This marks the end of the chapter of oscillations or simple harmonic motion. This is chapter number 7. Chapter number 7, electric field. Let's get started with it. Okay. And one disclaimer, this chapter is pretty similar to gravitation का chapter, तो मैं थोड़ी सी conclusions या comparisons करूँगा at some points, so that you know what is for gravitation, what is for electric field का chapter. Okay. Now, the first thing that you need to study about in electric field is Coulomb's law. The first thing that you need to study about in electric field is Coulomb's law. Okay. What does Coulomb's law state? The Coulomb's law state that the force between 2 point charges, the force between 2 point charges is directly proportional to what? It is directly proportional to the product of what? Charges, and inversely proportional to what? Inversely proportional to the separation between them. The force of attraction between two charges is directly proportional to the product of charges and inversely proportional to the square of separation between them. अच्छा, does this ring some bell? कुछ याद आ रहा है? ऐसा कोई लॉ और पढ़ा था हमने? यस, ऐसा कोई लॉ और पढ़ा था हमने? यस. एनी अदर लॉज दैट वी हैव स्टडीड लाइक दिस? कोई और लॉ जो हमने इस तरह का पढ़ा हो बेटा? यस, न्यूटन्स लॉ ऑफ ग्रेविटेशन. यूजुअली आई शो स्टूडेंट्स अ मीम हेयर जिनसे उनको याद रह जाती हैं ये चीज़ें. दैट इज दिस वन. न्यूटन्स का क्या लॉ था बेटा? m1 m2 डिवाइडेड बाई डी स्क्वायर इंटू जी. कूलम्स का क्या लॉ है? कूलम्स का लॉ है फोर्स ऑफ इलेक्ट्रिक इज इक्वल टू k q1 q2 डिवाइडेड बाय आर स्क्वायर. देखो सिमिलर है. न्यूटन्स ने किसके लिए लॉ दिया था? मासेस के लिए. कूलम ने किसके लिए लॉ दिया है बेटा? चार्जेस के लिए. सिंपल एज दैट, नथिंग डिफरेंट. ओके. नाउ सर व्हाट इज दिस के? ये जो के आ रहा है, व्हाट इज दिस के? Is there any more complications to it? Yes. This k can be represented as 1 over 4 pi E naught, where E naught is your permissivity of free space. Permittivity of free space. Okay. अच्छा, अब न्यूटन्स सॉरी कूलम्स लॉ लिखने के दो तरीके हैं बेटा. देर आर टू वेज इन विच यू कैन राइट कूलम्स लॉ एंड बोथ ऑफ देम आर perfectly fine. Either you can say the electric force is k q1 q2 divided by r square, or you can say electric force is equals to q1 q2 divided by 4 pi e naught r square. Both these methods are correct. You don't need to fight with your colleagues से कौन सा correct है कौन सा correct है. Your k has a value of what? 8.99 into 10 raised to the power of 9. And 1 upon 4 pi e naught में e naught की value क्या है? 8.85 into 10 raised to the power of minus 12. All clear up till now. Hmm. Okay. Beta, always remember electric field lines will emerge out of a positive charge. इलेक्ट्रिक फील्ड लाइंस एक पॉजिटिव चार्ज से इमर्ज आउट करेंगे इस तरह. And electric field lines will always go into a negative charge like this, like this, like this, like this. Perfect. If I place a positive charge in front of a positive charge, like charges repel, this positive charge will move towards the right. If I place a positive charge in front of a negative charge, unlike charges attract, this positive charge will get attracted towards the negative charge. Perfect हो गया sir. Now let's draw electric field lines between two charges. अब तक हमने electric field line बनाई बेटा, but between one charge. Okay, now let's draw the electric field lines between two charges बेटा. Let's say you have unlike charges. Let's say एक positive charge है मेरे पास, एक negative charge है. How will the field lines be? The field lines will emit from the positive into the negative, from the positive into the negative, from the positive into the negative. And you will draw some lines that are only originating from the positive and some lines that are only going into the negative charge. Okay, this is your field line when you have unlike charges. This is your field line pattern when you have unlike charges. This is your field line pattern when you have unlike charges. बेटा unlike charges में हमेशा क्या ख्याल रखना है? Your field line should come out of the positive charge and go into the negative charge. Okay. Now let's draw the field lines for like charges. Let's draw the field lines for like charges. For like charges, always remember they repel each other. तो बेटा फील्ड लाइंस क्या करेंगी? दे विल कर्व अवे फ्रॉम ईच अदर लाइक दिस, लाइक दिस, लाइक दिस, लाइक दिस. They will curve away from each other. One more important point to remember. Whenever you have like charges, whenever you have like charges, there will be a null point between them. Whenever you have two like charges facing each other, there will be a null point between them. What is a null point? A null point is a point where electric field strength is zero. A null point is a point where electric field strength is zero. Is everything clear up till now? Any ambiguities you can ask me right now. Now, before moving ahead with the chapter, you need to know what is a point charge. Before moving ahead with the chapter, you need to know what is a point charge. Okay. Now, point charges are charges that have no inner thing. Point charges are a single entity. Everything exists outside of the charge body and not inside. Every charge that we will be studying in A2 physics is a point charge. Every charge that we will be studying in A2 physics is a point charge, and this assumption is known as what? बेटा ये assumption को क्या कहते हैं? Point charge assumption. This assumption is known as point charge assumption. Nothing complicated, nothing to worry about. Now, let's study about electric field strength. Let's study about electric field strength. What will be electric field strength? Please, God say, your focus should not be somewhere else. You should focus on the board. What is electric field strength? Electric field strength is force per unit positive charge in an electric field. Electric field strength is force per unit positive charge in an electric field. Okay. Peter, do you remember the formula for force? Do you remember the formula for electric force? Yes, sir, we remember that. K Q1 Q2 divided by R square. Q2 and Q2 gets cancelled out. Your formula for electric field strength becomes what? E is equals to KQ1 divided by R2. Acha. Now here, one of the most ignored things, जो most ignored चीज होती है वो क्या होती है? You always take the charge Q1 जिसकी चार्ज की आपको इलेक्ट्रिक फील्ड स्ट्रेंथ चाहिए. Okay, let me rephrase it. The formula for electric field strength is like this: KQ over R square. This Q depends which charge की electric field आपको चाहिए. If you need the electric field of charge 1, you will take Q1. If you need the electric field of charge 2, you will take Q2. Simple as that, nothing complicated here. Okay. Now, one more thing that is going to come in handy just in a bit is electric field is a vector quantity. Electric field is a vector quantity. Now just sit back and relax. 15 minutes, just enjoy physics. Let's say you have a positive charge like this. Okay. Let's say you have a positive charge like this. What was the key point that I told you guys? In a positive charge, electric field lines always go into the charge. ठीक है, इतनी बात याद रहेगी. In a positive charge, electric field lines always go into the charge. ठीक है सर, सही कह रहे हैं आप. Now, electric field strength is a vector quantity. So the vectors acting towards the right can be termed as positive. The vectors acting towards the left can be termed as negative. Perfect. No big deal. No big deal. And I also know, I also perfectly know that electric field strength is equals to KQ. Oh, sorry. यार तुम लोग क्या कर रहे हो, मुझे बता भी नहीं रहे. 1 second. For positive charge, the field lines always emit out. The field lines always emit out. यार थोड़ा तो ध्यान दो. Yeah. Sorry, Umar. Sorry. Really sorry, यार. पता नहीं. I don't feel good for the last few days. चलो. Yeah. Sorry for that. Positive charges में electric field lines क्या करेंगी बेटा? Emit out करेंगी. So the field lines acting towards the right will be positive E and the field lines acting towards the left will be negative E. Just sit back, relax. Now it is proper. Now there will be no mistake. The electric field strength is what? KQ over R square. Perfect. This is the formula for electric field strength. Now, geniuses, can you tell me? Now, geniuses, can you tell me that electric field strength and R square किस तरह related है बेटा? Electric field strength and R square are in which type of a relationship? Inverse square law. Electric field strength and R are related according to inverse square law. Sir, what is inverse square law? I have skipped the lectures of gravitation. No problem. Inverse square law basically states that if your radius goes from R to 2R, your electric field strength will decrease by 4. If your radius goes from R to 3R, your electric field strength will get divided by 9. If your radius goes from R to 4R, your electric field strength will divide by 16. Okay, sir, this is what inverse square law means. Perfect. Now, let's draw the graph of it. Let's draw the graph of it. Just we will take baby steps. कोई जल्दी भागने की जरूरत नहीं है बेटा. जल्दी भागने की ज़रूरत नहीं है. यू विल स्टिल बी एबल टू ग्रास्प ऑल द कॉम्प्लेक्स कॉन्सेप्ट. सारे कॉम्प्लेक्स कॉन्सेप्ट अभी भी तुम लोग को आ जाएंगे. जस्ट नीड टू टेक बेबी स्टेप्स. Let's say y-axis is electric field strength slash Newton Coulomb minus 1. This is negative electric field strength Newton Coulomb minus 1. This is r slash meters. This is r slash meters. Perfect, perfect. No problem up till now. Okay. At the surface, chalo. At the surface, beta, at the surface, that is here. Here. At the surface, that is here. What will be your electric field strength? At the surface, here you have a positive R. If you have a positive R, your electric field strength will be capital E here. Perfect. Okay. As you go from R to 2R, what will happen to your electric field strength? It will drop to E over 4. As you go from 2R to 3R, what will happen? Your electric field strength will drop to E over 9. Let's draw this curve. 1 point here, 1 point here, and 1 point here. Let's draw this curve like this. Perfect. Oh, let's draw this curve like this, bhai. Easy terrain graph. Nothing complicated here. Perfect. Also, do you guys remember my point charge wala thing? Do you remember point charge ki definition? A point charge is something which has everything outside and nothing exists inside. बेटा अगर किसी चार्ज के इनसाइड there is nothing, then the electric field strength inside that charge will also become zero. So what will you do? Your electric field strength will drop to zero here. Your electric field strength will drop to zero here. Simple as that, nothing complicated. Perfect. Sir, can you repeat the curve? Where did the line came from? ये वाली line. This is an optional line. If you want to draw it, draw it. If you don't want to draw it, don't draw it. This is an optional line. This line I have just made so that I can. I have made this line so that I can identify कि मेरा surface क्या है charge का बेटा. This is just made to identify कि मेरा surface क्या है. ग्रीन लाइन वाला पार्ट चलो मैं कर देता हूँ. डोंट वरी अबाउट दैट. अच्छा ये फर्स्ट ऑफ ऑल मैं ये बता देता हूँ बेटा, ये जो लाइन मैंने बनाई है सरफेस पे, दिस इज ऑप्शनल. दिस इज जस्ट टू आइडेंटिफाई कि सरफेस पे आपकी इलेक्ट्रिक फील्ड स्ट्रेंथ ई है. आप बनाना चाहते हो डॉटेड लाइन बनाओ, नहीं बनाना चाहते फिर भी एग्जामिनर मार्क्स देगा. ओके. नाउ दिस ग्रीन लाइन वाला पार्ट बेटा, आई हैव टोल्ड यू दैट इन A2 फिजिक्स ऑल चार्जेस विल बी कंसिडर्ड एज पॉइंट चार्जेस. A2 फिजिक्स में हर चार्ज को हम पॉइंट चार्ज कंसिडर करेंगे. और पॉइंट चार्ज की अच्छी बात क्या होती है? देयर इज नथिंग इनसाइड द पॉइंट चार्ज, एवरीथिंग एग्जिस्ट आउटसाइड द पॉइंट चार्ज. तो बेटा ये जो चार्ज बना हुआ है उसमें दिस स्पेस इज हॉलो. देयर इज नथिंग इनसाइड दिस येलो एरिया. हॉलो है, एम्प्टी है. So if your space is empty, there will be no charge as well. If there is no charge, your electric field strength will drop to zero. Somewhat like this. As soon as you move inside the charge, your electric field strength will drop to zero. Any other curious questions? हाँ भाई पूछो जरा कोई curious सवाल. अब सेम काम करते हैं बेटा लेफ्ट हैंड साइड ऑफ द स्फीयर के साथ. बस चलो थोड़ा सा फोकस कर लो. देयर इज नथिंग मच लेफ्ट हेयर. वेरी इजी हो जाएगा तुम लोगों के लिए फिर. Okay, okay, okay. So now what can you do? You can make this dotted as well. Make this dotted as well, bhai. Make this dotted as well. Now, if you are a little smart, थोड़े से भी smart हो ना अगर, तो you will notice that the electric field strength is now what? Negative E at a distance of negative R. At a distance of negative 2R, it will become what? Negative E over 4. That is this point. That is this point. And at a distance of negative 3R, your E will become what? Negative E over 9. somewhere here. Can I draw a curve here, beta? Yes, I can draw a curve here, somewhat like this. And again, if I go inside the point charge, my electric field will instantly drop to zero because it is a point charge. बेटा अब आपको चार्जेस की सारी चीजें समझ आ जानी चाहिए इफ यू अंडरस्टैंड दिस ग्राफ. यस परफेक्ट. चलो नाउ लेट्स डू द सेम थिंग फॉर नेगेटिव चार्जेस. भाई नेगेटिव चार्जेस के साथ भी सेम करते हैं. अब नेगेटिव चार्जेस के साथ थोड़ा सा अपना ब्रेन फंक्शन मिलाओ. नाउ आई हैव टोल्ड यू ऑल द इन एंड आउट्स ऑफ वन चार्ज. नेगेटिव चार्ज के साथ जरा खुद सोचो क्या होगा. फर्स्ट ऑफ ऑल इन अ नेगेटिव चार्ज द फील्ड लाइंस गो इनसाइड. ठीक हो गया सर, इनसाइड गो करती हैं. ये ले मैंने आपका डायग्राम बना दी इस तरह से. ठीक है, ये आ गई आपकी डायग्राम. ओके लेट्स प्लेस इट हियर. परफेक्ट. नेगेटिव चार्जेस में व्हाट कैन यू सी? That the left hand side is positive, right hand side will be negative. So the curve for the electric field strength of a negative charge will be somewhat like this. Any ambiguities here beta? यहाँ पे भी देखो ये जीरो हो रही है इलेक्ट्रिक फील्ड स्ट्रेंथ. Once you go inside the sphere, electric field strength becomes zero. परफेक्ट है वहाब. चलो अल्हम्दुलिल्लाह. एनीवन एल्स दैट हैज एनी क्वेश्चंस? बेटा इलेक्ट्रिक फील्ड का चैप्टर लोगों को मुश्किल लगता है बट यू गाइज विल बी प्रोज एट इट अगर थोड़ा सा सही तरह सुनते हो. ठीक है. नाउ वी हैव कंसिडर्ड इलेक्ट्रिक फील्ड लाइंस बिटवीन आइसोलेटेड चार्जेस. भाई आपने एक एक चार्ज को सिंगल आउट करके उसकी इलेक्ट्रिक फील्ड स्ट्रेंथ देखी है. अब हम देखते हैं कि दो चार्जेस के बीच में, और अगर आप दो चार्जेस आमने सामने प्लेस करोगे तो हाउ विल द रिजल्टेंट इलेक्ट्रिक फील्ड लुक लाइक. ओके लेट्स यप बेसिकली ऑपोजिट ऑफ द प्रीवियस ये भी कह सकते हो. लेट्स राइट डाउन द हेडिंग ऑफ इलेक्ट्रिक फील्ड स्ट्रेंथ. इलेक्ट्रिक फील्ड स्ट्रेंथ between unlike charges. between unlike charges. Now you guys should also थोड़ा सा एक्टिव हो जाओ चैट में. You guys can tell me कि क्या होगा यहाँ पे अगर थोड़े से स्मार्ट हो. ठीक है. let's say you have a positive charge like this. ये पॉजिटिव चार्ज आ गया आपके पास. ठीक हो गया सर. ओहो yep, this is your positive charge and you have a negative charge as well here. Let's say somewhat like this. ये आ गया आपका नेगेटिव चार्ज. ठीक हो गया. Beta field lines always emit out of the positive charge. So this becomes your electric field line of charge 1. Let's say this positive charge has a charge of Q1. This negative charge has a charge of Q2. And electric field lines always go into the charge of negative. This becomes positive E2. Why? Because I am considering that right hand side vectors are positive, left hand side vectors are negative. बेटा क्लोजली एक चीज देख लो, यू विल बी एबल टू डू एवरी अदर थिंग ऑन योर ओन. ओके अब इलेक्ट्रिक फील्ड स्ट्रेंथ और रेडियस का ग्राफ बनाते हैं या सेपरेशन का ग्राफ बनाते हैं. चलो लेट्स डू वन थिंग. ओहो लेट्स डू this and perfect. Yeah, let's keep it here. Okay, now the step I am doing first of all is optional. If you want to do it, do it. If you don't want to do it, that's fine as well. The first step is to draw the surface. Surface usually draw करना इतना important नहीं होता, but I draw it so that students get to know what actually is happening here. Let's say this is my surface. Okay. I will make it dotted. बेटा अगर ये 5 मिनट फोकस कर लो, you will never get confused in resultant electric field strength का graph. Okay. What will be the electric field strength at the surface? The electric field strength at the surface will be positive E1. Okay. Let's say somewhere here. As you travel away from this charge, beta, as your distance or r increases away from this charge, the electric field strength of this charge will decrease. So you will have a graph like this. Oh, you will have a graph like this, somewhat along these lines. Is this first curve clear to all of you? Beta, first curve clear हो गया. The red line represents what? Red line represents the electric field strength of what? Electric field strength of what? Q1. Simple. Q1 की जो इलेक्ट्रिक फील्ड स्ट्रेंथ है वो इससे रिप्रेजेंट होगी. Perfect. Now let's represent the electric field strength of Q2. बेटा जस्ट लुक कि मैं क्या चीज़ों को ऑब्जर्व कर रहा हूँ यहाँ पे. First of all, I will draw the surface, then I will make it dotted. Okay. And can you see this electric field is also positive? So, yeah, let's make it here positive E2. It will start from here. And as you keep moving away from this positive charge, the electric field strength will decrease. Are these two curves clear to you guys? मुझे बताओ ये दोनों curves clear हैं? Yes or no? Now how to calculate the resultant electric field strength graph? Now first of all though, marks will be allotted on the basis of the shape of the yes. Okay. Now I have to plot the graph of resultant electric field strength between these unlike charges. अच्छा. First of all तो इस word का मतलब समझो. First of all, what is the meaning of this word resultant electric field strength? Or for that matter, the examiner sometimes also use this word total electric field strength. Okay. बेटा होता ये है, the thing that happens is कि if I am standing somewhere here, let's say this is point A, I am standing somewhere here. This charge 1 will also apply an electric field on me like this E1, and this charge 2 will also apply an electric field on me, that is E2. Now if I want to calculate the total electric field strength at point A, I will have to first of all calculate the electric field strength due to charge 1, then the electric field strength due to charge 2. Then you will have to add both of them. Like let's say I want to calculate the total electric field strength experienced at A. What will I have to do? I will have to calculate the electric field strength at 1, the electric field strength at 2, and you will have to add them up. This is a hectic procedure. So what did scientists do? They added both these curves. बेटा साइंटिस्ट ने ये दोनों कर्व्स को ऐड कर दिया to get a resultant electric field strength curve. Somewhat like this. Your black line represents the resultant electric field strength curve. All clear. Any ambiguities here? Also, again examiner, if the examiner wants you to do the hard work, and let's say the examiner has provided you that the total distance between the two charges is x, and the distance between E1 and A is R. Let's say examiner ने आपको ये मुश्किल तरीका दिया हुआ है. 1 second here, let me see. सर इलेक्ट्रिक पोटेंशियल, अभी बेटा रुक जाओ वहां इस बात पे रुक जाओ. वी विल डिस्कस दिस इन द नेक्स्ट क्लास. अभी नहीं, जस्ट वेट फॉर अ मोमेंट. दैट्स गुड दैट यू नो इट, लेकिन अभी उसको यहाँ पे कंफ्यूज ना करो. वो कुछ और चीज है. Yep, the sign of E1 and E2 will be same. How did I determine that बेटा? Because E2 भी राइट साइड पे लग रही है, E1 भी राइट साइड पे लग रही है. Now आप कहोगे सर आपको कैसे पता कि राइट साइड पे लग रही है? आपने क्या मैजिक किया है? नहीं. नेगेटिव चार्जेस में इलेक्ट्रिक फील्ड स्ट्रेंथ ऑलवेज गो इनटू द चार्ज. पॉजिटिव चार्जेस में इलेक्ट्रिक फील्ड स्ट्रेंथ ऑलवेज कम आउट ऑफ द चार्ज. ओके. नाउ लेट्स से द एग्जामिनर आपसे लंबा काम कराना चाह रहा है. वो चाह रहे हैं कि ग्राफ आपको नहीं देगा, लेट्स से एग्जामिनर हैज प्रोहिबिटेड यू, ग्राफ नहीं दिया उसने, उसने आपको डिस्टेंसेस दे दिए. द टोटल डिस्टेंस बिटवीन चार्ज 1 and 2 is x and the distance from q1 to a is r. How will you calculate the total electric field strength at A? Very easy. Just apply the formulas. E1 will be what? K Q1 divided by what? K Q1 divided by what? Divided by the distance of the charge from point A, that is R square. What will be E2? K Q2 divided by the distance between A and the charge Q2. What will be this distance? Yes, mathematicians. Maths पढ़िए सबने. This will be x minus r. This becomes x minus r square. All clear, crystal clear है ये. कुछ मसला है तो मुझे बताओ. If there is any difficulty, tell me. Now let's say I flip the charges. बेटा let's say I flip the charges. Let's say मैंने charges को flip कर दिया. पॉजिटिव की जगह आई हैव ब्रॉट नेगेटिव एंड नेगेटिव की जगह आई हैव ब्रॉट पॉजिटिव. ओके, व्हाट विल हैपन इफ नेगेटिव इज इन प्लेस ऑफ पॉजिटिव, पॉजिटिव इज इन प्लेस ऑफ नेगेटिव? क्या होगा? आपका ग्राफ बस उल्टा हो जाएगा, नथिंग एल्स. नथिंग एल्स, ग्राफ उल्टा हो जाएगा, नथिंग एल्स. इलेक्ट्रिक फील्ड स्ट्रेंथ ऑलवेज emit from the positive charge, hence this becomes negative E, and they always go into the negative charge, hence it becomes also negative E. Both of these graphs will be negative E, hence you will have this reverse graph, or you can say flipped graph. Two things that you need to remember here, two things that are really important to remember here. What are those two things here? Whenever you will have unlike charges, whenever you will have unlike charges, please remember, whenever you have unlike charges, please remember that your electric field strength की value remains same throughout. बेटा whenever you have unlike charges, ये point थोड़ा सा गौर से पढ़ते हैं, ठीक है, फिर we can finish the class. In the case of unlike charges, your electric field strength will never be zero. You will have no null points. बेटा electric field strength कभी भी zero नहीं होगी in case of unlike charges. You can see from the graph as well. क्या आप कहीं पे electric field strength zero देख सकते हो? No. Electric field strength in unlike charges will never ever be equal to zero. Here as well you cannot see a zero. Here as well you cannot see a zero. Second key point, the sign of electric field strength remains same throughout. If the electric field strength is positive, it will remain positive throughout. If the electric field strength is negative, it will remain negative throughout. Perfect. All clear? Yes or no? Yes or no? Any ambiguities here? Perfect, perfect. Alhamdulillah. Now, just last thing, just one last thing. एक सेकेंड यार, क्लियर है? चलो अल्हम्दुलिल्लाह. अच्छा, वन लास्ट थिंग. हाउ विल द इलेक्ट्रिक फील्ड स्ट्रेंथ ग्राफ लुक बिटवीन लाइक चार्जेस? बेटा अगर मैं लाइक चार्जेस के बीच में इलेक्ट्रिक फील्ड स्ट्रेंथ का ग्राफ बनाऊं, हाउ विल दैट लुक लाइक? नाउ इफ यू आर लिसनिंग केयरफुली बेटा, ये आपके लिए एक पीस ऑफ केक होने वाला है. Now every graph will be a piece of cake for you if you were listening closely for the first graph. How to draw electric field strength graph between like charges? Okay. Let's say you have two positive charges. Let's say you have two positive charges. Perfect. Say two positive charges है मेरे पास. Okay. So let's say you have charges like this. Perfect. Perfect. Okay. You have two positive charges. Electric field strength always emits outside the positive charge here as well and here as well. Now we also know electric field strength is a vector quantity. So electric field strength towards the right will be positive E and electric field strength towards the left will be negative E. So the electric field strength of charge 2 becomes negative E2 And the electric field strength of charge 1 becomes what? Positive E1. Okay. Let's draw the graph of each of them one by one. Let's first of all draw the graph of positive E1. You are starting from a positive value, and as you go away, your electric field strength decreases. Let's draw the graph of negative E2 as well. You are starting from a negative value. As you move away from the charge, your electric field strength decreases to 0. Are the yellow and blue graphs clear to you guys? फिर ग्रीन वाले ग्राफ पे आते हैं. Are the yellow and blue graph clear to you guys? Now, just like I calculated the resultant यहाँ पे, I will calculate the resultant here as well. I will take this point, draw a graph between them. But here you will notice a pretty interesting thing. Here you will notice a pretty interesting thing. Resultant electric field strength is becoming 0 at a point. That point is known as null point. And beta, क्या हमने initially discuss किया था? Yes, we have initially discussed this. Like charges will have a null point in between them. और ऐसा ही हो रहा है. Wow, our theory proved to be correct. Like charges के बीच में एक null point आ रहा है बेटा. That's perfectly correct. This is exactly what we studied. Perfect. Sir, okay, that's clear. ठीक है, null point समझ आ गया हमें. अब दो questions हैं हमारे. First of all, let's say if the graph is not given. Let's say if the graph is not given, just like in the previous scenario, and आपको distance is given है. And let's say you are asked to calculate the electric field strength at any random point, let's say A here. How will you do it? The electric field strength at any random point A will be a sum of both the electric field strengths E1 plus E2. But can you realize that E2 is negative? So we will place negative E2 here. What will the value of E1 come out to be? K Q1 multiplied by R square minus K Q2 divided by X minus R square. This is your resultant electric field strength if you are given the distances only. यहाँ तक clear है बेटा? Yes or no? When this electric field strength becomes 0, when this electric field strength becomes 0, you can calculate the null point. बेटा अगर E की जगह आप 0 सब्स्टिट्यूट कर दो तो you can calculate the null point. If you substitute 0 in place of E, then you can calculate the null point, as at the null point your electric field strength is 0. Your equation will become something like this. Everything else remains constant. Electric field strength क्या हो जाएगी भाई? 0. Simple as that, nothing complicated. What will happen if there are two negative charges? बेटा अगर दो negative charges होंगे तो क्या होगा? Then also you will have a null point. Your shape will look something like this. Your shape will look something like this. Always remember, field lines go into the negative charge. So this will become positive. Field lines go into the negative charge. This will become negative. Draw two curves. And the resultant of that curves gives you a null point here. Simple. There are two key points that you need to remember when you have unlike charges electric field strength. बेटा जब भी unlike charges के बीच में electric field strength निकाल रहे होगे, you have to remember these two key points. The electric field strength will be 0, and that at a point it will be 0, and that point is known as null point. The sign of electric field strength shifts. Firstly it was positive, then it becomes negative. In the upper case also we had this. Firstly it was positive, then it became negative. So there are two key points that you need to remember for electric field strength between like charges. First being the electric field strength becomes 0 at a point known as the null point. Second point being that the electric field strength changes the sign from positive to negative. Today, a topic of discussion will be electric potential. Okay. Sir, what do you mean by electric potential? Let's see that. Okay. So, electric potential is basically what? Electric potential is the work done per unit positive charge. Electric potential is the work done per unit positive charge in moving a charge from infinity to any specific point. What is electric potential? Electric potential is the work done per unit positive charge in moving a charge from infinity to any specific point. Perfect. Simple as that. Nothing complicated here. Okay. Now, what are the formula for electric potential? Electric potential or V is represented with this formula kq over R. And the units of electric potential are V, that is volts. It is a scalar quantity. It is a scalar quantity. Perfect. And it can be positive or negative. Now, please understand what does electric potential actually means. Let's say you have a positive charge like this. You have a positive charge like this. And let's say you have a positive smaller charge at infinity. You have a positive smaller charge at infinity. Perfect. You have a positive smaller charge at infinity. You have a larger positive charge as your source charge. Okay. The voltage or the work done per unit charge required to move this charge from infinity to any point x, from infinity to let's say any point x, is known as electric potential. The work done in moving this positive charge from infinity to any point x is known as electric potential. Perfect. If you have, okay, now you should also realize that V is equals to kq over R. What is this Q? What is this Q? This Q is the charge of this smaller charge. This Q is the smaller charge. What is R? R is the distance between the larger charge and the smaller charge. R. And K is your constant. What was the value of K? Anyone? The value of K was 8.99 into 10 raised to the power of 9. If you can analyze electric potential when a positive charge is moving towards a positive charge will always be positive. Electric potential when a positive charge is moving towards a positive charge will always be positive, or you can say potential always increases as positive charge is brought closer. Why? Because work must be done to overcome the repulsive forces between like charges. Let me re explain it, give you a brief summary as well. If you want to move this positive charge from infinity to any point x, and this is your source positive charge, what will be the work done per unit charge? Work done per unit charge or electric potential will be kq over r, where q is the charge of the thing that you are moving from infinity till any point x. R is the distance between the charge and the source charge. Perfect. Let's further move ahead. Now, let's see what will happen. Let's see what will happen if your source charge becomes negative. Sir, what do you mean by that? Let's say your source charge becomes negative and this small charge is positive. Let's say your source charge becomes negative and this small charge is still positive. What will happen? What will happen? Now your electric potential, that is V is equals to kq over R, will be negative. Why? Because we have a negative charge here. We have a negative charge here, hence our kq over R or the electric potential will be negative. And as you move from infinity to any point x, or you can say any point y, this is your distance r, this is your charge q, and k is the constant. Since this charge is negative, your electric potential will be what? Negative kq over r. Simple as that, nothing complicated here. Is this clear to you guys? Yes or no? So let's summarize it. Let's summarize it. Electric potential is what? For the internet disruptions, let's compensate it by summarizing it from the start. Electric potential is what work done per unit positive charge. Perfect. In moving a charge from infinity to any electric field. Perfect. If your source charge is positive, if your source charge is positive, your electric potential will be what? Kq over R. Q is the charge of the source. Q is the charge of the source. R is the distance between the source and the smaller charge. And K has a value of 8.99 into 10 is the power of 9. Now let's say you have a negative source charge. Let's say you have a negative source charge. Your electric potential will become what? Negative kq over r. Why do we have this negative value? Because your charge source is negative q. So your voltage or electric potential has this value. All clear up till now? Any ambiguities you can tell me here. Now you can write two key points here. First key point. When like charges, when like charges move towards each other, towards each other, just like in the case 1, when like charges move towards each other, when a positive charge is moving towards a positive source charge, what happens? Your potential electric potential increases, or you can say your voltage increases. Perfect. When like charges move towards each other, your electric potential increases. Perfect. Similarly, you can write another key point. When unlike charges move towards each other, just as when a positive charge was moving towards a negative charge, your electric potential decreases because now your source charge is negative. Perfect. Now let's further move ahead. Let's draw the graph of electric potential for a point charge. Let's draw a graph for electric potential versus R for a point charge. Perfect. Let's say, let's write down the heading of electric potential versus R graph. Okay. Let's say you have this sort of a graph. Okay. And let's say the charge is positive like this. Perfect. Here we have the positive charge. Perfect. So just listen carefully. Just listen carefully. First of all, you need to remember that electric field strengths emit outside of the positive charge. Perfect. And you also need to remember, now you also need to remember one more thing, that closer, electric potential closer to the surface will be high. And electric potential far away from the surface will be low. Sir, why do you say that? How did you deduce this conclusion? Because electric potential for a positive charge is equal to what? Kq over R. If K is constant, Q is constant, voltage or electric potential and R are inversely related. Can you realize that if K and Q gets constant, electric potential and R are inversely related? Simple as that. Okay. Now, how will you draw the graph of this? Very, very, very easy. First of all, you will draw the lines at the surface like this. and like this. Perfect. You will make them dotted. Why? Because these represent the surface. You will make them dotted because these represent the surface like this. Okay, these become dotted. Perfect. 1 second, yeah. Somewhat like this. Like this, like this. Okay. At a distance of r, at a distance of radius r, what will be your electric potential? Your electric potential will be V. Let's say this point at a distance of r, you have an electric potential of V. If your r increases to 2r, what will happen according to inverse proportionality? Your V will decrease to half of its value. At 2r, you will have what? V over 2, somewhere here. And if your R increases to 3R, what will happen? Your V will have a value of V over 3. Somewhere here. Somewhere here. Can we plot a graph with these points? Yes, we can plot a graph with these points like this. Perfect. You can continue on this graph like this. Perfect. Okay. Now, what will happen if my R reduces or if my distance reduces less than R? Or you can rephrase it, what will happen if you go inside this charge? Your electric potential will become constant like this. Why? Why will electric potential become constant like this? Because it is a point charge. This electric potential gets constant because this charge is a point charge. Let's do the same thing on the left hand side. On the left hand side, your voltage will be V at a distance of R. Your voltage will be V over 2 at a distance of 2R. Perfect. Your voltage will be what? V over 3 at a distance of 3R. Perfect. Let's draw this curve. Perfect. Clear है. चलो, let's further move ahead. Now, there is one more important thing that I need to discuss. There is one more important thing that I need to discuss. That is the gradient of this graph. I think one of the students pointed out in the first lecture, जब मेरे ख्याल से वाहाब ने आई गेस पॉइंट आउट किया था या समवन दैट वाज प्रेजेंट ऑन दैट डे, gradient of this graph, gradient of this graph will be equal to what? If I calculate the gradient here, that will be equal to what? Change in y over change in x. Perfect. But if you realize, this line is a downward sloping line. So the gradient will also be negative. Perfect. And what is on the y-axis? On the y-axis we have voltage. On the x-axis we have r or distance. Change in electric potential over change in distance. Perfect. What was the formula of electric potential? Minus kq over r divided by r. This comes out to be what? Minus kq over r square. Can you identify any formula that was equivalent to this? Can you identify any formula that was equivalent to this? Yes. Electric field strength had a formula of what? Kq over r square. Let's replace it here. Gradient of this graph is equals to negative of electric field strength. Simple as that, nothing complicated. You can write it here. Gradient of electric potential graph, gradient of electric potential graph is equals to what? Is equal to negative of electric field strength. Simple as that. Negative of electric field strength. Perfect. Now let's say you have to draw the electric potential graph for a negative charge. Now let's say you have to draw the electric potential graph for a negative charge. How will you do that? Beta, do you remember that electric potential for negative charge will remain negative throughout? Negative throughout. Electric potential for a negative charge will remain negative throughout. Perfect, perfect, perfect. So you will have a graph somewhat like this. You will have a graph somewhat like this. Perfect. The electric potential for a negative charge remains negative throughout. So you will have a graph like this. Sir, can you explain this graph further? Yes, surely I can do that. I can do that. How? First of all, if I zoom in a bit, the negative, the electric potential at a distance of r will be negative r. At a distance of r will be negative v. At a distance of 2r, it will become what? Negative v over 2. Perfect. Similarly, as you move forward, this electric potential keeps on reducing as your r decreases. And similar on the left hand side. The electric potential gets horizontal here. Why? The electric potential gets horizontal here. Why? Because this is a point charge. Whenever you have a point charge, your graph for electric potential inside the surface will get what? Horizontal. Nothing complicated here. Okay, perfect. Let's further move ahead. Now just please focus on the board. Please focus on the board. I have told you that the gradient of this graph will be equal to the negative of electric field strength. So let's calculate the gradient here. The gradient here will be equal to change in y over change in x. If I draw a line tangent to this curve, this will be the line. This is upward sloping. What will be your change in y? Change in electric potential. What will be your change in x? Change in r. Electric potential are the value of what? Kq over r divided by r. This comes out to be what? Kq over r square. However, you guys have conveniently missed one thing. That is, here your electric potentials are negative. So who will write a negative sign here? Put a negative sign here. Again, your gradient comes out to be negative electric field strength. Hmm. Yes, better. Perfect. Okay, so I was saying that the gradient of this graph will be equal to what? Negative electric field strength. Okay, so the what will be the gradient here? Negative of change in electric potential divided by change in R. What is negative of change in electric potential? Minus kq over R divided by R. This gives you a value of what? Negative kq over R square. Simple as that, nothing complicated here. Do you get this thing? Is it clear that the gradient of this graph will be equal to what? Negative electric field strength. Okay, sir, how did we deduce that? Gradient here will be equal to what? Change in y over change in x. What is your change in y here? Your change in y here is the negative of change in electric potential. What is your change in x here? R. Negative kq over r divided by r. This gives you a value of what? Negative kq over r square. You replace it with electric field strength. The gradient is equals to negative of electric field strength. Simple as that. Nothing complicated here. All clear? Any ambiguities here? If you have any, you can ask because the internet was also disconnected once or twice. Perfect clear hai. Umar, is it clear to you, beta? Any ambiguities here? Hmm. Perfect hai. Chalo, let's further move ahead. Now, when the electric potential is negative, what does that mean? When the electric potential is negative, what does that mean? If the electric potential is negative, that means that you have negative 2 into 10 raised to the power of 5. Let's say you have an electric potential that is negative with a value of this, negative 2 into 10 raised to the power of 5 volts. Perfect. This means that 1 coulomb of charge needs 2 into 10 raised to the power of 5 joules of energy to escape to infinity. This means what? If your electric potential has a value of negative 2 into 10 raised to the power of 5 volts, this means your 1 coulomb of charge requires 2 into 10 raised to the power of 5 joules of energy to escape to infinity. Simple as that. Okay, do you get this? Let's further move ahead. Let's write down the heading of electric potential between charges. Let's write down the heading of electric potential between like charges. Let's write down the heading of electric potential between like charges. Let's write it down. Let's say you have two charges. Let's say you have two charges. One is positive like this, and one is negative like this. Sorry, this is also positive since we are considering like charges. One is positive, the other one is also positive. You have to calculate the resultant electric potential between these two charges. You have to calculate the resultant electric potential between these two charges. How will you do that? Let's check out. So, first of all, since both of them are positive charges, your graph will only lie in the positive axis. Y axis V slash volts, R slash meters. Perfect. Let's make the surface here. Let's make this as your surface. Perfect. Let's make it a dotted line. Simple. Okay, once you have made this a dotted line, your voltage V at the surface will remain V. Perfect. And as you move forward, your voltage will keep on decreasing like this. Your voltage keeps on decreasing as you move further away from this. Okay, let's also label this. Let's label this as charge 1. Let's label this as charge 2. Your voltage here is V1. Perfect. And now let's label this as the surface of charge 2. Somewhat like this. And make this a dotted line. Perfect. 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 Okay. So the voltage at the surface of the charge will become what? V over 2. Perfect. As it moves away from charge 2, your voltage decreases. Can you analyze? These are just single or isolated curves of these charges. Blue is the electric potential curve of charge Q2. Electric potential graph of Q2. Perfect. What is red? Red is the electric potential graph of Q1. Electric potential of Q1. Can I calculate the resultant graph here? Can I make the resultant graph here? Yes. If I add these two graphs, I will get the resultant electric potential graph. Somewhat like this. This is your resultant electric potential graph. Any ambiguities here? This is your resultant electric potential graph. Any ambiguities here? I have just added the two individual graphs to get my resultant graph. Any ambiguities, anything that you feel is not clear, you may ask right now. One thing that I want you guys to realize here, one thing that is of utmost importance is this point, is this minimum point, is this minimum point B. If you draw a tangent at this point, if you draw a tangent at this point, yep, very good, Wahab. If you draw a tangent at this point, the gradient at this point will become 0. Why? Because it is a horizontal line. Because it is a horizontal line. And do you guys remember just from yesterday's lecture? Do you guys remember just from yesterday's lecture, beta, that the gradient of electric potential graph is what? Negative of electric field strength. So if the gradient is 0 here, the electric field strength will also be 0 at point B. This represents a null point. Very good, Wahab. I think you have seen the lectures previous wale. Shabash Nabiya, very good. Electric field strength at B becomes 0. Perfect. Now let's further move ahead with the discussion. Let's further move ahead with the discussion. Now you have Now, you have seen from the start of the chapter that between like charges, your electric field strength is 0. You have a null point. That was also evident. Now, see, there are two graphs that you need to remember, electric field strength ka graph and electric potential ka graph. For like charges, electric field strength graph was touching the null point or touching 0, representing that between like charges you have a null point. The electric potential graph of two like charges have a gradient at one point that is equal to 0. Or you can say at the minimum point, you have the gradient that is equal to 0. Electric field strength is equal to 0. And you have your electric field strength is equal to 0. Yes, beta, electric potential is a scalar. Yes. Okay, one more thing that I want to discuss with you guys is this. Can you see these points A and can you see this point C? The gradient of the graph will be maximum at point A. The gradient of the graph will be maximum at point A. So hence the electric field strength will be maximum at point A. Hence the force on a charged particle will be maximum at point A. You need to remember this. The gradient at point A will be the maximum. Hence, the electric field strength at A will be the maximum. Hence, the force at A will be the maximum. Simple as that. Now, let's say you are given a point here. Let's say this is point Z. And this point Z is a distance of, let's say, R from charge 1. Ek second. Sir, can we use electric potential of a sphere A is greater? Yeah, you can say that. Yeah, you can say that. You can say that. Take care. Let's say you have a point Z. Now, please listen carefully. The distance between charge 1 and point Z is R. And the distance between the two charges. The distance between the two charges is, let's say, X. Okay, the distance between the two charges is X. The distance from charge 1 to Z is R. You have to calculate the electric potential. You have to calculate the electric potential that is V at the point Z. How will you do that? First of all, realize that both the electric potentials will be positive because both of them are positive charges. Perfect. What will be the electric potential due to charge 1? KQ1 divided by the distance, that is R. What will be the electric potential due to charge 2? KQ2. What is the distance, beta? Can you tell me what is the distance from point Z to the charge 2? Any geniuses? What is this distance? Yep. This distance is what? X minus R. Let's place it here, X minus R. Perfect. Chalo. This is how you calculate resultant electric potential if you are not given the diagram. Now let's see the electric potential graph between unlike charges. Now again I need your undivided attention. No, you will equate it to 0 when you are at. Why will you equate it to 0? Yes. Wahab, why will you equate it to 0? You will never equate it to 0, bhai. You will never equate it to 0. That's a wrong logic. That's the wrong logic. Never ever try to do that. You will never equate it to 0. Perfect. Let's further move ahead. Now let's draw the graph of electric potential between like charges. Electric potential between unlike charges. Okay. You got disconnected? Yeah, I can say again, dekho. You will never equate this electric potential to 0. Why? Because can you see this graph is never touching 0. जो आप equate to 0 वाली बात कर रहे हो, the equating to 0 वाली बात was applicable when we were drawing electric field strength graphs. It is not applicable in electric potential graph. Please remember this. Perfect. याद रहेगी ये बात बेटा. Your electric field strength becomes 0 but not your electric potential at the minimum point. Please remember this. Yes, Wahab, galti samajh aayi beta? This is a very common mistake. That's why it's criminal to make here. समझ आई ये बात. Should we move ahead? Yes or no? Do you get this? Chalo, let's further move ahead. Now, let's see electric potential between unlike charges. Let's see electric potential between unlike charges. Let's write down the heading, that is electric potential between unlike charges. Electric potential between unlike charges. Let's say, you have a positive charge. एक second. Yep, very good Wahab. Very good, very good, very good. Just wait for a moment. भाई बहुत ही fast चल रहे हो आज. Very good. शाबाश. Appreciated. Let's say this is a positive charge and let's say this is a negative charge. How will you draw the electric potential graph between them? Very, very easy. First of all, let's draw the axes. The first and foremost thing to do if you want to draw a graph. 1 second. Yep. So basically, the positive y-axis is voltage V. This is negative voltage V. This is your distance slash R. Perfect. Now let's mark the surfaces. Let's say this is your surface. Let's make it dotted first of all. Let's make it dotted. Okay. And let's say this is a charge Q1. The charge Q1 will have a voltage of what? Negative V1. As you move forward, this voltage will keep on decreasing. Simple as that. Let's draw the surface of charge 2. The surface of charge 2 looks something like this. Like this. Let's make it dotted since it's the surface. Perfect. This chapter is just about to end if you can just listen carefully for the next 5 to 10 minutes. This is charge 2. Since charge 2 is positive, you will have a positive electric potential here. Positive V2. Let's draw the graph like this. Perfect. Again, how can you calculate the result? Okay, let me write down the key here as well for those who get confused. Blue line represents what? Electric potential. Blue line represents what? Electric potential of charge Q1. Red line represents what? Electric potential of charge Q2. Can you calculate the resultant electric potential? Yes. Somewhat like this. You can calculate the resultant electric potential somewhat like this. This is your resultant electric potential. Can you notice one thing? Here? That the gradient of the electric potential graph is never becoming zero. The gradient of the electric potential graph is never becoming zero. The graph of resultant electric potential is never horizontal or never has a gradient of zero. That means there will be no null points. At which point E is maximum? Okay, I will tell that as well. I will tell that as well. Let's wait for a minute. First of all, you need to examine that there are no null points here between unlike charges. Simple as that. Okay. At which point will the gradient be maximum? Let's see that. Let's see at which point the gradient will be maximum. For this, you need to realize that Q1 is a higher charge. So the curve at the starting, that is at point A, will have the highest gradient. C will have a lesser gradient than A. Perfect. So you can write it here. Gradient at A is maximum. Why? Because at A, the negative charge is greater in magnitude. Hence, a greater gradient, greater electric field strength, greater force. Where will the gradient be minimum? The gradient will be minimum when the graph crosses the horizontal axis. Here. The gradient will be minimum when the graph crosses the horizontal axis or x-axis. But please remember, this gradient at B is not equal to 0. There are no null points here. This gradient is not equal to 0. Any questions here, beta, you can ask away. If you have any questions, ask away. Now, let's say you aren't given the graph. Let's say you aren't given the graph. And let's say this is a point Z. This is a point Z. The total distance between the charges is, let's say, x. And the distance from charge 1 to Z is, let's say, r. The distance from charge 1 to Z is r. Perfect. How will you calculate the resultant electric potential here? The resultant electric potential will be a sum of both the electric potentials. But can you realize that charge 1 is negative? So our electric potential for charge 1 will become negative divided by the distance, that is r, plus kq2 divided by x minus r. Is this thing clear? Beta, ye cheez clear hai? Any ambiguities here? Yes or no? Tell me, beta, are there any ambiguities here? Yes, sir, clear hai? Acha. Now, we are just about to end this chapter. Just listen carefully. There are two cases that you need to remember. याद कर लिए, literally जिंदगी आसान. Literally जिंदगी आसान. Okay. First of all, you need to know what is electric potential energy. First of all, you need to know what is electric potential energy. Electric potential energy is the work done in moving a charge from infinity to any specific point. Electric potential energy is the work done in moving a charged body from infinity to any specific point in an electric field. Perfect, Wahab, but I prefer that you write this definition. Sir, what do you mean by that? But let's say you have a positive charge here. Okay, you have positive charge here, and you have one positive charge at infinity. This is at infinity. The work done in moving this small positive charge from infinity to any point, let's say x, is known as electric potential energy. Walaikum assalam Hussain. Walaikum assalam Hussain. Luckily, you have just joined at a topic जो हम शुरू से start कर रहे हैं. So just focus a bit. Electric potential energy बेटा क्या होती है? Work done in moving a charge from infinity to any point in an electric field. Let's say this is your source charge. Let's say this is your source charge. ठीक है, let's say this is your source charge. The work done in moving this source charge from infinity to a point x is known as electric potential energy. Simple as that. Perfect. Chalo. What is the formula of electric potential energy? Yep. ये मैं आंसर करता हूँ. I will answer this. What is the formula of electric potential energy? Electric potential energy is electric potential multiplied by the charge Q2. Okay, what are charge Q2, Q1 and R? Let's see that. Q1 is this source charge. Q2 is this small charge. The distance between the two charges is R. Your electric potential energy becomes this. Electric potential energy is equals to K Q1 Q2 divided by R. Simple as that. Nothing complicated. If you are asked or required in the exam to calculate the change in electric potential energy, how will you do that? Beta, agar exam mein you have to calculate the change in electric potential energy, which formula will you use? Simple. Change in electric potential energy is equals to change in electric potential multiplied by the charge Q2, the smaller charge, or the charge that is moving. 1 second. Okay. Now, let's move on to the most important scenarios that you will study in this chapter. Case number 1. Case number 1. Like charges. Please put a heading of like charges, beta. Like charges. Let's say you have a positive source charge here. Perfect ho gaya, sir. Let's say you have a small positive charge here. Please, I need your undivided attention here for the next 5 minutes. Everything will seem a piece of cake. This is Q1. This is Q2. Perfect. When you bring this positive charge towards this positive charge, When two like charges come towards each other, beta, what happens? Let's say this is point X. When two like charges come towards each other, what happens? There is a gain in electric potential energy. And this gain in electric potential energy is converted into what? Loss in kinetic energy. This gain in electric potential energy is converted into loss in kinetic energy. Okay. What is the name of the scenario? Like charges moving towards each other. What is the name of the scenario? Like charges moving towards each other. If like charges move towards each other, what will happen? There will be a gain in electric potential energy and a loss in kinetic energy. Perfect हो गया sir. Let's say you are given, one second, let me mark the position as well. Beta, at any point, if anything is unclear, just tell me, just give me chat में message, I will see. ठीक है. Let's say this was your point Q. Let's say this is your point P. Perfect. Now, how will you represent this, beta? And let's say the velocity initially was U. Now the velocity is V. You are moving towards. How will you represent gain in electric potential energy? Why is this a gain? Whenever two positive charges, one second. Yeah, you can say that. You can perfectly say that. Whenever two positive charges are moving towards each other, there is a gain in electric potential energy. How will you calculate this gain? Change in electric potential multiplied by the smaller charge, that is Q2, is equals to the loss in kinetic energy, negative 1 upon 2 into the mass of the charge into the final velocity minus the initial velocity. How will you calculate change in electric potential? The final potential Vp minus the initial potential Vq multiplied by Q2 minus 1 over 2m V square minus U square. Chalo, let's further move ahead. Now let's move on to case number 2. Let's also repulsive forces for stopping them, so tension builds up, okay, between, so potential increases. Can we say this for understanding? Yes, you can say this for understanding, Nabia, but you will never write this as an answer. Perfect. Okay. Now just pay close attention, beta. Attention आपने यहाँ पे ही देनी है. Just see what happens. In case number 2. Let's say like charges are moving away from each other. An interesting scenario. Let's say like charges are moving away from each other. Let's say you are initially at a position P and now you are at a position Q. One second, let me draw it again. Let's say initially you have a positive charge here, you are at position Vp, you are moving away now. Perfect. And you arrive at this position, that is Vq. Your velocity here was U, your velocity here is V. Perfect. Now what will happen? Very good, Wahab. Now just this will change. This upper line will change. Now you will say that there is a gain in kinetic energy. As like charges move away from each other, there is a gain in kinetic energy and loss in gravitational potential energy. Beta, any ambiguities here you can ask me right now. Gain in kinetic energy. Oh, what is happening here? There is a gain in kinetic energy and loss in gravitational potential energy. Any ambiguities here? Yes. Loss in gravitational potential energy. Any ambiguities that you have here, beta, you can tell me right now. Koi masla idhar. Now let's move on to unlike charges. Let's see how unlike charges behave. That is case 3 and 4. Oh, sorry, this is case 2. Let's change that as well. Now let's look at case number 3. When unlike charges, when unlike charges move towards each other, when unlike charges move towards each other, let's see what happens. But at any point, I am repeating again and again. कोई सवाल हो, just shoot away your सवाल in the chat. No need to hide it with you. Sir, loss in gravitational potential energy. Oh, sorry, my bad. There will be loss in electric potential energy. ठीक है ठीक है ठीक है. चलो ये मैं correct कर देता हूँ. आप clear है loss in electric potential energy. This is your positive charge. Let's say you have a charge here, negative, that is at infinity, and let's say it is moving towards you. Okay, towards the positive charge. Something like this. Let's say this is your position P, this is your position Q. What will happen? As you move towards an unlike charge, attraction will happen. There will be a gain in kinetic energy and a loss in electric potential energy. Is it clear? There will be a gain in kinetic energy and loss in electric potential energy. Beta, is this clear? Yes or no? Is it clear what happens when unlike charges move towards each other, or should I explain it again? Case 4 पे बढ़े. चलो, let's further move on to case number 4. What will happen if unlike charges move away from each other? Unlike charges. And this is not written in the notes. So ये copy कर लेना if you get a chance. Unlike charges move away from each other. Let's say this is a positive charge. And let's say this is a negative charge. This is moving away from the positive charge. What will happen? What will happen? Your kinetic energy will decrease, because as you are moving away, what is happening? Forces of attraction are decreasing, velocity will decrease, kinetic energy will decrease, and there will be a gain in electric potential energy. All clear